Yes, yes, 100%. I agree with Tesla.
I'm with you. I'm with you there,
100%.
Cyrus. Okay, cool.
E equals whatever the environment, the mass can absorb from the environment. And look,
You know
look
that
up
E
the
equals
speed of
MC
light
squared was
equation.
created by Einstein, right? Like the E equals MC squared relation is not even from Einstein. He stole it from earlier work.
Whatever.
Poincare, I think he stole it. But if you look at the speed of light equation, c equals 1 over the square root of epsilon mu. So there is conditions to the speed of light. Okay, so it is conditional. It is not constant. Okay, as long as these conditions don't change, it remains constant. Yes. So we just treat it as constant.
Do you know why E equals MC squared exists? Like, do you know what that represents? The normal equation for kinetic energy is 1/2 mv squared, right? That's kinetic energy. You just double that and you assume it's all, like, you encompass all the energy. So, because you got potential and kinetic. So 1/2 plus 1/2 is 1 whole. You got mv squared. V in this case is c. That's why it's E equals mc squared. Because the speed of light is the wave velocity in the ether, and matter is made of ether.
I had to backtrack the whole way on that shit. So does light conserve momentum? Yes or no?
Yes.
Everything conserves momentum.
Then why isn't light going c plus the speed of the train if we shoot it from the back of the train to the front of the train?
The speed of light is constant.
Yeah, that means
There's the dog man.
That means it's not conserving the momentum. Yeah, that means it's not conserving the moment. If it conserved the momentum, it'd be going c plus the speed of the train.
Yeah, if Newton ruled if Newton was true, Newton is not true at high speeds.
It conserves the momentum by slowing down the person in that reference frame. That's how it conserves its momentum. That's why time changes. I'm not. That's it. That's why time. Listen, let me explain.
Glover's gone wild.
That's why time changes when you get close to the speed of light.
Time has nothing to do with momentum, by the way. Like if C is
thank you for letting me finish and just blatantly interrupting. Hush a minute. When something is moving and you throw a ball, like if you're on a truck speeding down the road and you throw a ball will have the speed of the truck plus the speed you throw it. But light don't work that way. Light travels at the same speed. So if it leaves something that is moving forwards at a speed already, it won't gain that something speed plus its own.
It won't conserve the momentum.
No, it does conserve the momentum because in the reference frame of the light, time slowed down to make it speed up or seem to have sped up. And that's
how do you prove that time slowed down?
That's what Einstein says.
How do you prove that time slowed down?
They've done experiments
without using circular reasoning. Yeah, can you give me like evidence?
Yeah, I think like the clocks on the plane when you fly from one side of the earth and then fly back, how the clocks are different.
Yeah, so
that concept.
So you think that a man-made clock is more constant than time itself? Then that's what you're saying.
Yeah. The man-made clock works off of atomic material, which is as accurate as we can find in this universe.
Okay, so you're saying that everything's made of atomic material, by the way, but you're saying that the clock is more constant than time itself.
Yeah. No, I'm saying the clock is. I'm saying it is as constant as time itself.
No, it's more constant than time itself because the clock.
No, what do you mean more constant? It's measures time.
Reference frame. It still thinks it's ticking the same, even though it's ticking slightly slower than the other clock, because in its reference frame, it is ticking normally. But to the other reference frame and the reference frame on the ground, it ticks slower. That's why it slows down when you fly in one direction.
You say that time itself changes and it's arbitrary for everyone everywhere, and I just say that the clock experienced a physical change in its clock rate. And it's a physical effect.
What the fuck does that mean? You just made something up and put some words.
It's a physical effect. I didn't make anything up. Why don't you?
It is a physical effect.
I'll explain it if you be quiet long enough for me to answer.
Let him explain it.
Let him explain it. Let him explain it.
My gosh. Like, that's what you sound like, bro. Shut up. So anyways, you have a clock. How does it count time? Through a physical process. What's that physical process? Do you know?
Yeah, it's counting the transitions in 2 hyperfine levels. Yeah, about 9 billion a second.
Atom.
It's counting the transition rate, the energy transitions of the cesium atom. Okay, which happen for a cesium atom that's at rest. It happens at a fixed rate. But when the cesium atom is put into motion,
at a fixed rate.
That's why you have to cool it. That's why you have to cool it down to as close to absolute zero as you can get it, and that's what the clock does.
And when the cesium atom is put into motion, suddenly that tick rate changes. That clock rate changes.
Why?
But that's why we slow.
I'm going to get there. So now you must ask the question. Okay, what's
causing? Well, stay a point and let us respond. Let us answer. Like, don't go into a bunch.
Yeah,
of
but
points.
he asked why.
He
asked him a question. He's going to give his explanation of why it slows down in his paradigm. So let him explain it. Thank you, guys. Jesus.
Well, we both can explain it.
Because the cesium atom, its electrons are experiencing orbital changes, energy level changes, right?
Yes.
And so these electrons, which we count that rate, these electrons are solitons. They are wave packets in a fluid. They're standing waves de Broglie waves in the ether. And so when the soliton moves through the ether, just like any soliton moving through any medium, it will experience an inertial effect based on the ratio of its velocity to the actual wave speed itself.
So what?
The problem is there is no Aether. There is no Aether. Michelson Morley,
so you just conjecturing that doesn't make it true.
No,
doesn't
hold on, proving it.
Proving it. No, give me 10 seconds. Proving that Aether doesn't exist happened 130 years ago. Get on
NASA's just going to spurg out instead of let the conversation be open.
Don't argue something that you can't prove. Argue something that exists in reality. One of the things that they do is, yes, when at room temperature and at hotter temperatures, the atomic material like cesium does move around a lot more. It is dependent. But one of the things the clock does is it chills it down to almost absolute zero. That's how one of the best clocks we got on Earth works. So that means that atomic molecule or atom is not moving at all. It's basically
it doesn't have random thermal vibration. It doesn't have random thermal vibration. It's the electrons are still moving. The electrons are still moving at the same rate. But the point is that rate, that tick rate, changes as a ratio of the clock's velocity against the speed of light. And the reason for this can be explained perfectly intuitively as a physical mechanism by invoking the laws of fluid dynamics, fluid mechanics, because that's what happens to solitons moving through fluids.
You're just making stuff up, dude.
No, I'm not.
You just made this shit up.
Appears. The exact same ratio appears in fluids. When you have a soliton that is moving through a fluid, it will experience, because what happens is, here's why. I'll explain why it happens.
You have evidence for this? You have an experimental evidence?
Yes, look up the other 99% of scientists. Don't just look up the one odd one. Look up the rest of them and what they say.
I mean, this has been tested thoroughly. If you have evidence for this, you should. If you have evidence for this, you should submit it, because this is Nobel Prize winning stuff.
Oh my gosh, it's things that have been established for over 100 years.
No, it hasn't been established. It's been unestablished.
Interrupt me. Oh my
because
gosh.
Because it hasn't been established, because you're lying your ass off right now.
NASA. Come on,
Control your autism, and please just wait for other people to speak. Thank you.
But you're lying, but you're saying this, you're
I'm
muting him. Until you can respond. Until he can fully explain it, then you can respond instead of just poo-poo on it every time.
Make him leave, and then we'll lose the conversation.
Go ahead.
Yeah. So if you look up the Prandtl-Glauert equations, they express the effects upon an object moving inside of a medium. Now, when we compare this to the equation, Prandtl-Glauert, look it up. It's fluid dynamics. It's based on it's the same equations they use for things moving through air, for like airplane wings in air, for example, or things moving through water. It's for any fluid. But Prandtl-Glauert, Prandtl-Glauert.
But that has nothing to do with what's going on in atomic
clock. I'm going to explain why it does. So, because in my paradigm, I presume there's an ether, and if there is an ether, then there would be certain necessary predictions that must be made for its behavior. So I predict that it would follow fluid dynamical behaviors that we model in other fluids. And so I would invoke the Prandtl-Glauert relation and show how it would predict that as an object moves through this fluid, so in this case a soliton, which is, once again, I defined an electron as a de Broglie wave soliton moving through the ether. The faster it moves, remember, as it moves forward, it has to push the ether in front of it out of the way. And the faster it moves, the faster the ether in front of it has to get out of the way. Well, the more speed that the soliton has, the more difficult it is for the ether in front of it to get out of the way, which causes an inertial response because the fluid in front of it has inertia and it pushes back on the soliton. This causes the soliton to experience the pressure from that inertial response, which causes it itself to experience on the particle level, a length contraction. And also, in order for it to oscillate, which it's oscillating at a constant rate, right, when it's at rest, in order for it to maintain that oscillation rate, it has to push harder than it normally does because there's the additional inertia of the fluid in front of it, which causes its oscillation to slow down. That's the physical explanation, and the equations that model it are identical to the Lorentz symmetry.
Well, I watched a good thing the other day, a good video the other day, where they talked about how electrons and how photons and stuff that seem to be a particle and a wave, how it said they were just like an impression or a hump on some kind of like background medium that exists everywhere, and they act like they're like a particle because they're that hump that moves on that background medium. At the same time, they act like a wave because they can divide up and everything else, because it's like they are just a wave that's moving through, a flat laid blanket or something. Like if you make a wave, it'll move down through there. So you would see that as a fluid. If it hits something, it'd act like a fluid, but then you could also picture it as a particle because it's just one single object. It's like a wave, but they're talking more like just a hump in a background medium. So to me, that background medium would be the ether. That's what I think. And then if that's a particle, that's almost exactly what you're explaining, like how it's moving through a medium that is like hindering it and doing things to it. I'll try to find that video and post you a screenshot out where they showed it at. Like what you're saying matches a lot to what they said. They just said it in a different way, in my head anyway.
Well, that particle is a soliton, right? So what a soliton is it is a wave packet made out of the fluid that it's moving through. So just imagine an electron, since it's a de Broglie wave, but it's also it's like a bundle. It doesn't come apart. It's like one solid bundle. So it's like a wave bundle that stays together as it moves through the greater body of the fluid.
Yeah, that's what I'm talking about. It's like a hump. So it's not an individual particle. It's part of the medium, but it's like a hump of the medium that is moving, in a direction or an indentation or impression or something.
Yeah, and the soliton, and there's if you give me 1 second, I'm like bringing groceries in. When I get up to my computer, I'll give you the other. I can't remember the name of the other equation. It's like a PZG, or I gotta look. It's like a foreign name. I gotta pull it up. But I have it. But that other
equation, video.
I found it, and it's actually from NASA. NASA actually quotes this in 1947.
Quotes what?
What you're talking about, the Prandtl-Glauer, Prandtl-Glauer method for three-dimensional flow problems.
Yeah, no, it's what models fluid dynamical behaviors in any object moving through a fluid. And the cool thing is you can use it on airplanes or you can use it on solitons. The only difference is if you use it on like an airplane wing, since an airplane wing is a foreign object, right? The airplane wing is moving through air, but the airplane wing is not made of air. All you have to do to account for that is you add an extra term, the leading term, you add a 1. Because it accounts for the static in the Taylor series expansion. You add a 1 because the 1 accounts for the static pressure. There's static pressure on the foreign object inside the medium. But for a soliton, since the soliton is made of the medium, it doesn't have any static pressure and it doesn't need the leading 1 term. So you just start with the regular like 1/2 x plus all the regular Taylor series terms that show up in Thomas precession. So it actually becomes identical. It literally becomes identical to Thomas precession, like the thing that explains the way that like in spin orbit coupling, when you have an electron orbiting a nucleus, and as it comes around, it has a 1/2 precession. They try to explain that through like time dilation or relativistic geometry, but the same exact thing happens. It's in the vorticity equation in fluids. Same thing happens in fluids. It's identical. And it's caused by the same thing. But
I didn't hear him say it acts the same way as in fluids, but I did see. It sounds a whole lot like what you're talking about.
Yeah, makes sense.
And this explains relativistic mass increase. It's not really mass. It's inertia because it's picking up the extra push of the medium reacting back on it as it's trying to push it out of the way. So it makes the particle feel heavier or have more energy, right? It takes more energy to move it faster because the faster you move it. Oh, there's another thing too. There's a Larmor radiation. Larmor radiation explains how the faster you move a particle, the more it radiates energy away. This is an analogy to a wake. A wake in any kind of fluid, like a wake on an object moving through water. When you accelerate a particle, when you accelerate an object through water, it sheds a wake behind it. Particles do the same thing, and through the ether. And the faster you accelerate them, the faster you move them, the more energy they radiate. And that's why it's extremely difficult to get particles up to the speed of light, because the higher of a ratio of the speed of light that you move with, the closer to C you move with, the more energy gets wasted through Larmor radiation than actually goes into the velocity. So that energy just exponentially gets dumped into the radiation as you go faster, instead of getting applied to the actual movement.
Yeah, that same kind of effect is actually what you'll see airplanes, like little small planes, will experience by following a plane that just took off. If they take off too soon after the plane that just took off in front of them, sometimes they'll hit I can't remember what it's called, but they'll hit something that's like a vortex, and it'll cause their plane to just completely go 90 degrees. Can't remember what the hell it's called now. But all of that makes sense when you have a physical medium being enacted upon, right? So why would light be any different? Why is light always treated special? Like there's always special pleading when it comes to the properties of light. Doesn't make any sense.
Because they have to force it to be different, because they did that one experiment that one time and they didn't measure the velocity they wanted to measure. So they got to literally reinvent all of physics to not admit geocentrism because their philosophy is satanic.
Yep. Earth is not in a special place. You better believe that.
Yeah, they were so adamant that Earth does not hold a special or unique place in the universe, in God's creation, that they were willing to literally get rid of everything that we'd ever known in physics and reinvent it all and make knowledge and experience itself relative, and tell people that logic itself doesn't apply anymore. We're going to invent crazy explanations to things like the double slit experiment, so that you can say like it's okay for A and not A to be true at the same time.
Zanuck really just tried to
mind
do that to
rape
me
an
earlier
entire
today.
generation.
Zanuck really just tried to do that to me earlier today.
I'm watching a Veritasium video on exactly what what we've been talking about, or what you were talking about a while ago, and he's explaining like a lot of what you're talking about, and it's a Veritasium video.
Well, the thing is fluid dynamics was known and established and mapped out long before relativity ever was. And when you look at the Prandtl-Glauert relation, it has the exact same factor as the Lorentz factor. So like the Lorentzian behavior is literally just Prandtl-Glauert behavior in the ether.
But it has a physical medium behind the Prandtl-Glauert, is what you're saying.
Yeah, it's the Prandtl-Glauert applied to the ether.
Right here, I'm going to post the image in the chat. I want y'all to look at it. And imagine that this is just some kind of background field when you see the picture. I'm posting right now. When you see the picture, imagine that. Come on, damn it. Pull up. Hey, let me pull the live stream up.
Yeah,
there it is.
Cole,
okay, here
I
we go.
would actually accept it more so than most Globers about a physical medium being the reason for propagation of light.
All right, look at this picture. Now you see the grid. Now imagine that grid goes in all directions. It's not just flat like a sheet. It would be in all directions, but it would still work. It's just some kind of background medium, which would be basically the ether. This is like what they're saying an electron or a photon or something is. It's just a hump, like, or a bulge in this background medium that I would say is the closest thing to ether that we know of. And as this thing moves, it moves just like a energy would across, this background medium. And that is what we think of as a particle. But since it's just the impression of the background medium itself, when it hits something, it could split, it could transfer its energy into another wave and create two waves, or come together and create a bigger wave.
Exactly.
And that would be what we would see, what we experience as a particle. But since it's part of the background medium, it would act also as a wave. So you know what I mean? And that works.
Yeah, so all that matter is like matter's made of particles or whatever, but all that particle is it is a portion of ether that is held into a topological structure. It's held stiff. It's held in its structure is held in place by its rotational inertia. So every particle has spin, and they're spinning at like mind-numbing speeds that you can't really even measure. And that the rotational inertia, it's like a gyroscope. It's basically like every particle is like a little ether gyroscope.
Well, maybe that's why the speed of light has a limit, because there's only so fast it can move through that.
Every it's dictated by the elasticity and the stiffness and the mass density of the medium, like every other medium.
Yeah.
Hence the
that would answer a lot of questions.
Yeah, that's been the Ether Boys' position for a long time. That's what Witsit means when you have to make less assumptions, and it makes more sense logically that you have a background medium. But the problem with acknowledging the background medium, then you would have to go back and acknowledge the Michelson-Morley. And if you do that, then Earth is stationary and the universe is geocentric.
I'm going to post that video, by the way, if anyone wants to check it out. It goes all through a whole thing about it. Where'd NASA go? Did he leave?
He's just gonna be like, "Nuh-uh."
Well, I don't care. I'd like to hear
no ether.
I'd like to hear his side of it. I still like to hear other points.
You want to hear his points? I could tell you his points right now.
y'all just don't like him, do you? At all?
No, he doesn't know how to have a conversation like a normal human being.
It's funny. I get your frustration, bro.
Yeah, it's fucking like, dude. Anyone can fucking look up on Google relative simultaneity, get the spoon feed explanation for why the speed of light is constant. We're not retarded. We can all do that. The point of coming in here is to have discussions about alternative ideas and topics and see where they lead and see if it actually holds water. That's the point of thinking, right? That's the point of having critical thinking.
To me, thinking there's some kind of background medium, like we were talking about, makes sense. I mean, I could imagine there's some kind of ultimate, because supposedly gravity exists all around us and we don't feel it. So why can't there be some other background medium as well that allows things to propagate like light? And that makes much more sense. That answers a really good question about how something can act as a particle and a wave at the same time.
Oh, sorry,
it's a really good explanation.
Sorry, I had to jump out of here for a second because I was bringing the groceries in. I just went and got a bunch of meat and stuff. But give me just 1 second, and I will share something with you. Is it Cole I'm talking to?
Yeah, Ian Rigger.
All right,
Rigger.
Or who did I say? Who? No, sorry, didn't mean to call you Rigger.
All right,
I sound like Rigger.
No, I don't know why. I don't know why I said that. It just popped out of my mouth. Come on.
I have to claim that I was wicked smart to be Rigger. Okay.
So I have some notes
Beast.
here. I have some notes here that I made from when I was doing this research. So just let me read to you a little something from my notes. So like I've been digging pretty deep, and I've honestly been amazed by like how analogous the comparisons are between fluid dynamics and relativistic phenomena and other things, especially like in like relativistic quantum chemistry and electrodynamics. Things like the vorticity equations and the Prandtl-Glauert equations and Thomas precession. You have the Korteweg-de Vries, the KdV equations, and relativistic mass increase, energy inertia increase. You have wave wakes and Larmor radiation. You have the Magnus effect and the Lorentz force, which are like mirrors of each other. Even the equations are. And then you have soliton compression and the Lorentz contraction. And the mathematics of these are identical in almost every case. So
You sharing your screen?
No, I'm just
Oh.
Yeah, I'm just talking. So you can build a bridge. Like if you look at the Prandtl-Glauert factor, you can build a bridge from that directly to the Lorentz factor. They're the same factor when you look at the terms in the equation. And you can show, like I said just a second ago, that the Prandtl-Glauert relation directly results in the Thomas precession equation if you just get rid of the leading one term in the Taylor series of the Prandtl-Glauert. And the leading one comes from static pressure on a foreign object in the medium. So since the soliton is made of the medium, it doesn't receive the static pressure, so you drop the one. And then it becomes identical to the Taylor or Thomas precession's Taylor series. And then the Korteweg-de Vries equation, it describes the behavior of nonlinear, dispersive, but non-dissipative waves, which include solitons. So regular waves, if you think about it just like a regular wave, these waves get torn apart over time by dispersion, which is the wave spreading, and nonlinearity, which is the wave steepening. But solitons strike a perfect balance between these two, so they create a localized bundle of wave energy that moves as a single unit. And the KdV equation, Korteweg-de Vries, KdV, the KdV equation shows that a soliton's amplitude is directly linked to its velocity. So the more energy it has, the narrower and faster it becomes. And that mimics the Lorentz contraction, right? And the relativistic mass increase that you see in electrons. When you take the vorticity equations from fluid dynamics and you apply the vorticity to a KdV style soliton, because the soliton is not a foreign object, it's made of the medium, right? And it doesn't have a solid core, then the rotation is entirely applied to the phase of the medium. So that precession that you see in Thomas precession, right? That 1/2 factor, which is identical to the vorticity equation and identical to Thomas precession at speeds much less than c, that appears naturally because the rotation of the soliton's envelope has to be slower. It has to lag. It has to lag behind the rotation of its internal phase in order to maintain the stability of the soliton. So the outside's rotation has to lag a little bit for it to stay stable. Now, as it moves, like translates, of course, moves through the ether, the medium. Larmor, his formula describes how it radiates power out. So when that electron accelerates, it is not able to instantly perfectly adjust its structure. There's a lag. It doesn't respond instantaneously, right? There's properties of the medium. It has stiffness and all these different things which determine how quickly it responds. So since it can't respond instantly, there's a small lag. That lag in its response results in it shedding energy, which we call that Larmor radiation in classical electrodynamics. And in fluid dynamics, it's called a wake, as I said. But in a fluid medium, when this soliton accelerates, what actually happens is it creates a pressure imbalance between the front and the back. So as it speeds up, the leading edge, the front of it, compresses the medium. That increases the local pressure at the front. And then the trailing edge leaves a low pressure zone behind it, okay? So there's a pressure differential. And if the acceleration is high enough, then the tail cannot keep up with the head, and a piece of the energy gets pinched off of the back, and it propagates out as a secondary wave, as a photon. And there's an equation that describes it, the Larmor formula. But just like in that formula, fluid wave radiation also scales with the square of acceleration, because the slope of the pressure gradient in that fluid, which is proportional to the force, has to be squared to calculate the energy flux. So that's if you can't see the equation, so that might not matter much right now, but that's how it works out. And then there's a 2/3 factor, which comes from the geometric relation to the surface area of a sphere, because the radiation, so the energy that radiates spreads in all directions. It's like a spherical shape that it spreads out in. Every direction equals sphere. So when you integrate the energy flux of that, of a spherical distribution shedding in every direction, you see that only a fraction of the work done by acceleration escapes as a wake, which is, turns into a wave that radiates as a photon. The rest of that energy stays present as added inertia, reactive energy. It stays present in the soliton, because it's the energy of the medium pushing back, right? A little bit of it radiates out. There's a photon sheds away, and the rest of it stays in the soliton and gets picked up as a mass increase. Now, as v gets close to c, right, it speeds close to the speed of light when we get to relativistic speeds, they say. The radiation power scales up exponentially. So the closer you get to c, the more energy sheds away. That's the reason that you need infinite energy to accelerate an electron to the speed of light. Because the closer to the speed of light you get, the more energy you end up radiating away instead of adding to the velocity. So that makes intuitive sense, but also because how could you possibly accelerate?
Yeah, I agree.
How could you possibly accelerate a wave bundle of the medium? So like there's a bundle of medium, right? How could you get a wave bundle of medium to move faster than the wave speed limit for a medium? You couldn't.
Right.
It doesn't even make sense.
It'd be crazy if it turned out the whole time that there was something known like as an ether. After all these years of them saying that they wasn't.
It doesn't stop there, dude. Well, it's even crazier when you think about the Lorentz force. So the Lorentz force, right? It's the force experienced by a charge, an electron moving through a magnetic field, right? F equals QV cross B. Okay. If you treat the magnetic field as the vorticity of the ether, right? Because when you actually look at Maxwell's equations, the definition of a B field, B equals the curl of A. So B just describes the rotation of the A field. So if the A field is the ether, and you just think and you say, okay, so B describes the vorticity of the ether, then the Lorentz force becomes mathematically identical to the Magnus effect. Okay, or also sometimes it's referred to under a Kuta-Joukowski lift, but it's the lift force experienced by something moving through a rotating field. So if you guys know what the Magnus effect is, it's how, like, if I take some kind of sphere.
Coriolis.
Well, if I take let me say I take like a tennis ball or something, and I spin the tennis ball really fast, it will actually create lift if it moves through an air current, because basically you have the rotation of the tennis ball, and it's interacting with the rotating field of the air that it's moving through. And as these two terms add or subtract, they interact with each other, they cross one another, it actually creates lift. It's mathematically identical, because Lorentz force F equals QV cross B. Magnus effect is F equals rho V cross gamma. And so this explains the deflection of electrons moving through a magnetic field, because they experience lift due to the differential pressure between the two vortex fields, the vortex of the spinning soliton and the vortex of the curling magnetic field. On one side of the soliton, the spin velocity adds to the flow, and on the other side it subtracts, and then you apply Bernoulli's principle, because Bernoulli's principle says the side with higher velocity has lower pressure. So there's a pressure gradient that creates a net force, and it acts perpendicular to both the velocity and the axis of rotation. That explains why the force is perpendicular in the Lorentz force. That ties everything back together perfectly. It goes back to the 1/2 ratio of precession, just like how we see the force in the Magnus effect depends on the circulation term gamma. We see the same fluid mechanics applied to precession. Since the effective rotation omega is half the vorticity in the vorticity equation, then the lift generated by a wave packet, an electron, is scaled by the same 1/2 factor as in Thomas precession. So the Taylor series handles all those terms all the way past the 1/2 as the velocity increases, and it causes compression of the ether, and that compression responds, it adds inertia, requires more energy to move faster. It also, the last thing it explains spin 1/2. So it's known in physics that electrons have what's called spin 1/2. It's a fancy term. It basically says that instead of taking one
heard of spin, but I've never heard spin 1/2.
Yeah, instead of it taking one full 360-degree rotation for an electron to turn around back to its original orientation, it takes two of them. It takes a 720-degree rotation. It takes two full turns. Now that seems counterintuitive, and they just explain it abstractly, right? But what if you apply this to fluids? There's also a perfect analogy. So in fluids, this exact spin 1/2 happens in Mobius-like flows. So you can watch animations of like a sphere that has a Mobius strip attached. Look up at what a Mobius strip is.
Yeah, I know it is.
But they require 720 degrees of rotation to return to the original orientation. And I can actually copy a. I'll put a link. I'll put a. Real quick, I'll put a link to the video.
It's just a loop with like a belt, but you invert it.
Or you ever see the
There you go.
See the Mobius? You ever see the Mobius strip thing? It can just stay in flight constantly as long as you keep like an angled like board behind it. You ever see the guy demonstrate that?
Check the video I just put it in the chat. It shows a visualization that explains it perfectly. But if you look at like this in fluids, this spin 1/2 property happens in Mobius-like flows. And one example of a Mobius flow is a toroidal toroidal vortex, because there's a coupling between the internal flow, which is poloidal, and the external flow, which is toroidal, and that gives you a vortex soliton that's effectively a tiny gyroscope that's made out of the medium it's traveling through. So I believe that electrons are actually solitons that are like toroidal vortex solitons that act like little tiny gyroscopes, and then you piece all of these together and into bigger and bigger structures, and you get atoms and molecules and so on and so forth. But using these fluid dynamics relations, you can use classical mechanics to model the effects on the electron as it compresses the ether and it gains inertia and it radiates energy out as it processes, as it spins, as it gets deflected in a magnetic field like a vortex field. It's to me, bro, it's honestly amazing to see like how fluid dynamics, just you apply fluid dynamics and it's perfectly analogous and it accurately describes all these behaviors that are typically attributed to like the geometry of empty space-time.
And you don't have to have all that weird stuff like saying something's a particle and a wave at the same time. And
correct.
You know what I mean? Like that's what I was thinking when I saw, especially after watching that Veritasium video. It made more sense in my head to say that it works like they were saying, like something on a background medium. Well, that background medium would then be the ether.
Yeah, and it explains time dilation too, like the whole clock pair, the clocks changing on atomic clocks, because the reason that the clock slows down is because since it's moving through the medium and the medium's pushing back on it, it compresses that soliton a little bit, and the soliton now requires a little bit more energy in order to oscillate, but it only has as much energy as it has, so that extra stiffness essentially that it experiences causes the oscillation to slow down, and then your clock ticks slower.
It can only travel as fast as it can move through that medium, and that medium only let it go so fast, so it won't maintain the momentum of whatever it left from, even if that had speed, because it can only travel at a certain speed through that background medium.
Yeah, so this gives not only an intuitive but a physical explanation for things like Thomas precession, for example, because it actually gives a real source for the torque on an electron. Like when an electron precesses as it orbits, they don't have an explanation other than to say space-time, but they don't have a source for torque. There's something known as the Mansour-Pore paradox, and it explains that perfectly because now you have a source for the torque. Because in order to explain the Mansour-Pore paradox, you have to have this paradoxical concept of hidden momentum in order to explain it, and that's just nonsense. And so, like, it's just like, dude, I started digging in this stuff like not that long ago, a couple weeks ago, and yeah, it's literally every fluid dynamical equation that I look up in here applied. Like some of them are literally built for solitons, like the KdV. And the Prandtl-Glauert can be applied to them if you just drop the static term, and then it literally perfectly matches like relativist or quantum electrodynamics.
Piezo. Only you could casually drop 6 to 7 new terms in a conversation, and it'd be completely relevant to the same topic.
No worries, bro.
That was insane. What the fuck paradox did you say? What's it called?
Mansour-Pore paradox.
Okay. Someone should timestamp this in the recording so they can go back and like actually listen to what he's talking about.
Yeah, here I'll just tag you, Beasticles. I'll tag you, and then I'll just give you a list of terms that came up here. 1 second.
But yeah, Cole. There's a lot less incongruent thinking when you have a background medium.
Yeah, I agree. It's just funny though that things like that would then represent themselves as like electrons or protons or photons or neutrons. Or even now they got quarks and everything that makes up this stuff. But the things we're talking about are the smallest things that can possibly exist. That's what would make up the background medium. Like, in my opinion, it would be like the base level of the simulation.
You could say that, I guess.
I had to say that.
Or light.
I feel like things just get smaller and smaller, and I just wonder if there even is a thing at the bottom, or if we're not just part of. Like, what if our entire universe made up a quark in a larger atom, and things just there was no end to smallness and largeness. It just went on forever. So we could literally be like a quark inside of a proton, inside of in the body of an atom, and something that makes up something material far bigger. And we're just, you know what I mean? But to us, we see it as our entire universe, but it could be just something very tiny in the next universe up, or the next whatever's going on, bigger. Because if the universe is something that just pops out of like whatever's it came from, then it would have to be like there would have to be something that is doing it. So there'd have to be some type of other wherever reality or whatever you want to call it that these
Oh, nice.
universes seem
Piezo
to pop
tagged me
out
in.
of.
Grab
You know what I'm
that too,
saying?
Cole.
What's it?
Look on the chat.
Get back here.
I'll tag you to reply so you can get it too.
I posted Witset's logical questions about Mickelson Morley for whoever was saying that all it did was debunk the ether. They should answer that.
Oh, that was NASA's show.
Why Cole sounds like a flat earther.
Yo, but real quick, let me take a quick survey for anybody that was listening. Was the whole medium fluid dynamic explanation of quantum electrodynamics intuitive
You're just a liar.
and coherent?
No, you're just
coherent?
a liar. You're a liar. The ether's been disproved. You're a liar. You're a liar. Yeah, do you see how we would never have gotten to that conversation if I didn't mute that guy?
You don't know what the papers are saying, reference frames, refraction.
Yeah, that conversation would have never existed if I just let that guy continue. Yeah.
I just like that idea.
True physics, bro.
I just like that idea, the way that we was talking about. I like the way that works.
Well, you were talking about simulation, right? Like,
no,
you heard the idea of...
I'm talking about before that. I just mentioned simulation. Be silly.
No,
I'm talking about.
I was going to add on to it. No, I was just going to add on to it. So the image of God, like we were made in the image of God. Well, if you think about like the if we're in a torus field, right? Like in terms of, at the north, there's actually, that's actually a vortex. There's actually a vortex there. If there is an ether wind or ether drag, if you will, right, that follows sidereal rotation, and then you can actually look at like how our bodies operate, and it's basically like a toroidal. Like if you were to spin your body,
flower
right?
Pattern.
Yeah, the flower of life pattern, exactly. Like, kind of makes sense.
It's also how the planets move. It's the orbital path of the ISS. It's a lot of things.
Yep.
You just take the top-down view over the North Pole. It's what everything looks like.
Exactly.
But yeah, dude. When I say classical mechanics, I like to give this disclaimer before I get strawmanned by people. The classical mechanics is disproven by relativity. What I mean by classical mechanics is that everything is able to be explained mechanistically, and everything follows the principle of local action. That's all classical mechanics was ever intended to mean.
Local action meaning scalable, right?
No. But the principle of local action meaning that entities only act upon one another where they are located.
Yeah. You don't have quantum mechanics is crazy.
There's no such thing
In
as
a lot of
action at a
ways.
distance.
Right, because hence why if there's a medium between the thing that's distant,
Right.
it's technically local.
Right. Correct. Yeah. The medium is local there and there at both points, and you touch it here, and it pushes the influence through the medium and touches it there. Right.
Got it.
If I want to push my desk, I either have to touch my desk or fan the air really, really hard so the air blows across the desk. But if I'm in a vacuum and I'm here and my desk is there, I can't possibly affect my desk, right? Not unless there's something in between us that's touching us both. Principle of local action. And by the way, the principle of local action is just like unambiguously true.
Right. There's no special pleading involved.
Yeah, and that gets into a separate conversation, but based on this, logic is able to be consistently applied to physics and science, which it always was. They actually create illogical applications of, well, improper or erroneous applications of logic to science in a lot of the quantum paradigms because they allow for contradictions and stuff like that in logic.
Well, how then? I mean, I was thinking about that, but then they build like what do you call it? An atomic computer or whatever. What do they call that?
Quantum computer.
A quantum computer, and they do use 3 different states.
Never been proven to actually exist.
But it does work. No, it's been proven to exist.
There's different.
Show me.
There's different types of quantum computers. There's only one type that is truly what I would call an actual quantum computer, like true to its name, because they've invented a lot of new like fancy analog computing. Basically, is what they've done. But true quantum computing, as it was originally like named, is computing that's based on quantum state superposition, and there is no quantum state superposition computer.
Exactly.
You know why that'll never happen? You know why that's never going to happen? Because the algorithms are the bottleneck.
Yeah,
as much
that's
as
what they
do with
say.
the hardware, the software is going to brick them.
They can't write software for it.
It's because quantum state superposition doesn't exist. There's only wave superposition. You can't have superposition of particles. You can only have superposition of waves, right? So like waves can cross over and add together or subtract from one another, right? 2 waves in the water hit each other and you either make a taller wave or they cancel out. But you can't have two. You can't have 2 marbles in the same spot. They'll smash into each other and bounce off.
Yeah. So maybe though what they're thinking is like a quantum state. Maybe it is just like the waves we're talking about, but it still works because they figured out how to model something that is not correct, but it matches what is correct.
Well, the other ones, like I said, don't use quantum state superposition as the backbone. They use other methodologies for their process.
It's still classic, though. It's still classical computing, though. At the end of the day.
Yeah, in order for them to create a quantum state superposition computer, they would have to actually change it from being like driven by like a binary set of data where there's like on off or whatever 1 0 like based on it either it's there or it's not there, and they would have to basically be able to measure amplitude of the wave and say, oh, based on some kind of function, we know that like this amplitude is a superposition amplitude, so we have the third state here based on superposition. But if all they're doing is measuring like an electric field or something like that, then technically they wouldn't know that it's
just
superposition. Yeah, so it's like they would have to just like basically build it into the system and have it be like amplitude dependent as opposed to just on off.
Either way, it's impossible, Cole.
I've watched quite a bit about it though. I mean, I've watched several things about them, and they talk about how like what the hard thing to do is to keep it in a quantum in a superposition state, and you
Pipe
know,
dream, Cole.
if you're not careful, they said the slightest little vibration can knock it out, and then it fails.
That's their excuse for why it doesn't work.
Yeah, they say that any external input of energy into the system can cause the wave function to collapse. Now, what's funny is like wave function collapse, right? That's treated as like a phenomenon, but like what in reality, like what they see is there is a collapse in the state of the machine. Like that does happen, and what collapses is they have a wave function that describes the basically the electron cloud. So like Schrodinger's equation, which was turned into Max Born and his cohort took it and squared it and turned it into a probability amplitude. But Schrodinger's actual equation, the Schrodinger wave equation, describes the full state of properties of a wave. And he said, like because he applied it to electrons, he was using it to model the electron cloud of hydrogen to predict the line spectra emission, the light coming out of a hydrogen nucleus. And he got awarded for it because he worked. But he said that his equation described a real wave in a real medium, like it was like and that the energy of the electron cloud was contained continuously everywhere throughout its trace in the equation, basically. So, like when you see an electron orbital cloud, if you look at like the SPDF orbitals on like a chemistry chart for an element, for example, those SPD had the teardrop shapes and stuff and the little random different shapes. Anywhere that you see that cloud, it's not that there's an electron somewhere at one point in that cloud. It's that everywhere inside the cloud at any given time, the entire distribution of energy is continuous throughout it.
Okay, I got you.
Like a jar of water.
It's all just energy, but it's filled up in that cloud.
It's filling the whole space, right? It's not concentrated at one point. Now, what happens when the detection event occurs is you take your probe and you shove your probe into that teardrop, and now the probe touches a spot on it. And if we pause time,
its shape, yeah,
if we pause time and then we do like move one frame at a time, what occurs is that needle tip hits it. It cuts into the wave now because an electron is actually
I didn't think we actually shoved a needle into it. You're talking a needle.
I'm just giving an
extraordinarily small.
Yeah, I'm just giving an example, like a visualization. Any object touches it.
I thought we just tried to. I thought we just measured it some way crazy and something.
Well, you measure an interaction. I'm just modeling the interaction as like.
All right, but go ahead. Keep going.
Yeah,
I've always pronounced that as de Broglie wavelength. I don't know.
I don't know how you say it, but I just say de Broglie. But anyways,
isn't it like a fan piezo? So like,
well, that's a very like simplified version of it in a 2D.
I know, but I'm retarded, so I need to like simplify it from my own brain.
Got that right? No, I'm just kidding.
If you think of it in like a 2D top down view, you can imagine like a
2D top down view of a
fan blades that are spinning really fast.
When you measure it, you're basically creating a fan blade position in
not
time.
Measuring it. No, it is a fan, but the electron is a de Broglie standing wave that's oscillating around the nucleus at retarded speeds, right? And so when an interaction occurs when something touches it, right? So when you touch it, you literally cut into that wave. You like slice into it, right? And the part that's moving towards your finger, say you stick your finger in it, the part that's moving towards your finger keeps going into your finger. Because you basically just when you cut into it, one side of your finger has the head and the other side of your finger has the tail. Well, the head flows into your finger, and then the tail has to go all the way back around and do a full loop around in order to follow the head, and like a snake, like when you play the game Snake, it has to follow around.
No, I got what you're saying.
Yeah, and the whole spaghetti noodle unravels and flows into your finger, right? And so that's the wave function collapse.
Is it angel hair?
Interesting. So basically, okay. So
because when I touch it, it's no longer stable. I mess with it. I knock it out of a stable configuration when I touch it, and now the energy.
So you're measuring when it gets back into a state. So basically, okay, I'm just trying to wrap my mind around this. So the actual numerical value you're giving, whatever it is that you're, measuring, like in terms of like electron clouds, right? Like, how there's like different, like valence electrons, etc. Like how it's they show the model as like a concentric circles, or like what would you call that? Like a radius.
Distance
so
from the nucleus.
distance from the
Radius.
nucleus, right?
Yeah,
So
on
one
radius.
wouldn't just be in a linear direction; it would just be like omnidirectional, like from its center.
Well, yeah, like I gave you a top-down 2D view of a fan blade. In reality, everything's 3D, so it's like a much more complex geometry depending on the element, depending on what energy level you're at. But that suffices to explain the general concept. And another thing is that the actual like oscillation, right, as this thing is moving around, it's harmonic. It only is able to exist in certain stable configurations based on the harmonization, the harmonics in the atom. So that's why you only have certain energy levels that the electron is able to occupy, because it can only create stable standing wave harmonic configurations at certain distances. So the circumference, something really cool that will make this intuitive, make more sense.
It's kind of like frequencies, right? Like kind of cymatic patterns in a sense, where that certain frequency gives its topology, essentially, like you were saying earlier.
Yeah, so something that makes this intuitive is that every electron orbital, if I just imagine it as a big circle around the nucleus in the center, okay, the circumference of that orbital will always be a whole number of wavelengths. Okay. And there's a ratio, there's a whole number ratio between the radius and the circumference. So it's literally
otherwise
building,
it wouldn't be
stable. That's
wouldn't
not
be
able
stable.
to occupy it. Yeah.
Right, so it wouldn't have that radial function. Okay, I get what you're saying. To hold that shape. If it would I kind of get what you're saying.
If the frequency is, 30 megahertz, 30 megahertz is like 10 meters or whatever. So if it's a 30 megahertz frequency, the wavelength is 10 meters, then if it's energy level 1, n equals 1, then the circumference is going to be 10 meters.
Period. Right. If it's 2, 20.
I think if it's 2, I think it's 2 squared. I think you square it. I'm pretty sure. I have to look at the ratio again, but it would be like 4. So it would be 4 of them.
Oh yeah. It would be. Yeah. Yep. Because that's essentially how you do.
And then n equals 3, it would be 9 of them
over a sphere, right?
There's like an r squared in there, but yeah, it's crazy how intuitive it becomes, and the whole like detection event. That was the thing I was going to say. So a detection event, right? They say that what is quantum state superposition and what is a wave function collapse. So I explained how you stick your finger in it, it breaks it open, and it falls around, and has to come back around and hit your finger, right? But that's the detection. Wherever my finger touched, that's where the electron is said to be. But prior to me touching it, they acknowledge that the electron exists in a superposition. What's that mean? It's everywhere in the cloud all at once.
It's energy dissipation. It's just like the energy is the whole cloud is a homogeneous ball of energy.
Yeah,
the whole electron cloud.
It's not necessarily homogeneous, because some parts have higher energy density than the other parts do, but it all contains some energy, right? And
but whatever part you disturb, or if it gets disturbed at all,
wherever you touch it, that's where the electron just got detected. That's where it must be. But
that makes much more sense. Instead of it being a full wave, like if you throw a rock in a pond and you see a complete ring of a wave, I picture it as like you could pause those rings in the middle of that pond. If you throw a rock in the pond and you let the waves start heading outwards, and there's always several of them, and they head out towards the edge of the lake or edge of the pond. If you could just pause time for a second and take one of those rings of a wave, one of those ripples, and then cut just a section off of it, like a 2-inch wide piece of it. That's what I feel like that an electron or a particle is. It's not a full wave. It's just like a piece of a wave, but it'll still act like a wave because it is a wave. It's just not a complete wave like we think of.
It's like a standing wave.
That's a good word for it. It's a standing wave.
That's a hump. That's what you were talking about earlier.
So, A standing wave is created by when you have the overlap of multiple waves, and it create the result of that creates a wave that doesn't move. It just stays in place, and its amplitude moves up and down. And so, if you look at the orbital clouds of various elements, right, you'll see that they're all different shapes. And what that ends up coming from is as you get heavier elements. What's a heavier element? It's an element that's more ether in rotation, right? It's a bigger bundle of ether, right? And so as it's rotating, and the electron is the electrons are swirling around, right? New harmonic configurations are created, and the superposition of the electrons swirling around adds up in some places and subtracts in other places, and so some places are filled and some places are canceled, and it just takes on all these new shapes. It's super interesting when you look at the orbital shapes of all the different elements. We've got 100 and something elements; they're all different, and it's super fascinating. You start to realize oh my gosh, the heavier these elements get, the more ether that goes in there, the more it changes what their geometry looks like, because they're having to change their shape of their clouds in order to be stable. And that explains um, unstable atoms like radioactive isotopes, because a radioactive isotope has a little bit different mass than the stable one does. And so that little bit different mass is just enough to throw it out of stability, out of equilibrium. And so you imagine this ether's flowing around. It's like a top that's wobbling, right? Instead of a top that's upright, instead of a gyro that's upright and just spinning, balanced, it's a wobbling top. And a top that wobbles, it'll every time it goes around so much, it'll hit a wobble, and every time it goes around so much, it'll wobble, and another wobble, and eventually it goes crazy and it goes out of stability, and that's when you have a decay, right? And so once again, the gyroscope analogy applies very well here, and that works to explain radioactive decay.
Wow. What are the implications of actually switching it to that kind of a view state, right? Like how does one go about getting the entire scientific community to acknowledge a different fundamental view or perspective of
Well,
how would you go about that?
we got to realize, right? If we were having this conversation 100 years ago, plenty of people would agree. It'd make intuitive sense. But the generation of scientists that grew up on classical mechanics and fluid dynamics and would be able to digest this intuitively and make sense of it has long since passed, and all the generations since then have been raised and taught relativity and the abstraction view through their entire education. So those in order for it to gain traction, you have to talk to people who would be willing or able to basically unlatch from their currently held views, and people have that abstraction view are like, well, the math works and it describes the behavior fine, so it must be true. It's yeah, but there's no physical explanation there. It's just math with no physicality to it, and they don't care, right? So you have to get people who first you need to train people in philosophy and logic, people who are willing to accept scientific realism, right? Concreteness and realism. And if you operate under the presumption of scientific realism, you know that, okay, an abstraction cannot be an explanation, it can only be a description. So even if I'm describing this accurately, that's not telling me what's actually going on. I need to figure out how and why it's happening. And the only way you can physically do that is if you have a physical mechanism, which the physical medium provides.
Mm. Mm. Yeah, I don't know. I mean, the dogmatic view that NASA show had earlier, the speed of light is constant, all reference frames are valid, and it's just dogma. How do
That's sort of
you?
what I think he's talking about. Everybody raised on it. It's
reference frames aren't valid
they
though.
won't believe anything different.
All reference frames aren't valid. When you get on a merry-go-round, a roundabout at a park, and you start spinning super fast, and you see the plane doing like a jumbo jet passenger plane, like a 747 or whatever they're using now. You see one of those planes, and you look up at it and you're spinning super fast and it is doing a friggin' loop-de-loops in the sky. The plane's just spinning in circles. That reference frame is not valid at all because it's physically impossible for the plane to do that in the first place. It would literally tear itself apart. The plane's not built for that. F-22s or whatever aren't built for that shit. Like, you just can't physically fly like that. It's impossible. That is not a valid reference frame at all. Absolutely impossible for that to be valid. That all reference frames are valid thing is just some bullshit they say to try to get out of arguments, and they just say reference frames.
Yeah, only the lab frame is universally valid. But see, here's the problem, Beasticles. Are you still there?
Yeah, I'm here.
Yeah, so you got to also realize, like, not to pick on NASA, like, I think that he's probably genuine, but like, here's the problem, right? A lot of these people have philosophical biases that are baked into their like scientific paradigm, and that's we're human, we're subject to that. We can't not be, right? It's very difficult. It takes a very special type of mind to be able to say, look, I'm going to completely separate my science from my philosophy and be philosophy agnostic in my science. That's not an easy thing to do. Most people can never do it. Like legit 90 something percent of the population, 90, probably like 98%, maybe not that, but like a very large number, right? And when you say things like, okay, well, I can show you this proof or this evidence or this experiment that demonstrates the invalidity, the non-validity of your mainstream model, right? It's not that like it's impossible for anyone to show evidence to the contrary, right? Because like that's how science works. Things have to be falsifiable. You have to be willing to look at new evidence. Like that's literally the backbone of science. But people become unwilling to do that because they're afraid of like what would be the philosophical implications if I were to give up this paradigm, right? For everyday
Do you
people
think it's
walking,
a philosophical fear more
Yeah.
so being wrong in the scientific community? Because it's more about like them being wrong in their idea of what this place is and how it works, and if it works this way, then that means that Earth does occupy a special place. There are consequences to my actions.
Yeah.
I am accountable if there
Yeah,
is a
dude.
creator.
The anti-God people will always be the most staunch opponents of anything anti-mainstream because their worldview and their identity is tied to their philosophy. And if you take that away from them, they're like completely lost, right?
And what is the mainstream worldview right now?
Well, the mainstream
It's
worldview within
secular.
academia and science is secularism, right? It's
Exactly.
there is we can explain everything in the universe without needing God at all. We can invent 16 billion years ago an explosion of nothing created everything, and blah 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 blah, and on we go, right? So if if someone is already fully bought into that and they know where you're going with what you're trying to explain, right? If they know where it's leading them, they're going to immediately be opposed to it. Sometimes if you
Incessantly
find
interrupt you, call you a liar,
right,
ad hom
because
you.
they're already negatively reacting to even the idea of things being wrong, right? They don't even want to allow you to speak or levy your your evidence or your experiments or whatever. They don't even want you to be able to say it because they like that would cause the conversation to progress and their brain to form conclusions about it. And I don't think they do this consciously, most of them. I think it's just like the way that the human brain works when you're into this like matrix delusion, right? Like they've been deluded by falsehood, and that's one of the natural consequences of that. So to answer, like, if it to full circle to tie back to your original question, I think that the way that you do it is you just continue to have these patient conversations with everyone that you're able to get to listen, and then you also just lay down just this cold, hard, raw science and logic, and campaign for it, and then you just let the cards fall where they may, and you pray about it. Because ultimately, you can lead a horse to water, but you can't force it to drink, right?
No, yeah, for sure. By the way, this is what Lion just tagged me in to try and help explain. I was just listening to it for a little bit, but to try and explain what you were talking about in terms of like when you take a slice of that electron cloud.
Yeah.
Yeah, this seems to be related.
Jesus, just for funsies, if you've never heard the logical binary question list that Witsit came up with, you should just click on those pictures and read them. Like read them out. And read. I didn't tag you. I put it on. I just put it in the chat
but
around.
There's so much.
Can you control F? Can you control F and like search the chat and find it, and then reply to it?
It's at 8:42. Yeah. But yeah, it's just binary questions, and it goes to a logical conclusion. That's hilarious.
8:42.
You can keep playing this video. I'm very interested in what this guy has to say.
Okay.
Take the proton. You take the proton, and you take all the modes of oscillation of the 0 point in it. Okay, and you calculate how many modes of oscillation all the way down to the Planck size, to the smallest, inside the oscillator, right? Because now you didn't remove the source of oscillation of the oscillator.
Yeah,
you have it in,
yeah.
So now you have it in there. So you calculate, and you imagine the waves are bouncing all around, and some of them are canceling out, and some of them are building up energy, right? And so we calculated that. It's called the correlation functions equation, and when we calculated the amount that are canceling out, most of them are canceling out, but some of them are building energy, and we got the exact mass of the proton. Exact mass we measure, right? Which is remarkable.
Yeah.
And the next paper, actually, we show that the ratio of the ones that are canceling out to the ones that are building up, that are creating energy, that ratio is very, very special, but I'm going to keep it for the paper. Okay, it's very, very special. But basically, it gives the correct answer, and then we calculated how much pressure it would produce inside the proton, this energy, and we got the pressure that they're measuring that's inside the proton, which is similar to the pressure of a neutron star. It's like really high pressure. And it's called the color force. It's the force that is at the source of like the confinement of the protons together in the nuclei. And we got the right answer. So we have the Planck force, then it gives the color force in the proton, then it as you get away from the proton, it drops again, and it gives the residual strong force, which is the nuclear force that holds the nuclei together. And then you keep going further from the proton, and approximately 2.6 protons away, it becomes the gravitational force. So we showed that it's all the same force. What Einstein called space-time is just the fluid dynamics of the 0 point energy. You take the proton, and you take all the modes of oscillation.
Yo.
Wow. Yeah, dude. When did this drop, bro? Can you give me the screenshot of that
Lion.
paper?
Yeah, I did. I sent it to you.
Holy frick, dude.
If that wasn't the exact thing you were just talking about, I don't know. Like, Lion, I'm gonna put my vote on it. Lion is the king of relevance this year. 2026, Lion as the king of relevance.
I appreciate it. No, I mean the thing is, dude, people have been talking about this low key for a while now. I know like Lockheed Martin, they got technology beyond your wildest dreams, and they understand that. I think
that's why they keep it hidden. Remember how?
Yeah, they keep it hidden, bro, for national security reasons. They don't want other countries knowing what's actually going on. Let them keep believing the Einstein relativity is all. You know what I mean? Like I feel like this stuff's already been leaked long ago. It's just slowly reaching. It's boiling up.
Well, the private sector, the private sector. I mean, the like academia, the public sector is like, slowly catching up to what these like
Yeah.
super dope like development labs, like private government
These
contractor development labs
engineers.
have already known
Yeah.
about. Because I'm sure they already figured this stuff out probably a while ago, but it's classified, right? Like all these equations that they figured out are
Right.
classified, and you don't learn about it in a university class, right? You can't go take a course on it. But if you're in the Skunk Works or whatever, like black team of development somewhere, I'm sure those guys probably knew about it.
Do you think they figured out the ratio for?
Dude.
Okay, all right. Check this out. This is where I'm going with this. We remember how we kept talking about it. How do they keep those satellites up there? Because there's things up there.
Uh-huh.
What if they figured out
that's
that ratio?
Well, yeah, I mean, the first satellite was launched up in 1949, or was it 50 something? Hold on. When was Sputnik sent it? 52? Hold on.
No, earlier. Wasn't it? Wasn't it like
I
40?
should know this, and I don't.
No. It was 1957. Yeah. Okay, sorry.
57.
1950. Yeah, 57. And then 3 months later we sent one up in early 58. October 57 was Sputnik, and then ours was like 3 months later, January 58.
Dude, Sputnik only orbited for 92 days before burning up.
Yeah, it's really low.
So
that's wild. Okay, 92
But if you look at a
days.
picture of Sputnik, right? So you've got this big metal sphere, which you can't see inside. You don't know what is in it. And then you have these like antenna rod things sticking out of it, which, if they're, whatever's inside of it is imparting charge or something to the outside, who knows what's going on. But I'm sure that whatever they're doing, right, they figured out what the fluid dynamics equations are in order to keep those things up there, whether it's some kind of like just macro scale, like Newtonian type mechanical force, or whether there's like some kind of like electrostatic coupling that's going on. I don't know, right? I would get paid a lot of money if I did know, I'm sure, but I don't know. So, but yeah, dude, it's all very interesting.
Dude,
it's also interesting the timeline, right? Because if you look at the timeline of like the Antarctic expeditions and the space program and the first satellite, as well as like ionic thrust engines and stuff like that, they all happened right along that timeline.
I know, dude. And you know what happened afterwards? Like right afterwards, you had like the high altitude
explosion, detonation.
Yep, and also the artificial ionosphere tests by using tiny little copper dipoles to create like an artificial ionosphere that they could bounce signal off.
Yeah.
You heard about that? Project Westford?
Look,
dude,
sure.
look up here. I'll just give you the Wikipedia. All right.
Dude, but it's so crazy. This guy's like, yeah, Einstein space-time stuff was really just fluid dynamics. I'm like, bruh, that's what I'm saying, dude.
That's literally what you said. You're like, dude, it's crazy how fluid dynamics could be the explanation to everything. And this guy just says it.
He's like, yeah, we just predicted the mass of a proton, the strong nuclear force, the color force, radiation pressure, and all this other stuff using fluid dynamics and adding up all the oscillation components and the correlation function for them.
Bro, do you see Project Westford? The picture right there is to show the scale of one of those copper dipoles.
Project Westford.
You see how?
Oh, tiny little copper strands, like hairs,
literally
almost copper hairs. Yeah, and when they shot those up in the air, that created like a mesh in the sky of like.
Yeah.
Wow.
Yep. I'll show you the other paper. So.
Wait, is that stuff still up there?
No. No, definitely not. But when
They spray chemicals out now, so.
hold on, let me see. Project. Here we go. So there was 2 of them. So there's one that says they are still in orbit. By the way,
Okay, yeah, they're still up there. Yeah,
they call it
probably.
the X band transmission. So
Oh, that's X
yeah,
band.
yeah, dog, yeah.
What?
Okay, all right. So I've been looking into this ever since I came into this subject because I used to work for Dish Network. So I was always curious. I'm like, okay, so what the fuck are they aiming at actually? And that's what they're aiming at, dude. I think they created their own little artificial ionosphere as well, using the same kind of principles. They just call them EcoStar, right? EcoStar satellites. But when you actually look at an EcoStar position, like if I go to EcoStar 9, for example, I'll show you like what it looks like in images, right? Check this shit out.
Put it in the chat. Oh, Echo. Yeah. Let's see. Transmit and receive.
Yeah.
Receive.
So what they say is that those 4 channels are like 4 channels coming down from a satellite, right? Where it's line of sight, but just picture it as like the opposite. Where it's not beaming down, it's beaming up. Those are transmitting. Like they just basically created these like areas where I think they
Wait,
just
are you
launched.
saying that your antenna is not pointing at a satellite? It's pointing at a layer in the atmosphere of copper dipoles?
Yeah, that's my theory.
Oh my gosh.
And the reason why is because you would just like imagine they just launched so many of them, right? Some of them would deorbit, some of them would just get launched into space or whatever. Like, but some of them would hit a neutral state and just stay up there.
Yeah. Well,
just like geostationary satellites.
Yeah, I mean, we have satellites up there. Like,
okay, but that's what I'm saying. Like,
no, but like you can see the ISS go past you at 7 bajillion miles an hour. Like you can watch it.
Yeah, that's a little different. A little different than what I'm saying. Because what I'm talking about is broadcast transmission, not just not like like no one uses the ISS to get their their fucking sports game.
Yeah,
that's not what I'm talking. What I'm saying is like in terms of broadcast and transmission, in terms of like radio signals.
You're saying instead of like saying that some satellite up there has the bandwidth to transmit this station out everywhere, that maybe they're just beaming it up from the ground and it's like bouncing off and radiating out everywhere.
Hence why you have to have a line of sight. You have to have a certain angle to it.
Okay, yeah, to get the coverage, to be in the coverage zone or whatever.
Yeah. Because otherwise it doesn't make sense. There's an open FM crossband repeater on the ISS. Oh yeah, I believe you, Bull Knight. I was just looking into SSTV or Space Signal TV, where like this guy literally used like a USB, and downloaded what was being broadcast from the ISS because he was like tuned into like 140, whatever the frequency was. I can't remember what it was, but it was basically like, single scan. I think it was single scan television signal or whatever, where you can literally download an image that's being broadcasted from the slow scan TV. Thank you. Yeah, that's what it was. No, yeah, I got you. I'm just trying to. Okay, so what I'm just trying to do is I'm trying to understand why this Project Westford, which also occurred around the same time as like, Operation Fishbowl and Operation Dominic, etc., where we did high altitude explosions. And it occurred around the same time. They were able to get actual bit rates in terms of like signal and communication where they could use it to talk to each other.
Do you know how many dipoles they put up?
Yeah, 480 million.
Oh my god.
That was just Project Westford 1, though. They did it twice.
And all the times we don't know about it as well.
And all the times we don't know about it, exactly.
Yeah. It's like we have no idea the stuff they're doing every day.
Project Needles.
Yeah. Yeah, dude.
What rabbit hole did you fall down to get to this?
Man, don't even ask me, bro. Like, you know how I find shit.
Did you just get here, Levelist?
No, he's been listening.
Kinda, yeah. Been listening.
Oh, he missed out the whole fluid dynamics thing.
I heard the last like 5 minutes you were cooking your ass off. I'm gonna go back and listen to the start of it. How long? When did you start that?
I don't know.
I got you. I'll get you a timestamp.
Don't worry. I'll be posting it anyway.
All right, Dave. Thank you.
You've been cooking for a minute.
Dude, Beasticles, I would be so happy to work for one of these places that does this crazy, like, beyond future level, like, tech development stuff. How sick would that be, man? Especially if you were doing it for something really cool, like, national defense.
Yeah. And you can go and really bomb brown people efficiently.
They don't use that stuff for that, bro. All the super high tech stuff that's under wraps, so you don't even know about it.
I know, I'm just playing. I mean, what would they use it for, though?
Well, they wouldn't use it unless we got into like a big war against like Russia or China or somebody.
Yeah, we're working on that.
Well, here's the thing, bro. I absolutely don't support the crazy stuff that they're doing for Israel. However, that doesn't mean that I don't still love my country and know that there's a need for us to have a military that can defend us, because
I agree.
like two things can be true at the same time.
Yeah, we can have a really good military and a really big need for our good military, but at the same time, we can have an idiot who's in charge of it.
Yeah,
and that's what we got right now. Which, like, everybody asks me, like, why did you vote one for another? But I'm just, in my opinion, I don't like Trump at all. I think he's a total idiot. But I think Kamala Harris would have put us through 4 years of living woke nightmare hell.
It wasn't a real choice, bro. Like, the people that you see don't actually even really run the country. Do you think if Kamala Harris had been, do you think if she had been elected president that she'd actually be running anything?
No, not at all. She'd have been told every move to make by whoever runs the government.
Does anybody really think Joe Biden and his auto pen was actually running shit for those 4 years?
Of course not. And Trump doesn't really run stuff either, bro. It's always a cabinet of advisors. It's always been like that in every kingdom. You get a king with a bunch of advisors. I mean, certain places the king actually did run stuff, and he's just like, I'm the king, But like, there's always people in the cabinet. And we just happen to live in a time where our government's co-opted. But that doesn't have to be the case, and it doesn't mean like serving your country is bad, or that there's not still a need to like take care of your people. It just means that currently the state of affairs is such that people are abusing power and doing bad stuff with it. But if we were to just not have a military, then you best believe that somebody that's not good would take over, and then it's like, oh, so what did we do out of benevolence for not wanting to have a military so they couldn't use it to bomb people? We just let people take our country over? Like, you can't do that. So it's a catch-22. You just got to do what you got to do. The creation of weapons is agnostic, right? Like, bombs exist. They're not inherently evil. Swords exist, guns exist, weapons exist. They're not inherently evil, but how they are used will determine like the morality or whatever.
Bro, okay. You ready for this? It's called SYNCOM. SYNCOM 1 was intended to be the first geosynchronous communication satellite It was launched February 14th, 1963.
What happened? Say that. They did what?
So the first geosynchronous communication satellite was called SYNCOM. SYNCOM 1.
Share your screen.
Sure. Oh, you know what's funny? I'm still in Arc Raiders.
Yeah, close it out. You're just burning resources.
Dude, I'm still in. Like, there's 2 minutes left in the game. That's hilarious. Oops, wrong stream. Hold up a second. All right, check this out.
Dude, why do they all look so weird? They got those sticking out. They all got those things sticking out. Those like metal rods going.
So check this out right here. Where was I? Oh yeah. Right here. So the debris that was caused by these dipoles, essentially, right here.
Yeah.
It says data collected during observations in the mid-1990s suggests that a moderate population of small debris resides in orbits above 2,500 kilometers. It has been suggested that these debris represent small clumps of needles from the first Project Westford mission in 1961. So that was the first one. The second one was in 1963.
Okay.
What also happened in 1963? The supposed first geosynchronous communication satellite was launched.
I see.
I might be making a correlation, but it can't be a coincidence, right? And then you see this
So,
right
like,
here.
are you guessing, like, what if some of them are actually just needle clouds and not real things? Because since we can't see them anyway, is that what you're like hypothesizing? Is that where you're going?
You can't see them, yeah.
What about the
You can
ISS
get,
though?
the ISS is, well, I mean, that's something different. I don't know.
Yeah,
I don't know.
it really moves at 16,000 miles an hour though.
I know. We actually did the calculation too.
17,500.
Remember we did it? Remember
Yeah.
you did the angular diameter of it,
Yeah.
as opposed to the background with the moon? Yeah, we did all that. Yeah.
Yeah, and then I found out if it was at a 61-degree angle from his telescope, that the 95 meters that I calculated would be 108 meters based on the law of cosines, because I didn't know the angle of the telescope. So,
and they say that it's
I'm
that
saying
wide,
you got deep
right?
with it.
Of course, dude. Well, you think we're just gonna be surface level when we try to make arguments about certain things, dude? Same thing with me. Like, I've been looking into this EcoStar shit for a long time, or EchoStar, whatever you want to call it. But I wanted to show you guys this as well. I was trying to figure it out. In early 2025, mass retirements of older Gen 1 satellites caused the rate to temporarily spike to 4 or 5 satellites per day. But as of early 2026, 1 to 2 satellites are burning up in the atmosphere daily. And I'm talking about Starlink. 1 to 2 satellites per day.
yeah, 5 reentries per day is the future projection in order to maintain a planned constellation of 30 to 42,000 with a 5-year replacement cycle.
Think about that for a second, you guys.
Each satellite leaves behind 30 kilograms of aluminum oxide particles. They could float in the stratosphere for decades, affecting ozone layer chemistry.
Yeah.
There's a
But
human casualty risk of less than 1 in 100 million. While nearly all mass vaporizes, approximately 5%, may reach the ground as tiny, lower energy fragments. Dude, imagine you're one of the 1 in 100 million people and you're just out in the middle of Africa, like walking around one day and you just get smoked by like a tiny little fiber dropping out the sky.
yeah, like tiny little microscopic holes just appear in someone's body. And you're like, what the fuck?
It's like a piece of aluminum that's just at like ludicrous speed falling down.
$5 billion loss last year. That's crazy.
Okay.
The point is about Starlink, right? Like why I brought this up, because we're trying to figure out like what the fuck is going on up there, how are we actually keeping it up there, etc.
Yeah.
So imagine we found out what that ratio would be in terms of it to be able to be geosynchronous and just stay up there in that neutral zone.
Yeah.
Now the reason why we were able to figure it out with copper dipoles is because of how tiny and how how less, it's not that much weight. So you
Right.
can basically suspend that for a long period of time. You know what I mean? If it's based off of certain like ratios of like, it's
you fly them up there and you spray them out continuously, like at every altitude as you fly up, and
it's like iodine in a bloodstream, dog.
And you find where there's a layer remaining after you wait like a few months or a year or however long, and then it's like, all right, let's shoot our beams up there and see like where we get reflections, and the ones that are still up there,
Exactly, dude.
we know
You
that's
got
the
it.
altitude that stuff will just float at.
Exactly.
So really, it wasn't through any kind of like Keplerian and stuff. They just did empirical measurements to figure out where the stuff would float, and that's where they fly the rocket up to, get it going
This is my
sideways really
theory.
fast, and kick it out.
I'm sure Josh has other thoughts about it, but hey, Josh, have you actually ever heard of Project Westford? I don't know. Or Project Needles?
Nope.
Oh, dude, you're gonna love this.
It's
So
pretty
it's called
interesting, bro.
Yeah, Westford Needles, essentially. I'll read it right here.
Well, you remember Dr. Mike? What he like?
Dude, Discord disconnecting all the time.
Yeah, me too. You remember what our NG our NRO friend, like our 40-year NRO retiree friend, said, right?
Mm-hmm.
Like, legit. I mean, it's all automated now that they automated it and turned it over to the Space Force, but like their solutions for position fixes and the orbital mechanics are like classified, right? But that doesn't really make sense in a mainstream paradigm because orbital mechanics are literally open source material just based on altitude, and the altitudes are published. So there would literally be nothing about it that would be classified if it was just based on mainstream.
Yeah.
The only people that would know, right, would be the people kicking it off the rocket because they actually have to know where the rocket's at.
Right.
And which now, since it's all automated, they use the positioning. They use the positioning system just from WGS84 anyway, so they probably wouldn't even have to know as long as it just matches whatever's the reported in the system. They would just say it's at this reported altitude, and they wouldn't know the difference anymore either.
Okay, so I got a question for you, Josh. Remember we were talking about geosynchronous satellites?
Uh-huh.
What was the inclination?
Any inclination you want, it's a altitude that matters.
And what was the altitude?
36,000-ish.
Kilometers.
3,600?
36,000.
36,000?
Yeah.
Yeah.
Okay. You see these dipoles?
I'm
It was
not looking at my phone right now.
3,600 kilometers.
No, geosynchronous is 36,000.
Ah, dude.
All are still in orbit. Yeah, it's like, well, how are they still in orbit? Like, why are the needles still up there? Is that like under the?
What if this is that classified shit though? It's not actually 36,000 kilometers.
Yeah, yeah, we don't
really know, but I'm just saying that isn't that interesting that it's the same. It's just literally. What is that? 10%?
Yeah, it's interesting. Yeah.
This is what I'm saying, bro. Like, I don't know what the connection is here, but it is. There's something here. So the first geosynchronous satellite, right? SYNCOM, right, Josh?
I have no idea.
Oh, fucking, what the hell?
What altitude was it again?
Aren't you a satellite expert, bro? Don't you love this shit? Isn't this like you live it and breathe it? Like, what?
What was the altitude again?
But I haven't, the last time I took like a space history class was, I don't know, like 5 years ago.
What,
I can tell you what's up there now.
What's the altitude of this?
Like 36,000-ish. A little over 36,000.
Yeah, let me see here. It should show like right here. So geosynchronous, yeah, 35,786 kilometers above Earth's equator.
Yeah, and then a little higher above the poles.
Yeah.
And what are you thinking that it is? So Glober model says this, and then this other one, what is it reporting?
Not a Glober model, but this other project. Where is it? Hold on. There was this project in the same year, actually 2 years before it, called Project Westford, where they basically launched millions of these 480 million little tiny dipoles, essentially
little copper hairs,
strands, copper hairs. Yeah, this is like a scaled. I don't know if you see my stream, Gatebreaker, but this is like a scaled image, right? So it shows like how big they actually were compared to like this postage stamp, and essentially, its intended orbit was 3,500 to 3,750 kilometers. It says the second project was partially successful and released an estimated 120 to 215 million copper wires into initial orbit of 3,600 kilometers. It says the orbit and design of the individual needles were chosen to promote rapid orbital decay and re-entry into the atmosphere. The needles are believed to have re-entered within a few years, largely due to solar radiation pressure effects. The individual needles could not be detected and tracked by the SSN. During 1963, 4 additional debris with radar cross-sections ranging from about 5 to 1 meter squared were cataloged. These are likely the 4 main dispenser subunits. However, since 1966, the SSN has cataloged 144 small objects associated with the second Project Westford experiment. 2 additional objects called Westford Needles are assessed to be from a different mission and are miscatalogued. A post-mission investigation concluded that only 25 to 45% of the planned 480 million dipoles dispersed properly.
So, real quick,
they still say it's there, by the way.
Yeah, this was supposed to be like an experiment to be able to extend radio communications beyond to larger distances and coverage zones, right? Which, I mean, they used it for that. But if you think about it, what did they do right after this? They did the Project Starfish, and the Operation Dominic Project Fishbowl stuff.
Right, right by Christmas Island, exactly. Yeah.
They had trackable isotopes that they put in and launched out of bombs up in the sky, and that would allow them to, using a radio telescope, for example, tune to the correct isotope frequency to 3D map the skies.
Exactly, you got it.
And so
that's what I think they did. Yeah.
Yeah.
Go ahead.
I think that's no. I agree. And this was like an early version of that, right? So that first they used whatever the first Sputnik, 1957 Sputnik. What you should do is you should look into like any precursors to this, like any other type of mapping efforts that were done prior to Sputnik being launched, right? Because Sputnik was pretty low and burned up pretty fast, right? So maybe whatever they did early, they were able to figure out this low altitude band for Sputnik, and then they're like, all right, let's figure out a higher altitude band. They shot a rocket up, dumped out these copper dipoles. They're like, all right, now let's put some freaking warheads on missiles and shoot them as high as we can and blow them up. And just doing this, they iteratively mapped out all the layers of the upper zones, basically. And when you can 3D track it, you can literally see the altitude and the paths of like the ether winds and the currents and the movements and stuff. And they use that data to be able to put satellites up.
Yeah, what do you think about all that, Josh? Does anything sound familiar about mapping certain orbital paths or anything like that?
No, not really.
At this point, Beast, I mean, if you think about our NRO friend, remember what he told us? Like his last project in his like 42 years or whatever it was to turn over the system to the Space Force when the NRO gave it up, right? And that they had to program the entire backbone to take all the functions of each individual person from the teams that were cross working and sharing, their classified functions. Here's my data, use it to do your function, use it to do his function, next and next. They put all that into a fully automated system for the Space Force to use when they took it over. Now nobody at the Space Force has any idea of what's under the hood inside the black box. They only see like the white box around it. But
you only see the completed project, but none of the actual components that built it, right?
Yeah, but remember he was saying that all he could say was that if they just got something moving fast enough, right, that it would stay there, and then if they increased the speed, it would go higher. Decrease the speed, it would go lower. That paper Alan found about that Asian team, like this past year or two, talking about the modified gravitational parameter equations to adjust orbits. We're saying that the gravitational parameter wasn't actually that basically the momentum that something would have would effectively reduce the mass of the Earth, like in the equation, not literally, but in the equation. And so that would cause objects to go up or down based on changing its velocity. They were proposing that same thing in their paper, and he was telling us that, right? Like that was like, and he did that stuff 15 years ago when he retired, or 10 years ago, 12, whatever year it was he retired, 2015 or something like that. But he clearly knows a little bit, and you wouldn't need to know any of that to launch something. It's compartmentalized as all that crap is. You could freaking build a whole
Double check that
satellite.
data. Because
So?
if he retired, if his last task was to turn things over to the Space Force, and he retired in 20, okay, I don't know.
I don't know what year it was. It was like 2016, 2015, something like that.
I don't really trust anything that comes out of Heffron's mouth.
Why?
Because I don't think he has the credentials he claims to have.
Why?
Because I pulled his dissertation, and it's from a diploma mill.
His dissertation? You actually have his dissertation?
Yep, I do. So
what is it?
It's on some statistics. It's like computer science optimization models for doing statistical analyses. I actually read it about a year ago now. But yeah, no, I don't. I don't.
You looking it up, B?
Trying to.
It's not anywhere publicly, which it wasn't published. So.
Oh, send it to me, please.
Yeah, sure.
Yeah. Next time I'm at my computer, I'll send it to you.
What do I look up exactly?
I did ask him for it.
Oh.
You asked him for it?
Oh, you asked him for it, so it should be in your DMs then, right?
Yeah. Next time I'm. Oh no, it was on email. Next time I'm at my computer, I will send it to you.
Where are you right now?
Playing Kingdom Come Deliverance.
Oh, come on, bro.
That game is cool. I love that game, man. It's awesome that you're playing that.
Yeah.
What do you mean by diploma mill?
Hours.
What's the education there with the diploma mill?
Oh, it's from Colorado Technical University.
You need to try re-entry, dude.
Which isn't Colorado Technical University is not ABET accredited. So his degree is not, it's basically not from a qualified university. So it's just one of those things where I'm just like,
but
if you
were implying that he's lying about it.
No, not at all. He did the
Okay,
work.
well, that's what it makes it seem like to people listening.
No, I mean,
it's not credible.
Google what a diploma mill is. Yeah,
just not credited. That's what he said.
Okay, well, maybe that's the way I interpreted it. Regardless, you're saying it's not an accredited university, meaning it's not at a certain prestige, or what's the problem?
Yeah. It's just like if he was applying for a job that required a doctorate, he would not be qualified.
Is that his LinkedIn?
No, he doesn't have a LinkedIn, which is another red flag.
Dude, he's old. Why would he care about LinkedIn?
Oh, I know. I'm just saying. I know a lot of old people that are in the community that.
Oh, here we go.
We have to consider that you might be biased because of what he's saying.
Oh yeah, 100% unbiased. That's fine. I'm okay.
Okay, that makes sense then.
Yeah, we all are biased on what he says. It's not new information.
So you mean you looked up his patent, or?
Yeah. So I mean, like, are you just to be clear, like, are you levying an accusation against Mike? Are you saying that he didn't really go to
No.
school and?
No, not at all. I'm just saying I
Listen
don't
to the
really
words
trust
he's
most of his
saying.
stuff.
Yeah, just
y'all
listen to the
are
words
projecting.
Yeah, it's crazy.
No, I'm just trying to figure out like what you actually.
We said his
like,
diploma was from a diploma mill, which would be
Yeah.
saying that he didn't go to school.
No, he did go to school. What the fuck?
You don't know what that means. It's okay.
Just Google it. It's
So
okay.
he
Just
didn't get a
Google
real
it.
PhD.
He did not get
It's
a real
from an
PhD.
accredited school. Do you know what accreditation is? Like you can't get licensed if you get
Yeah,
certain
I know,
licenses.
yes.
But what
yes.
about his dissertation though? Like, I mean, he could have submitted that dissertation at any university. It doesn't matter how is the dissertation itself is what I'm asking. I'm trying to figure that out.
I mean, it's like early 2000s. You know, doing like late 90s, early 2000s statistical analysis using computer programming. It's pretty surface level stuff.
What was the school?
Colorado Technical University. You can Google it. They're not ABET accredited for their doctorate programs.
It says they're Higher Learning Commission accredited.
Yeah, it's not. They create other accreditations when they can't get ABET.
So if you want to get like a professional license anywhere, you have to do an ABET accredited school. Otherwise, you have to do certain things or tests to get a licenses. So this other accreditation isn't what most people take. Or
Yeah, like it's not. I'm not saying like, oh, he didn't go to school and he's lying. I'm just saying I take everything he says with a huge amount of huge grain of salt.
What if he did it online and he didn't care about his ABET stuff for the doctorate? He already had his master's.
Well, that's fine. Then you make that decision and understand the consequences of doing that, which includes people not really taking you seriously.
Are there even any ABET accredited online PhDs for that?
So, I mean,
Josh, by the way, it seems kind of lame that you're playing your game and you're too busy playing your game to DM. It's a beast. Why don't you just do that real quick?
Dude, I'm on my console. Dude, you guys are entertainment.
Josh, you need to play the game re-entry. I'm telling you.
You're bringing
we
up
just get some
talking. You're making
clarity?
accusations
Hold
and
on.
not even providing any citations.
Yeah,
that's
so
fine. We can do that at a later date. I'll be around later. It's all good.
So you're requiring that ABET is required for PhDs? Because I'm reading here it's really not used in PhDs, or it's not required or common for PhDs, but it's for bachelors and some masters, ABET. So
all right. I might be wrong here. That's fine.
Wait, are you just totally wrong about that whole thing then?
I don't know.
You just said a minute ago that if he doesn't have an ABET certified PhD, which apparently isn't even a thing, I just looked it up, that you said he wouldn't even be able to get hired as a job that requires a PhD. So now you're just saying
I'm saying if that's what was my understanding. I could be wrong. That's fine. I appreciate you looking it up.
It's quite literally.
You said it with such confidence. I thought because I'm not.
I say everything with such confidence, dude.
Oh my gosh.
That's the issue I get.
Bad look. You just tried to
okay, we got it cleared up. Just,
when you're not even sure.
He's saying don't take anything he says seriously. It's all right. We won't.
That's just cold, dude.
What?
You understand what you did, right? Like you took.
I have read his dissertation.
I'll be redeemed when you send me that dissertation so we can go through it.
Well, Wesley, you said it as well. So Wesley, you were incorrect as well. Wesley?
No. ABET accredited schools, you can't get your license unless you go to a ABET accredited schools. But if you do,
for what?
What? For any type of professional practice. You know people are licensed. You know, like electrician is licensed, engineers are licensed, hairstylists are licensed, right? You get that, right?
Okay. So here we go. I'm actually pulled up my phone, so I'm gonna send you the dissertation real quick. But
it says you can still get a credit evaluation by NCs.
But ABET is for undergrad, and it says some master's. It's not even a PhD.
School. Yeah, I understand.
Not even for PhD.
Oh, geez. Okay. So if you look at Colorado Technical University, I'm remembering this now. They are not ABET accredited for their computer science program at any level, which even though it doesn't matter for the doctorate directly, you know, I actually looked up his advisor tree. I read his dissertation. I just don't. I think that all I'm trying to say here is that when people refer to him as Dr. Mike or Dr. Heffron, I'm just like, okay, cool. You wrote a paper and you wrote a check. Like, it's not like he's, you know, has a ton of citations on his work. Like it's a title thing. It's like the white coat of whatever.
You're trying to do a
Yelp
genetic
project.
fallacy, and then it's
Oh,
actually
Jesus
just
Christ.
a weak one. It's just a weak genetic fallacy.
He was giving you his reasoning for it. Who cares?
I just don't. I don't.
If I just said Mike Heffron,
Mike Heffron. I don't trust Mike Heffron. Is all I'm trying to say.
Yeah, you kept
All right, well,
asking
this
him
is
why.
what. All right, well, this is what a quick search. It says, yes, Colorado Technical University is fully accredited. It holds institutional accreditation from the Higher Learning Commission, HLC, a regional accreditor recognized by the U.S. Department of Education. CTU also holds CTU, the college, also holds programmatic accreditations for specific programs, including ACBSP for business, CCNE for nursing, and ABET for engineering
yeah, it
programs.
says it's ABET. Yeah, Colorado Technical University. We're talking about the same
Computer
one, right?
science,
boys.
for
This is a
computer
real bad look,
for computer
boys.
science. Why are y'all falling on your swords for this guy?
I'm just trying to get to the correct information. I'm not following.
Yeah. I was gonna say, like, they're not accredited for their computer science program. This is what I looked at like months ago.
So now you're saying that they are ABET for engineering, but not for computer science. Is not what you're saying?
Which is what his degree is in. Yes.
Yeah, he's not
The
an
program
authority
matters.
on this. He's just a person giving his opinion. I don't know why you guys are getting all.
I know Beasticles. He said he didn't trust him. Beasticles asked him why, and he gave him his reasons. It's not like Josh brought this up out of nowhere.
He said he read
It just
his
said something about
dissertation.
computer engineering is different.
Well, it's okay.
Computer science and computer
I'm not-
engineering is different.
I just put his dissertation in the chat. Y'all can read for yourself.
Okay,
I'm
thank
just
you.
saying
Thank you, bro.
I don't trust what he says. I don't think he worked for the NRO.
All right, but I was just okay. Well, if you have, that's fine. You can have your viewpoint, but I was just trying to get to what the actual information was. I'm not committed either way to what it is or isn't. I just you had mentioned that. I was just trying to look it up a little bit because I was curious. Like, oh, is that true? Like, because basically what you were saying, what you were alluding to, is that he doesn't have a real PhD. Was kind of essentially what it sounded like you were saying. It's like a fake PhD of some sort. So that's why I was trying to.
If I was going to go get a PhD, I would go to every single ABET program before I would go to Colorado Technical University. If I actually cared about, like, I'd love to talk to him about why he chose to go to that school, because it just doesn't have the best reputation, and neither does it his advisor. So, like I would love to know what decisions went into him deciding to go there and writing them that check.
Okay, well, but it does say here that they don't have accreditation for their Bachelor of Science in Computer Science program.
Correct.
So apparently they don't have it for that. They do have it for engineering. They are accredited in general as a whole school. So is your understanding also
you don't get accredited
as
as a school? It's a degree level. You don't get accredited as a school.
Okay, but his PhD program is a real PhD. It's just not from one that has an undergrad that has ABET, and to match what you think what you're saying is the best. Is that the?
Yeah. I'm being a prissy bitch about where he got his degree from.
Okay, but he does have a real PhD. Well, because the one thing you said, oh, if he was going to get hired to somewhere that required a PhD, he would not be certified.
If I was if I was a hiring manager and I saw a PhD from the university and I looked it up and it wasn't from an undergrad program that was ABET accredited, I wouldn't hire that person.
Okay, so that's fine, but he does have a real PhD. Essentially, he can get hired at places that, even though they might want one that's ABET for his undergrad. It is because it sounded like the way you had said it. It sounded like you were saying that it's like not even a real PhD.
Yeah, I don't trust Heffron. That's all we need.
Well, even further, you're saying you're saying he's lying about where he worked. That he never worked at this place.
I don't think he worked at the NRO. That's fine. Yeah, I don't have evidence for that. I don't have evidence.
Yeah, that's crazy.
We can call the college though and do a degree information. We can do a degree check though, right?
What's that?
And see if he had. You can just call the college and do a degree check, right?
No, it sounds like we got. It sounds like
good.
He has a PhD. that he has a real PhD. All Josh is saying, just so that we got to the bottom of it, is the specific computer science program does not have ABET, even though other programs at that school do have ABET, but the computer science one doesn't. And then he does, and Josh doesn't think it's a school that matches his standards, which is fine. I mean, that's your, you're free to that. There are different levels of schoolings and things, and what one thinks of PhDs from different schools is obviously a thing. Even, I mean, companies will not hire someone if they don't have a degree from a school that they prefer and so on. So
yeah, I was gonna say I'm a prissy bitch when it comes to that stuff. I went to the top 5 school for aerospace
With most
engineering,
things, I think.
What school is that?
I think you just call yourself a pussy bitch in general.
Okay, that's fine. I'm okay with that.
That's why I keep telling you, Josh, you need to play the game Re-Entry. I've said it 3 times now.
I don't have a PC.
You need to go work with Cole. You're gonna make a man out of you.
I'm playing on my PlayStation right now. Y'all are cool. Just on my phone on Bluetooth.
Josh, have you seen? We were arguing about that earlier today. That old NASA document of flight. It's like a flight dynamics model that says the assumption is an aircraft of a rigid body of a fixed weight on a flat, not rotating Earth. Do you know the reference?
For flight dynamics at most altitudes, it doesn't the Earth's rotation doesn't matter.
No, hold on. Before you guys continue on that, Jake, just respond, but just don't miss a beat. But I just want to say the reason I jumped in because I was kind of doing something else and I was half listening. And when Josh said if he was going to go get hired, just from the thing from before, if he was going to go get hired at a place that required a PhD, he wouldn't be qualified. I thought that's what Josh said. And so the reason I was like, wait a minute, is that the case? Because I mean, people refer to him as Dr. Mike. Usually in society, that's a thing that if you have a PhD, you're kind of, you can be called doctor, this and that. And so on. And so that's why I jumped in because I was like, wait a minute, is Josh saying that it's because you called it a diploma mill. So,
it is.
Sometimes that may be referred to as a place that has like no accreditation. But anyways, I'm just saying that's why I jumped in. So we got to the bottom. He does have a PhD, but there's just different levels of what's accepted, in terms of the levels of it. So anyways, I just want to say that that's why I jumped in.
Yeah. And Josh, since you're speculating, Josh, about him, what's your speculation about why he would be lying about where he worked and all that?
I mean, during my conversations with him, I again can't go into details, but there was a couple things where you just sort of poke at it, and I wasn't satisfied with his answers.
Be like me talking to another person.
Yeah, I wasn't saying
a coal miner. They wouldn't be able to answer, or they would sound like they wasn't. So I think he's.
Yeah, I wasn't saying like where your bias about him and his becoming a flat earther might have something to do with it, which you admitted. But I'm just wondering, like, why do you think that he's coming in here trying to lie about where he worked, and that has nothing to do with the self-heal?
I'm not saying he's trying to lie. I'm just saying I don't believe him.
It sounds like it. Sounds like that's what you're implying.
I remember this paper. I totally remember talking to him about this. Do you know that Dr. Mike is like his paper, this one specifically, the effective metrics for tracking software project schedule progress, is key performance indicators. That's what they use in terms of like remote work nowadays.
I mean, okay. You can go into Google Scholar and check the citations and nothing pops up. So I'm not sure where you're getting that.
What do you mean? No, he has his. I remember talking to him about this, and we were going back and forth. I'm like, effective metrics for tracking, like key performance indicators, and he goes, exactly. So I mean, this is 1998, by the way. Like in terms of information science. You can say he's not a doctor, that's fine, whatever, but like...
No, I never said he wasn't oh, Jesus. Woof. Okay, apologize for stepping on a fucking hornet's nest here.
No. You just said he's not... I wouldn't necessarily call him a doctor. Okay, that's fine.
I wouldn't, no.
I don't trust him, that's fine. But like...
Saying that I wouldn't call him doctor and saying he isn't one is two different things.
I mean, it's implying that he's not. Because you wouldn't call him one.
Implying that he thinks he's not. So, I mean, he's allowed to think what he wants.
Yeah, geez, y'all.
Yeah, exactly.
Oh, really? So people are white knighting for this guy. Like, come on.
Oh my goodness.
Jesus.
What are we doing here, y'all?
What are you doing?
I'm just telling you I don't trust him.
He's saying a lot more than
And he's
that.
telling us he's biased and he admits it, so there's no reason to
Yeah.
even pursue anything further
Yeah,
about
geez.
I
I'm
don't
very upfront. I'm very upfront and admit my faults when needed. Like I'm
I don't
not.
see what the big deal is. There's all kinds of people that flat earthers bring up that I don't put no faith in. There's that says that
Well,
they
Josh,
have
if you admit your faults, you should just
degrees
say
and
I was
shit.
wrong to imply all those things and not make it clear what I was trying to say about somebody that's a part of our community.
Yeah, he's a cool ass dude.
Okay.
He's
Oh my
he's a
gosh!
Christian.
He was asking why he didn't trust. He didn't even bring this stuff up. You guys asked him to.
No one asked
Wesley,
him
it's
for his
just sad
opinion
that
on
you're
Dr.
trying
Yes,
to
you
like.
did. You literally said, "Why don't you trust him?" And that's what you
Yeah,
asked.
because he implied that already.
Okay. So
He's
why
Yeah.
didn't
me
you
and
Okay.
ask him?
So
me
your white
and
knighting is just sad and lame.
me and
No, it's
Piezo
No,
were
just that he's
talking
allowed
about.
to not
he's
trust
allowed to
him.
have his feelings. You guys all have feelings too
Yeah.
about NASA. So what?
That's
It's
not
just like
the
a
point.
trend. Anybody with any credentials, it's like the first thing you try to do is dismiss
No,
their
No, here
it
let me
wasn't the
explain.
first
Let me
dismiss
thing.
them.
hold on.
Like, no, hold on. I'm not done fucking
All
It
right,
wasn't
talking
the
go
to you.
ahead.
first thing.
Jesus
Go ahead.
Stop
Christ.
Go
straw
ahead.
manning.
Get
Go
off
ahead.
my dick. Let me say
Stop
something.
straw manning.
Like, I brought
Go
this
ahead.
up, right? This guy, Stephen Young, right? I brought this up in Omni's chat, and you
Story
guys
time.
did the same fucking thing. And you're like, no, he's not really a nuclear physicist. He's not practicing in the field. Therefore, all his education doesn't matter because he's not utilizing it as a
Wow.
career. Like, you guys use the same type of tactics.
Now I'm going to
and it's like,
respond to this when you get done. So finish.
just go, because you want to respond
All right.
more
The
than you want to
reason, the
listen to what
reason,
I have to say.
no,
That's
I
for damn
listened to
sure.
exactly what you said.
I
The
was
wasn't
reason
even
why,
done,
the reason
Cole.
why, well, the reason why that we do that, the reason why we, when you bring up some person, a lot of times the Glober side will say they're quack or they're, because you guys will find the one out of the 10 million who believe one way, and the other 10 million will believe opposite. All of science will believe
No, it's the
opposite, and you'll
one
find the
that's willing
biggest
to come out and
oddball.
admit it. The
Dude,
one
Alright.
person
it's
that's
actually the
willing to come
opposite,
out.
bro.
You will
You're
find the
basically
biggest
saying the
oddball, and then when
whistleblower
we,
is lying. That's
and
what
then,
you're doing.
and then
And then
every
you're
time,
asking
and
for a whistleblower
see,
2
you won't
weeks
let me
later.
finish either.
Yeah,
Then
how's it feel, motherfucker?
I
All right,
told
I
you
get
to
it.
How's it feel?
finish.
You don't
I
like that shit, do you?
specifically said the words
meta
finish.
button.
All I said is I wanted to respond to, so go ahead
All
and
right,
finish.
cool. Can
And
I
you said
respond to what
no,
you said?
go ahead. But well, I want to finish real quick what I was saying. You guys find the 1 in 10 million
No, I
that
heard that
believes
part.
different. And then every single time when you start digging into those people's backgrounds, you do find quackery. So that's why we
Okay.
say it.
Okay, what's the
Oh,
quackery within Stephen Young?
yeah.
Since you're just going to
And
discredit
he's
and make a
approachable,
claim
and you
that
could talk to
every
him.
single one, because all you're doing is saying, all right, there's no whistleblower to tell us about this that's a specialist in the field. And then when someone does come out and goes against the mainstream, you're like, this dude's a fucking quack.
Yeah,
Like,
it's
okay.
crazy, dude.
So
Crazy
like it's
double
just an
standard.
endless goalpost shift that no burden can ever be met. That's all you're doing.
Hey, Pure Rigor, what is Mike Heffron's specialty?
Okay, wait. Well, before we go to that, I just want to say one point on top of that, real quick.
I asked the
Real quick.
question. I got in. So, what is Mike Heffron's specialty? It's not in celestial.
Why are you asking me questions?
It's in programming.
Pure Rigor's not a Mike
Nothing I
Heffron dude.
said.
He isn't.
So
Regardless,
again,
I mean,
you
on the
can't
point you
answer
were on the point we were on, Wesley. It's not about Mike Heffron anymore.
He has no
So
specialty.
deflect the dumb
We're not
shit.
talking about Mike
That you would
Heffron.
say that.
Real quick. I'm gonna
No,
give you guys a
Answer my
hypothetical.
question.
Wesley and New
No,
Perspective. You
Wesley,
guys
just
gotta
shut up for
New
a second.
Perspective. Stop. Hold on. Wait. Wesley, we're talking about Stephen Young because Cole brought him up as a quack. What specifically, Cole?
I didn't bring him up as a quack. I said
Nobody
you guys
brought
will
that
pick
up.
the one
Pure
out of
Rigor
10
did.
million
Yeah.
who goes against what the entire body of science says, and then those people, when you dig into them, you always tend to find things
So
that
you
seem
don't
really
Always.
suspect.
Keyword always. Okay,
Yeah.
Stephen Young, you found something
Just
wrong with
like
him.
Josh
What
just
is
now
it?
talked about. That's the reason why he didn't like
And
that
you're just
dude.
gonna
That's
ignore
how
it.
it
You're
always
just gonna
is.
keep ignoring it.
So
and
you don't
fucking
even know
rambling
what
on.
You just know that if Stephen A. Young is
I'm not
agreeing with
talking
our
about
side.
any specific person. I'm talking about you all and what you all do.
You said
Yeah,
always.
Okay, wait. Since we're not being specific, I'm going to say what I was going to say. Since we're not being specific, we're talking about general ideas or opinions, and biases and all that. It's understood that, there's that going on here. But the thing is hypothetically for Josh or Cole or even Wesley, I guess, if the case is that someone published something, if someone has a paper that they're using for the doctorate or whatever it is, whatever their paper is, and it doesn't get published, and the actual reason is because it doesn't follow the mainstream, even if it has sound science, right? Like if there is that kind of quote unquote conspiracy going on where there's a mainstream narrative that's actually false, and if you try to publish anything that doubts it whatsoever, you're not going to get it published. If that's the case, hypothetically, wouldn't you think that there's something wrong there? If that were the case?
You should make
Well, here's one thing about it.
No, you have to admit to that, right? You would think there's something wrong there.
Okay, wait a minute. You hear me?
Go ahead, Leflane.
He claims to be, according to his own description, it says in there, Master of Science. And then I found the article, it says, though he claims Master of Science, he does not have a Master of Science degree. So he's all about theology, and he works in the intersection of theology and science.
Okay, go ahead, post
It
that.
says he has a PhD. Hold on. It says he has a PhD in theoretical physics. Is that what your understanding is as well?
PhD in theoretical physics. Let me check that.
Yeah.
Well, that's what the
first,
thing you just
first
posted.
line.
This is the link tree you just posted. And all I'm
He's
saying
got
is
more
if he
than
has
that,
if he has
Gio.
the PhD, then he likely also has a master's.
Yeah, that's his self description, and I want to check that PhD in theoretical physics. I want to look at that too.
All right, we're gonna hold your feet to the fire, Leflane.
Does anybody want to answer my hypothetical? It would be wrong. It's an obvious no. That would be wrong if it's a bias that you go against the mainstream in any way, and the
Yes, if
mainstream
you
false. That would be wrong,
have an
right?
answer,
So that's what we're talking about. So having looking up people and finding out something and seeing that they're not like the biggest mainstream cock, that's actually an accreditation to them if the mainstream's actually not giving the fair narrative, right? And they're biasing it based on pseudoscience rather than real science. That would be something you'd even have a problem with if you realized that were the case, right?
No,
That's
if
all.
it was the case, yes. But like for
Yeah,
Mike Heffron,
but you just haven't looked into it enough.
when he does his self theo and it's doesn't it's straw manning and he has to correct it multiple times, then yes, then we can say that.
Yeah, I want to clarify something too with Stephen Young.
You know nothing about self theo.
He holds
More than you,
both
way
a
more than you.
Master of Science and a PhD. He's an author and a musician.
Where are you reading this from?
On his biography, on his fucking webpage, if you just clicked it and gave a shit.
I am. I'm asking you where you got it. I thought you had another source.
Homepage on his website. Scroll down, dude.
I know. I'm on it right
biography.
now.
It says
But
biography in big bold letters.
Just in this whole conversation, I will say, I do think there is something to credentials, like to a degree, though. Because there is a system that does have certain credentials, and different colleges do have different levels of what they're putting forth. So there is something to be said for that too. Like if you want to get hired at a certain company and you needed a PhD or a master's, they might deny you because you didn't get it from a school that they would approve of. So that is a thing. And then also, yeah, like if somebody has a PhD and then they do something in a field that's not in their PhD, like Wesley's saying, like with what he was saying about Heffron, like has a degree in something that's not, what would you call the self-theo? Like earth sciences or like geophysics or something? And like that's not technically what his degree's in, right? It's in computer science. Is that what you're saying?
Yeah, but if he has expertise, if he has like on the job experience and things like that I would totally accept that too. You both degree and work life experience.
The other thing, just as like a meta point to this whole topic, though, the other component to it, though, is that credentials are not necessarily always something to look at as well. Like somebody could have really high level credentials and they could either be totally wrong or just corrupt or deceptive. And if you took their information, you'd really be led down the wrong path. Whereas someone else may have even no credentials or credentials from something that, is not considered as high ranking or whatever. And they might, be a genius and have some truth or some information or invent something or whatever it may be. So you'd agree with that as well, that there's like a lot of variation and it's not always credentials.
Yeah. The guy from Harvard who now believes in he's proven aliens or something like that. You have to take the whole thing.
Who's proven aliens?
So then we should just take the
Oh my
information.
gosh,
Error
he's not
bar.
even, he can't even follow along.
All right. Well, then
No,
wouldn't
I
the
know. I'm saying
also,
that guy's probably. You go ahead. Sorry.
well, then wouldn't like the wisdom here be to well, we could go on that if you want, but wouldn't the
Yeah,
wisdom?
look at all
My
the
last
work.
thing I wanted to say, wouldn't the wisdom be then to look at what they do and
Yep.
look at their credentials as a backup or as an extra thing as well? Of course, it's good to know everything, but I'm just saying to go off what they are doing or putting forth rather than only off their credentials.
Of course, that's why on your CV or your resume, you list your degree, you list where you went to school, you list your work history, and you list any skills that you've picked up along the way. I mean, all of that is important.
And again, back to the hypothetical. If the mainstream credentials are only based on following a mainstream narrative that actually is just pseudoscience, then the credentials really don't mean that much to begin with, in a larger sense. But Beast, wasn't Mike saying something about like the ether and how he was putting forth something about the ether and what he thought about it, and he was getting some pushback professionally on that? Wasn't there
He's got
some story he
books
was telling about
published.
that?
Yeah, I mean, he was talking about how he had to wait until his NDA expired before he could even publish his book. That's what he was talking about. That's what me and Piezo were alluding to. Which is why I wanted to hear, like, okay, I wanted to know your reasoning for why you didn't trust him. You said it was Colorado Technical University.
With a civil cert, you get read out. You don't hold an ND. Oh Jesus! See, that's another red flag to me.
No,
you
just
don't hold NDAs with government agencies. You get read out of programs. And you're never allowed to talk about them. NDAs are only for proprietary information.
Yes, exactly. He says there's certain things they tell us to never be able to talk about, but the NDA was for a specific company, and I can't remember off the top of my head right now. I'd have to ask him again.
I say that's also not confidential paperwork as well. He could show you the NDA.
He's such an honest, open book kind of guy, in my opinion, and I think a lot of other people's. I think he talked like directly to you about all these questions
100%.
you have, and you might have a different opinion.
100%. I haven't interacted with him in months. I'd be more than happy to have a conversation.
100%.
I was just going off my gut.
But I don't trust him. 100% he's open and honest. I think he's open and honest, but I don't trust him. Yeah, it makes no sense, dude.
Once again, the difference between him lying and him not telling the truth are two different things.
It's so weird.
Oh, really? Really? How are those different?
Lying and not telling the truth are two different things.
Yeah, you don't understand.
I don't know if he's being malicious.
Out of your mouth is fucking
Lordy.
unreal. Okay, Wesley, break that down. What's the difference between not telling the truth and lying?
Because you can believe what you're saying, which would make it not a lie if you believe what you're saying, but what you're saying may be wrong. So you believe what you're saying.
So he just believed he worked for a company he never worked for. So he just believed he worked for this company. That really was just like an
not a
like
company.
some kind of like.
You said the NRO. Oh Jesus.
He thinks new perspective thinks it's a company.
Yeah, Wesley. Every time you laugh, it just shows how much you don't know. Every time Wesley laughs from now on, you know that he's wrong. That's just basically what he does.
So funny.
He's getting off on you.
He giggles like a girl when he thinks like there's a moment.
He's getting off on your ineptitude. It's okay.
Yeah. Okay. So you're just gonna keep throwing darts, huh?
No, just I don't want to make you feel small. I'm just trying to call it as see it.
You could never make me feel small, bro. You never could you.
If you have to say that, you're okay.
Yeah, but if you have to say that I have to say, then that indicates all I need to know. Because it's just a gut feeling about you, bro. I know 100% that you're definitely an honest liar.
Yeah, gonna be okay.
What was the issue that this was on now? What are you guys on? Wesley, what was the thing you said that's led to this?
I don't even remember. Oh, he said that he didn't understand the difference between
telling the truth and lying.
Yeah, and why there could be they're not exactly opposites.
That's obvious, but what thing he was saying that Mike was lying about is where he worked, right?
Do you know that NRO is not a company?
Yeah, it's a national
I didn't say
reconnaissance.
company.
office.
Okay, whatever.
Whatever what, dude? Is it not the National Reconnaissance Office?
Give him time to Google it.
Oh Lord.
He's already admitted he's biased, and we shouldn't take anything he says about Mike seriously anyway. We should just move on.
Okay, that's fine. I'm okay with that.
Oh, here we go.
All right, so Josh, do you agree that this celestial theodolite method, as time goes into the future and more and more observations are done, more and more tests are done in other areas as well around this cosmology question and the shape of the Earth and everything related to that? Do you agree that it's possible that in the future, 1 year, 2 years, 5 years, etc., that this method will be seen as valid in the future of humanity, and therefore his credentials wouldn't matter because it is valid still? Are you
Oh,
open to that being a
I'd
possibility?
like to see him publish on Cell Theo. Outside of a Discord, I would love to get a couple papers out there and have the wider community comment on it.
Okay, that's fair.
It's my understanding that Shane said that they're retiring it. Is that not what you heard, Gio?
No, it's just that's not that they're retiring it. Alan talked about this. Okay.
As far as I know, what Alan's
So,
told me, he's doing another show. He's doing a new show. It has a new name to it and everything. He's going to do it at the same time on Mondays. And it's a new show, and he's going to be covering a lot of different topics. He said they're going to do like special Cell Theo updates as well.
Okay.
So like when there's data that accumulates, and when they need to do like a specific Cell Theo update show, they'll do that. I don't know whether he's also going to incorporate some Cell Theo into the new Monday show. I guess we'll find out. I think tomorrow may be the first one. I think he said he's going to do it. I think Monday tomorrow. So, yeah, but that's all as far as I know. So no, I don't think it was retired. And he told me that they'll still do special updates for it.
No, that's good. Shane might have been
yeah, he
joking.
said it was exhausted as far as like what the ballers are willing to look at without like, just reverting to it has to be a globe regardless of all this damning information that I have to deal with. Fuck it. They just made it like an unfalsifiable claim after unfalsifiable claim, and they stuck to that because what else could they do, right?
Thanks, Gio. Shane had said something differently, but now that I look at it, it might have been a joke. So thanks.
Okay, that I did see that screenshot. Someone had posted something like that. They may have been Shane joking, like that they retired undefeated, quote unquote, LOL kind of thing.
Yeah.
I think he might have just been joking. But
oh no, he wasn't joking. They definitely retired undefeated. That wasn't a joke.
Yeah, but the Cell Theo's not over. They're still collecting more data, so it's not retired, right? I mean, the method is not retired. They're still going to be doing the method.
Oh, well, it's retired in quotes, but undefeated for sure.
Well, the thing is, I was just gonna say, if you're going to be doing one show on one thing, I mean, how many shows did they do? Like that was like years, like that was year plus for sure, right?
I was gonna say, I feel like Cell Theo or Celestial Theodolite just had a branding issue. I would try to understand, and my eyes would glaze over.
People were trying to sell it. It was just information that was damning to the globe, and it really got exhausted and with the Globers coming on, and they had nothing. They had nothing the last few times they came on, and then you have to deal with Jesse's bullshit the whole time, which is obvious as well. So yeah, it got exhausted in the way that it was useful for everyone to continue hearing the excuses.
All right. So
I think
we
it was like a whole year.
Straight
It was like a whole year of shows, right? Because they went to Antarctica in December 24, and I remember it was a couple months later, is my memory, like last spring that Cell Theo started. Is that about right, Beast? So it's like a whole year of shows?
Oh, Cell Theo, yeah. September 26th is when he came to us with his Celestial Theodolite. But I'd like to set the record straight because I want to put Left Lane's money where his mouth is. So you said he's not an actual doctor, or he doesn't have an actual PhD in theoretical physics.
No, I didn't. And I didn't say that. I just sharing what I was reading.
Yeah, you said he didn't have a master's, which was just in factual.
Yeah, that was what it was, a side comment thing. It wasn't factual. No.
Yeah.
So this is from the Department of Physics and the University of Surrey in May 2004. It took me a while to find it, by the way. And this is probing nuclear halos with pion photo production. Now, I have no idea what the fuck that is. But this is his dissertation from Surrey University. And then I could look back. and post
He did it on
real-
nuclear physics.
Yeah, that's it right here.
He talks
And
about it
then,
in his videos. He reads from it.
Yeah, and then you got it says he did it. He got the masters at what the hell was it called? St. Andrews. So there is an actual masters of science. Where is it?
Beast, where did you say he went to school?
St. Andrews.
What country? Or you said Surrey? Did you say
Scotland.
Surrey? Okay. I was like confused because MSCI that's not Masters of Science in the U.S., but that makes sense if it was from overseas.
Correct. I mean, credentials can be important. They can also be complete bullshit. Like it's just it just lowers the error bars on the person you're interacting with.
So you guys actually understand why appealing to credentials is a fallacy. We just experienced it just now. If I were to say like, oh, this guy is correct in his argument based off of his credentials, that would be a fallacy.
He never said he did
Nobody
that.
said that.
I
It's
know.
just wait till I
know.
start appealing to credentials and making sure everyone can can do a basic logic test, right? Like they can form a basic
Great
logical
input.
argument.
Great input as
Wait till
usual.
I start getting people's credentials, see what happens. It's a wrap.
No,
Yeah,
it's just relying solely on their credentials is fallacious.
Yeah.
But relying on
Agreed.
their work and their work and their supported work, if they got papers written, are they significant? Have they won a Nobel Peace Prize or Nobel Prize or
That's appeal to
whatever? You know, it
consensus.
depends on their validity of their credentials.
No, that's
Right,
no.
and we
You
use
just
like logic to determine whether or not something's valid. So just wait till I start giving people basic if-then statements, see if it's sounding valid, and see if their credentials can handle it.
And Left Lane, it's always a good idea to like read something slanderous about somebody and just read it off as if it's like something people should go by when you didn't look into it very much further at all.
Oh, you
Mine
mean like
Jock is
about
gonna
you mean like
start
when you talk about
hosting
NASA,
debates.
right?
My Jock said he's gonna start hosting debates.
You
and he
have
would
no
send like
idea what
basic
it's talking about.
logic courses to people. You know, just basic logic courses. See if they could. These little tests. See if they could pass them. And no one could pass them. Simple, basic logic.
It's all relative, baby.
Yeah, you have to give up all common sense to be a Glober, in my opinion.
But you're biased.
No, I just don't see any common sense in the common narrative. The consensus doesn't have a lot of common sense.
Yeah, but I have common
Especially
sense and I'm a
you're
Glober.
you have some common sense, but I think there's been discussions between us where you're denying your common sense to favor the globe. Regardless of that, you're denying all your common senses as well as your common sense allows the globe right now. Maybe you don't see it, from where you're standing.
Matthew Learns is a rare breed.
I like Matthew. I do like you, Matthew. I just really wish you would give Celestio Theodolite a fair shake. I still haven't heard a fair shake from you on that.
Yeah, I think that the light bends too much to make it to make it clear if that makes a difference between flat and globe. But we don't have to talk about that right now.
Okay. I would like to though eventually.
Okay, fair enough. As far as denying my senses, I deny my senses every time I use Wi-Fi or my cell phone. I can't see any radio waves.
Yeah, but that's like the standard that people point out, kind of like, oh, you don't feel it on an airplane, so you could be going all these different directions at millions of miles per hour. It's the same thing. It's like taking one small example and then blowing it up to represent like a larger concept. I don't know why that
It's called a
is
Mott and
satisfying
Bailey.
for you. Yeah,
It's just an
I guess
example of the
it's
fact
enough
that
for
our
you.
sense.
Good enough for you, I guess.
Oh, sorry. Yeah, it's just a simple example of when our senses fail us. We don't see radio waves, but we believe they exist. That's all. It's nothing more than just a little analogy.
Yeah, but it's not something you should sense, right? Radio waves aren't known to be something you could sense, so it's a non sequitur.
Yeah,
Right,
you
and
also
neither is the acceleration due to the rotation of the Earth. It's below our threshold, so we shouldn't sense it even on a globe.
Or
God,
velocity.
those threshold tests, man, those are just such bunk tests, bro. You look
No,
at
you can measure it.
you provided them. You
You
sent
can
them to me.
measure it.
Threshold test. You can measure it.
Well, wait. Measure what?
Did they do multiple directions?
Measure what?
You
Let
can
me-
measure. You can measure the ability of human beings to sense acceleration and compare that to what acceleration might happen due to the rotation of the Earth.
No. Left Blade said you can measure it. Measure the rotation of the Earth. How?
No, I'm
Not
talking
with your
about
senses.
exactly what Matthew is saying.
What?
Yeah, it's a reifying claim, but like the threshold within a certain range makes it plausible that if it was consistent enough, you could possibly be within that threshold range in the one direction that we tested, that we gave, certain results for. I mean, it's just to satisfy people that want to believe that they're, in my opinion. But you did multiple
I
directions.
can give you the numbers.
Anything
What
comparative to all the directions.
What direction of acceleration do you want
Nothing
them to
like that.
use?
Nothing comparative to what we were actually
No, I
going
can
through
give you the
supposedly
numbers.
on the planet. Post it
No,
in the chat.
okay.
Post
Well,
the
if you
threshold test.
quit your rambling, we can give you the numbers. It's 0.003 meters
I've
per
seen it.
second at the equator, and the human threshold is like 0.05 meters per second. So it's well below our ability to feel it.
I know that's the claim. It's just
Isn't
that
that
the
more
extremes aren't
credence to
represented.
No, it's
Perspectives
empirical.
argument?
Not a claim. Got the numbers to go with it.
And I posted it from cornell.edu at 36 past the hour.
Okay, so
Cool.
if we
Thank you.
can't sense it, that's fine. That's fine. Then we should have an apparatus of some sort that can sense it. Correct?
Right. The point is that human senses aren't always reliable for telling truth. That was the main point.
I agree with you. Now, do we have anything that actually substantiates these numbers?
And on that point, we know that they're not always reliable, but it's like the next step then is they're never reliable. You can't count on them for anything.
I'll ask it again though, but in a different way.
Let me answer.
Is there any device, experiment, or demonstration you can point to that can justify these numbers?
So we know what we say the shape of the Earth is, so we know what size the sphere is, and we know what size the speed that we're supposed to be rotating. So we can calculate the centrifugal force on that an object at that point going around a circle at that speed at that size circle. So we can calculate that.
You
So
said we know, but you should say we assume.
I'm not done. Let me finish. I'm almost done. But another thing we can do is we can weigh something at the equator. We can weigh it several times all the way towards the North Pole, and we can measure the difference in weights that things change as you move from the equator to the North Pole, and that directly correlates with the size of the sphere and the acceleration that we should think. So we can do different things to determine that. Yes, should be.
It's just an assumptive calculation. You just admitted it.
No, I also said you can do physical weight measurements from the equator to the North Pole to show that it matches perfectly with
what? It's affirming the consequence, dog.
It matches with a sphere that size spinning at that speed.
Okay, so there is no actual physical demonstration that shows Earth's rotational speed.
I'm sure they might be. I don't know. I don't know everything. I just know that we can do that, figure it out.
Yeah, okay. All right.
Yeah,
cool.
based on assumptions.
I just wanted to.
By the way, the threshold test that you linked, Matthew does says page not found when I tried to click on it.
It's perfect science.
That's
That's making a hypothesis of the size of the Earth and then using weight measurements at different locations to determine that hypothesis is correct. How is that using assumptions?
If the Earth is this
size,
no, but that's called affirming the consequence, dog.
Everything's called a fallacy to you guys.
No, if the Earth is this size,
That's your out.
this would
Call it a fallacy, guys. It's all over.
It's affirming the consequent, not a consequence.
Wait a minute. For Left Lane and Cole, you guys both hand wave dismissed what he said, which was that's affirming the consequence.
There's the fallacy guy.
Yeah, so just to be clear, I mean, affirming the consequence of formal logical fallacy.
I really don't
So
care.
for you guys to dismiss it, can you just tell the room what
No,
affirming the
because I don't give a
consequence is?
shit
Or
enough
how
about
about the
that
preponderance of
fallacy
all
to
the
worry
other
about it.
evidences?
Oh,
Okay, so you guys get super
spurred.
triggered. You dismissed what the man said. You don't even know what the thing is, but you know it's not that.
No, I
Just let
know
the
that. I
audience
know
see
that when
that.
you don't have an answer and you know you're losing, pops up the fallacy word.
If your
No,
argument
I'm
is
not
affirming the
losing.
consequent, it is an invalid argument and it's
Yeah.
false.
All right. Sure
All
it
right,
is,
all right.
Einstein.
So remember what I asked for because I wanted to know how these numbers were justified. You said that they were an assumptive calculation based off of certain other assumptions, like the Earth, the size of the Earth, that certain weights weigh certain, it weighs differently if you go from pole to the equator, etc. That didn't give me any demonstration or justification.
And it also matches with all the other experiments we've done to figure
What's
out
all
the
the other
size of the
experiments? I'm
Earth.
just asking for one. That's my point.
I don't know. What's the one where they measured all the triangles across France?
What?
Shit, what was
What
the
does that
name of
have to
that
do with
one?
the Earth rotation?
That showed the curvature of the Earth.
I said Earth rotation.
Bob
Earth
Nodell.
rotation. The sun. We can measure the sun and how fast
Oh,
Yeah,
it
ring
moves
right
around
now.
lasers.
in a circle and come
Holy
back to the
shit,
same
this
You
is
seem
point.
to be
crazy.
highly distracted.
It's not
And
very
just for the
hard.
record, let it be known that Cole and Left Lane do not bitch when Wesley calls out fallacies or
Iner-
anything else.
inertial navigation systems on
No, I
airplanes.
ignore 'em.
Inertial navigation systems on airplanes demonstrates the rotational speed of Earth.
Demonstrates Earth's rotation, yes.
How so?
The fact that all these things match up is a big indicator they're correct.
Probably doesn't matter how so.
Yeah, it would matter. It would matter. And what about before the inertial navigation systems? How did planes
No,
fly
it
before
won't
that?
matter. I can tell you exactly verbatim how it matters, and you're just
You
going
guys
to
hear
call it a
yourselves?
fallacy or something and hand wave it. That's how you do.
Dude, you don't even know what the
So do
fallacy
it without
means,
being
so you can't
fallacious,
say it's
bro.
not that. You're done.
It's
Like,
so funny.
why can't
Even
you
if they
like
gave
put
you the
things forth?
explanation, you wouldn't even accept it, pure rigor. You understand?
That's
You wouldn't even
acceptable.
accept it. How
It's such
crazy is that, dude?
nonsense. It's like I can't make an argument without being fallacious, therefore you must accept my fallacious argument.
Dude, it's
Do
10
you understand
years
how
of this
absurd that
bullshit. Is
sounds,
what it
dude?
is.
Oh, so you
Yeah, I
still
know
don't
how
Yeah,
absurd
and
all
section then?
you
fallacy is
point
every time you start losing. I do know
Dude,
how
in 10
absurd
years,
you
this
you
is.
point
haven't
out a
learned
fallacy.
basic
It's because
logic
you're
that you
losing. I'm
learned
just
in
going to
ninth
assume
grade.
that now.
In 10 years, you've heard this. You haven't learned basic logic that you could learn in ninth grade? Good
I don't
lord.
understand. How did you guys get anywhere with like reading comprehension? Like your verbal skills cannot develop unless you're logical.
What do you do for a
Do you
living,
understand
Rigger?
that?
How successful are you as an individual?
Do you understand how bad your verbal communication is going to be if you're illogical all the time?
Not bad at all, and that's not illogical.
Yeah,
You're
when you're
illogical.
being
Calling out
fallacious
fallacy,
and
calling
making
out fallacies
illogical arguments, like you can't
constantly.
even argue with people without being
Like
illogical.
you're a
So it's based on
literature
emotion. You're
professor.
saying my emotions are more important than your logic.
No. What I'm
Okay.
saying is you
good
and
luck with that, buddy.
a few
I
others
just wanna-
act like you're literature professors who are so great at speaking that they never speak fallacy, but yet
No, I
every
sound
time the
retarded
other
sometimes.
side makes a very good claim that's very hard to go against, it's fallacy this and fallacy that.
No.
You're
Cole,
not
Wait,
as
first off, you
intelligent
don't
as you
know if
think
it's
you
a
are.
good claim.
That's
You
what
don't know if it's a
irritates
good claim
me.
because you don't know what a valid or sound argument is. Second off, you should look into how to make a valid or sound claim. Why wouldn't you want to?
Because everything can be called a fallacy in one way or another.
Not formally.
That's
so.
And you
true.
guys prove it.
That's
Here's
not
the thing.
true.
Can I jump in? Oh, Cole. The thing is, not everything can be called a fallacy. I mean, you could do it, but it would have to be rebutted as to be a fallacy or not. Yeah. And Cole, I just want to ask you, like, in terms of being upset about fallacies. So if
I'm not
two
upset
people,
about it.
if you were debating someone, and you give a really good point, and they come back with just a pure insult, and that's it, that would be an ad hominem fallacy. Now, wouldn't you want that to be called out?
Exactly.
To me, I would probably just move on with the conversation.
And just what? Get no response to what you say, and just be
Okay,
like, well,
so that's
because
okay. That's
good enough for
because
response.
what I said, what I said was true. What Left Lane said was true. But now the whole conversation's been wrecked because literature experts in here who seem to think they wrote the English language or something want to
Oh my
derail
goodness,
it
being a
by yelling
positive.
fallacy all the
Come
time.
on, bro.
It's
Okay,
dumb and it
let's
makes
try
no
to
sense.
circle down what
Gio.
Cole and Left Lane are
But if
saying.
somebody said,
They
if
don't
somebody
like
says a
when
fallacy,
fallacies are called out.
if somebody calls out a fallacy, the best in a debate, at least, the best thing to do would be to respond to rebutting why it is or isn't a fallacy. Because
Oh,
just like
I
the ad
disagree.
hominem, just like the ad hominem one, or imagine that you're debating someone, you're on a big stage, you're debating, everyone's listening, and the guy, let's say he says, well, this authority said it's true, therefore it's true. And he just kept saying that over and over and over. This authority said it, therefore it's true. This authority said it, therefore it's true. True. Well, that's an appeal to authority. Now, that would be a major problem for you in the debate because it's completely fallacious. There's an issue with appealing to an authority because just because they're an authority, it doesn't mean that necessarily what they're saying is true. We would agree with that. That's not logical. Therefore, that has to be called out as a fallacy and so on. So if you're suggesting just no fallacies get called out and points can just be made, does that mean that you're arguing for a situation where everybody can just be saying fallacious arguments nonstop with no check for that?
No,
Yes.
what I am trying to say is that everybody in the room understands what we all say. So to yell fallacy this and fallacy that, basically when a very good argument is made, is just
It wasn't a
derailing
good
the
argument.
conversation. So
Dude, you've
you
admitted
believe
that
what
you
you
do not
believe. I'll
know
believe
what
what
a
I
good
believe,
argument is,
and you
though.
can just move on with it. The conversation's done.
I
been
explained
derailed
why
well
it's not a good
enough.
Wasn't an
argument,
Cole and
though.
argument.
Left Lane, you
Wasn't a
guys
good
have
argument.
admitted that you do
It
not know
was
what a good argument
evidence.
is, and you do not care to
It
know
was
what a good
evidence
argument is.
presented. It was evidence presented, not an argument, and y'all called it a fallacy.
You didn't present any evidence. What are you
Oh, that's
talking
it.
about?
Oh, you want me? Do I have to go get it and show it to you again, or do you
It's,
know about it already?
you said
Dude,
inertial
evidence
navigation systems
presented
show.
is not in and
Oh
of
my god,
itself a
Gally,
thing. It's evidence presented for a
We,
specific
Gally,
purpose.
Gally.
You
yeah,
say,
we can
here's the
present
evidence.
multiple observations of weight change with latitude. Wolfie 6020 did it. Bob the Science Guy did it. MC Toon's done it. He's got a
MC
whole
Toon did it on the way
library.
to the
He's
South
got
Pole.
he's got a whole library of evidences that we could present and lay out for you, and you're just going to call it a fallacy.
What?
Well, is it fallacious? Because if it's fallacious, then it should be labeled as said fallacy, and so we can all understand. Because we're here to get to truth, not just to play games. We want to get to the truth.
Oh my God, you would know the
Tuesday
truth.
get to.
You're going to label it a fallacy. That's what you're going to do, and then that'll be it.
No,
Labeling everything a fallacy
something,
say
hold
you
on,
not
yeah,
get the truth.
but if we're debating and it's a courtroom style type of debate, if there is a fallacy, it's very important that that fallacy is addressed. Because otherwise, we're just going to run around in fallacies all day. And I don't think many of us that love being here don't want to be here where it's just fallacy after fallacy. That's game playing. It's just playing games. We want to get to the truth. So it's
Establish,
Now,
establish legitimate
make
established and legitimate observations are not fallacious in any way.
Okay, Left Lane. All right, listen. I don't want to harp on this. Okay, I just want to state for the room the reason why I even brought this up is because we were talking about Earth's rotation, right? And then Matthew Learns brought up the threshold for humans to sense that rotation, and it would be under that threshold. So then I asked, I said, okay, if that's the case, then, and I agree with you that, just because we can't sense it doesn't mean it's not real or not true. So then, therefore, these numbers must come from something, right? So is there like an apparatus or a demonstration that
Then
shows the
I answered.
rotational?
Let me explain then how I answered that. I said that there are many different measurements. We know the size of the Earth. We know the spin of the Earth. We have done multiple experiments to find those numbers. All right. Since we know that, then we can take actual measurements of weights starting at the equator and work our way all the way to the North Pole. And the centrifugal force calculated, from spinning on a sphere that size and at that speed matches exactly the centrifugal force expected and what we see when we measure that. That's what I said. You called it fallacious.
Cole, yes, because I said, okay, how have you demonstrated the first part? You said we know the Earth to be this size, Therefore,
do I have to look it
Earth-
up for you? I told you that
Okay,
they've done
all
many
right.
different
I'm
experiments.
disengaging. You're
You
retarded.
can't get anywhere with him when he just fights you on it.
Here, I'll
He's
look it
gonna
up. Hold
say,
on,
"I
hold
don't
on, hold
care
on.
about
I'll
being
look it up
fallacious."
for poor
No,
little
no, he's going to
thing.
say, "How did you prove that?" You have to go all the way
Yeah,
back to
it's
first
like talking to
principles
a
for these
3-year-old.
guys.
Why?
Yeah.
Why? Why?
Yep.
Why?
Yep.
Why?
We have to
Yeah,
go
so
all the way
anyways,
back to
like
first
the
principles
whole
for
thing
them
that
to
like
accept
It's
Wesley
anything.
Cole and
fallacious.
Left are saying is just I don't like when I'm being unreasonable and my reasoning has errors. I don't like it. I don't like when you
How
tell
did that
me.
reasoning have errors? Why don't you tell me?
Your reasoning
Cole,
has a ton
let
of
me tell
errors
you this
because you
quickly.
said that
Cole, if you put
I
Whoa,
can't
Cole,
what's
if
answer.
you
going
put
on?
different numbers, Cole.
And then Wesley's going to try to chime in as well. Yeah, your reasoning has a ton of errors. You don't even know that it has errors because you said you don't care about having good reasoning.
No, I said I don't care about fallacies.
Marry up with your wife.
Wait. You said you don't care about fallacies. You know that a
Hold on,
fallacy...
John, hold on
Dude,
one second.
John, stop for a
I
minute,
really
dude.
don't care what you're going to say about it, what I said. So you might
Yeah,
as
a
well let Wes
fallacy
talk.
definitionally is an error in reasoning. I said you don't care about your reasoning. You said I don't care about fallacies, meaning you don't care about errors in reasoning. You just don't know
I
what the
don't.
word means.
Okay, let me rephrase it. I don't care when you guys call out fallacies. I ignore them, and I just think that they're just conversation
That's
killers.
the point,
Because
Cole.
they're
If it goes against
they're
you,
a tactic you guys use to kill the conversation when you don't know what to say.
It's
You're
not to
burying
kill the
yourself, and you're
conversation,
just
dog.
afraid of like developing your own reasoning. It's weird.
I
Yeah, you
legitimately
mean
was
by
asking
developing your own
how you guys
reasoning.
substantiated those numbers. I didn't know the answer. I literally was asking, like, well, how did you guys come to your conclusion? And then
measure
you
it.
said, we know. Okay, and I
Yeah.
asked, what did you measure?
All right.
I
The
didn't
weight
hear any
difference.
measurement.
Says
weight
direct
difference.
satellite photography, ships disappearing bottom first, the circular shadow cast on the moon during lunar
That's
eclipses.
curvature. I said
Consistent global
rotation.
navigation. Rotation is from watching the sun set and rise. If we know it's curved and then we know it's a globe, then we know the sun is going to go around at a certain speed, and we could
You gotta
measure
be
that
drunk, man.
and determine the speed that we're spinning.
That's wild, dude. Okay.
You
Yeah,
gotta
it's
be
wild,
drunk,
isn't
man.
it? Yeah.
Can we stay on
Coco
one thing?
pendulum,
Those
yeah.
are a bunch of different topics. Those are a
You
bunch.
just
That's
been
like
asking about motion,
Can we
not
stay on one
curvature,
thing?
and Cole just
Coco
sends a bunch of
pendulum, Bob
so-called
Nodel's
curvature.
gyroscope.
It's crazy, man. He's asked for a very simple question. Cole, do you even know the question that you're answering?
Yes, he asked how we know the Earth is spinning. And I
Right,
just
and then the
answered.
examples you gave, do they show Earth's spin or do they show Earth curvature?
Direct satellite photography does show Earth is spinning. Let's see. Constant global navigation that shows Earth is spinning because
Would
we
that be
have
the
to.
same if the Earth was geocentric and things are moving around it?
No, because when we built things like the Saturn V rocket, we literally had to put a laser on the ground shining at it through a prism so its internal computer could keep up with what point the Earth is rotating so that it could constantly update the computer before launch, or it would think it was facing in a different direction than it was really facing. We have to do things like that. Actual things in real life. That's how we know the Earth is rotating.
So if the sky was rotating and
It
the
would not
rocket,
affect it at all.
hold on, if there was a celestial sphere, not a literal sphere, but but I'm calling the celestial field where all the stuff up in the sky was rotating, and it was the same rate at which the Earth rotates, and something flew up into that, and that rotation was happening. You don't think that would be equivalent?
It's not exclusive at all. The Saturn V works perfectly fine, assuming the Earth is geocentric and stuff is
No,
moving
it does
around
not
it.
at all. No, it does not at
Okay,
all.
prove it. Show the
Okay, hold on.
exclusivity.
I'll post a video that
You
shows the
interrupted me to
entire
say,
thing.
hold on. You interrupted me to say, hold on.
Yeah,
Show the
'cause you're saying show
exclusivity
it.
that shows that it can't work if the Earth was geocentric and that it must be heliocentric for it to work.
Right.
Because then you wouldn't have the extra del TV of Earth's rotation. So your orbital,
it's not
the amount of energy you would need to reach the amount of energy you would need to reach orbital velocity would be much higher.
It's not
if you
Okay,
weren't
you guys
doing it.
understand what an
Can I
exclusive
please
proof
explain?
is,
You
right?
asked me the question.
This
Let
is
me
crazy. You're
explain.
like tag teaming. Someone makes a point, and then someone else makes a point. You guys know exclusive proof means it cannot be explained under any competing model. Does the Saturn V meet up to that criteria? No.
Yes.
No.
And let me explain how. Because when it's setting on the launch pad,
its computer and its internal navigation system has to know that it's pointing straight up. When they first turn it on and they turn everything on, they have to link it to that ground laser system that tells it which way it's facing straight up. Because if you just because it's got a spinning mass gyro on board, actually it's got 4 of them. And wherever you start those things at, they lock themselves in that position. And they think that is straight up. Well, if you go for 12 hours without launching, the Earth has moved. So that gyro now is telling the rocket that it's laying on its side instead of still standing straight up on the pad. Because it has moved a quarter of the way around the planet, or halfway around the planet. It's laying on its side at this point. Or a quarter way around the planet, I guess you could say.
Yeah, it locks
6
in
hours.
an
But
initial
anyway,
orientation.
so
Initial
in order to
orientation.
keep that correct, since the Earth is spinning, they had to build a specific device setup and that talked to the rocket that constantly updated its computer all the way up until like 20 seconds before launch when it took over, so that it would know where up is because of the rotation and spin of the Earth.
Yeah, so it
I'm finding the
locks in
video
an
right now to
initial.
post it.
Dude, when are you done? It locks in an initial orientation at launch, and then it tracks any deviations or changes from that with an accelerometer and a gyroscope.
Talking about
So it knows
before
the-
launch.
Dude, I did not interrupt you.
Yeah, come on,
So anyway,
Cole, let him.
there's the local vertical, that's the direction of gravity. There's known geographic coordinates, and then there's sometimes star sightings, so you can calibrate it. That works the same if the Earth is rotating
No,
around the sun or if everything else is rotating around Earth. You haven't
no,
put
it
in
does not.
anything that's
They
exclusive.
they do not use the stars when it's sitting on the launch pad. I'm not talking about after it launches. I'm not talking about when it's in orbit. I'm talking about when it sits there and they turn the computer on, because you don't turn the computer on a minute before launch. You turn it on like a day before. And you're getting everything ready for launch. You're getting the people loaded. You're getting everything set. You're doing all your checks and everything else. When they spin up these gyros, they think that where they're at is pointing upwards at that moment. It don't matter what the
Okay.
stars are doing overhead. They're not looking at the stars. They're a spinning mass. So in
That
order
doesn't
to
address the point.
constantly
That
update,
doesn't address the point.
where up is, which way that
Okay, so
rocket
that
is
was
facing,
one of
as
3.
let me finish.
Dude, you're
As the Earth is orbiting,
misrepresenting what I said.
they have to use their laser device that I'm getting ready to post a video of showing how it works to constantly update it that whole time, so it won't think that it's facing in a completely different direction
You
than
just
it really
repeated it.
is.
You're just repeating the same thing, dude.
I know,
Okay.
because
Yeah,
every
so
time I say it, you guys come back with something wrong, just
So
like you
what you
said a second
addressed
ago, because
was
he don't listen.
part of my justification for how sometimes these ships orient themselves. That's all you refuted, saying it doesn't look at the stars. But my main point was, how is that exclusive to a heliocentric globe and not a geocentric globe?
If
You
It's
need
you
not
did say it's
exclusivity,
exclusive.
right?
impossible,
It's
you said it's
exclusive to a
impossible.
spinning globe.
Why?
Prove it.
How? That's the question.
Here,
Why
You
would
haven't
a
proven that yet.
rotating universe? Why would a
Shouldn't
rotating
take this
universe
long.
not do the same thing?
It shouldn't take
just now
this long
found
to
it. I
get
thought
you.
it was in my
It's okay,
Discord
Cole.
page, but it's not.
Just
Here,
be
I
careful
posted.
saying you can't or it's impossible. Like you can say that it could work one way or the other, right? That's an honest take, because saying it would be impossible, you'd have to show that for sure, definitively.
The system that they use to keep it facing upright does not use the stars or the sky.
We know.
Dude, I mentioned the stars because sometimes when they orient it, they do use the stars, and you could look that
That's
up.
when it's
But
already in orbit.
that was a tertiary point. Like to my major point, you have to chime in. That's super annoying.
Because
I
you're
said
always wrong.
before launch, the platform is aligned using a local vertical, the gravity direction, and known geographic coordinates, and then they go up, and that just means perpendicular to the Earth's surface, right? And then it calibrates itself along the way to adjust to know what up
Okay.
is. That works in either paradigm.
Okay, you're completely wrong, and it shows that you don't know anything what you're talking about. You're making up off the top of your head. When it's
Okay,
sitting
what
on the
did I
launch
say
pad
that was
and it's
wrong?
sitting on the launch pad and it's running, it has to constantly be updated over hours and hours of time. It has to be told which way is up. Because if it's not towed as that spinning mass gyro, which back then was an actual big piece of metal spinning real fast inside of a complicated device, as it's spinning, the Earth is rotating and it'll constantly be drifting off course, making the rocket think it's facing upward or facing in the wrong direction. And it'll
None of
literally
that
think that
disagrees
it's
with what
facing
I
up
said.
even if
What
it's
did I
staying on
say
its
that
side.
was wrong?
Because you said that they sometimes they use the stars and on the
Oh my
way up they
God.
use different things and they don't. They use the stars
Dude, you
once they
gotta
get
be
to they,
drunk.
they
You
use the
gotta be
stars
drunk. That's
once they
crazy.
get to orbit. That's when you would use the stars to orient yourself if need be. And on the way up, they use the spinning mass gyro that was set to point upwards from the ground. It isn't till
Okay,
the
awesome.
third
So what
stage
happened
fires
was,
that they kick
you're
over
just gonna repeat
to
yourself, man. It's
the
so annoying.
upper one.
So what happened was you heard
So
look
it
at
shows
stars
you
and
don't
you
know
jumped
nothing
on
you're
it as if
talking
it was
about.
some gotcha. You heard look at stars and you jumped on it like it was some gotcha. Everything you just said about
No,
the
you've got it
correctness
all wrong.
agrees with what I said. You
No,
said that's
nothing
completely
does.
wrong. So what, if anything, did I say that was wrong? Go
You
ahead.
said right at launch it knows which way is up. No, the reason it knows which way it's up because it's constantly been updated over the last several hours from an
That's what
external
I
device.
said.
No, you did not say that.
I said they use a
And
Oh my
local
God.
vertical to align it on the platform, and they use known geographic coordinates. I didn't say they just know which way is up. Like, dude, I
right.
know you have to be drunk.
I think he is
Like,
drunk.
I do not
No,
believe
no,
you're
I
sober,
don't
man.
even
That's
drink.
crazy.
What I'm trying to tell you is that while it's sitting there, its computer keeps drifting off, and it has to
Why does that
constantly update
matter?
it. That would not happen if it was a flat stationary Earth. It would have no need to happen because the sky wouldn't make a gyroscope drift off.
Why not?
Baseless assertion
And
doesn't
it
even
also
understand the
drifts.
claim.
Guess what? It drifts at the exact rate we would expect when we calculate the size and spin of the Earth. Well, there's just yet another thing that all fits together in
What
one
would
moment.
the difference be on a geocentric Earth?
Because it
He's
would have
saying
no
that
reason to drift off. If
the only
nothing is
yeah, hold
spinning,
on.
the gyroscope will stay stationary.
Yeah, the only thing I think okay, but if you had a globe, stationary globe, and it had an ether that was in motion that was causing the drift, would you then agree that the stationary globe, if that was taken into account, if there was an ether that could cause this drift, Cole, do you then think it would work?
Yeah, if you could show that there's an ether that could cause the drift and stuff, I think that would be, but there's nothing to show that.
Wait, even
Did you
admitting
say
that there's
there's
a
nothing to show
possibility
that?
that it could
There's,
not, like it could be
done.
proof, or shows that you have not excluded the thing that you keep claiming you have.
Yes.
no, it
That's
matches
so
exactly. It
ridiculous,
matches
man.
exactly with a spinning Earth. There's nothing to show that there is some kind of ether that's making it
You
get
keep
off
just
out of
saying there's
whack.
nothing.
Dude, so
There
now
is.
you go
There's no
right
experiment
back,
to
now
show
you
that
go
Oh,
ether
right
what are you
makes
back
a
to
doing?
saying,
gyroscope drift.
now you go right back to saying it can't be the case, but with Geo, you just said it could
Geo
be the
said,
case.
if you could show, yes, if they could show, but they cannot show. So no, I don't
How
think
do
so.
you know that?
Well, show me proof that they can show.
Hey,
No,
okay.
that's not how it works, man. If you're making an
All right
exclusivity
then,
claim,
exactly.
if you're making stop, if you're
Avoiding
if
backing
you're
it up.
making an exclusivity claim saying that you've ruled out a thing, you can't just say because there's no evidence of it, that means I'm not going to believe it. That's appeal to ignorance or appeal to silence.
There's
That's
another
saying
fallacy.
There's a appealing fallacy. It's an appealing fallacy.
It is. It's an appeal to silence.
So really quick,
because there's
hold
no
on one
evidence
second.
at all.
One
It
second,
has
guys.
to still be real.
Guys, real
That's
quick. I just
your
want to.
claim, man. You just so the mocking that you just
Guys.
did, there's no evidence at all, so therefore blank. You're actually mocking yourself. That's your claim.
One second
we just
before you
chill?
continue, really
Just let
quickly.
Piezo go.
Really quickly, just before you guys continue, I would like to say that maybe it would be beneficial to say this, regardless of who is correct in truth about like what's really causing it. You have to understand that when you're arguing this point, that if you say, well, my spinning Earth model explains it, and the other one says, well, my stationary Earth with spinning ether model explains it, either of you can say that there's no evidence of the other one because both of you are claiming that the phenomenon in question is the evidence. So no one has any more evidence than the other one does. So like I think Galley would accept that, but I don't know if Cole does.
That's
Like
completely true.
No, there's no evidence of ether causing anything to move.
there's
And
no
he
evidence
just
of the Earth
repeats
rotating.
it.
Dude, you got to
There's all
listen
kinds
to
of
what he
evidence of Earth
says.
rotation.
But every evidence you list
It's
could
a
be
lie.
explained under ether
The ring
rotating.
laser gyro is designed to detect rotation, and it does.
Everything,
I think they don't care about having good reason.
Yeah, well,
Pretty
here's
We don't
no,
care about why it was made to detect rotation,
no,
and
no,
it
no, no.
does. We don't care about that.
Here's the point,
I
right? Like
prefer the
if
consequent, by the
you
way.
have to think, you have to
course it
think
is.
of a proof where you have to be able to say, okay, I'm going to give an evidence that Earth is spinning, and whatever explanation I give for it could not possibly be equally explained if it was Earth being stationary and the universe or the ether spinning, right? Because if you grant the if, right, because it is a conditional, it's like I'm giving you an alternate if, right? If you grant the if and it would work, then you can no longer claim that you have a mutually exclusive proof in that thing. That's how mutual exclusivity works.
Yeah, it doesn't Michelson-Morley show that there is no movement of the ether compared to the Earth?
No.
What do you
Not
mean
at
no?
all.
They've always gotten the null result.
No.
Do you even know what a null result is in the context of that experiment?
Yes.
What?
It's within the margin of error.
Nope.
Yep.
Incorrect.
I thought it was
No,
stationary Earth with stationary ether. Isn't that what y'all say it does?
No, it's the movement of the luminescent ether compared to the motion of the Earth.
Wesley, do you know what
Yeah,
the
but
margin of error was on that experiment?
Which one?
like
The Michelson-Morley.
I know which one. It's been done many times
1887.
after.
1887.
I don't know the exact one, but it was big. But now we're 1,000 times more.
it was
Hold on
within-
a second. We're 1,000 times more accurate now. I think many orders of magnitude accurate with the same result.
Accurate than what?
Yeah, the experimental setup's completely different now, though. In the Michelson-Morley
Okay.
experiment,
So what do you disagree with the most updated ones?
Yeah, one second. You should try to make me shut up because I made one little comment. Now you're talking through me. The experiment 1887 had a margin of error of between 0.5 and 1.0 kilometers per second. Okay. The signal that they got was between 6 and 10 kilometers per second. So we are between 6 and 20 times the margin of error on the signal. Now, the reason it was called a null result is because null just means that it fails to affirm the hypothesis, which the hypothesis was that it would measure 30 kilometers a second. Since it fell far short of that, it would be considered null in that regard. But it was not null in that it was below the margin of error or that it was a zero. See, people conflate that.
All right, I'll put it. It's within the experimental resolution of the experiment. So here, I'm going to post it right now. And
Yeah, it
then
was
I'll do
not
all the ones. Hold on a second. Hold on. I let you talk, and now you do the same thing you convinced me or said I did.
Sorry.
So
Okay, go ahead, and I'll
were
correct
just
you
gonna-
after.
I thought you were just gonna post it. My bad.
Yeah. No, it wasn't you. It was him. So what? Okay. So if you don't like those, what do you think of the more updated ones since then?
The ones that they do now, they always do them in shielding and in vacuum, and that's specifically the things that make the. Those are specifically the things that make the thing that you're actually trying to measure go away. You're trying to measure a variation, minute variations in the speed of light, like directionally, right? And so, in order to pick that up, because the signal is so small, you want to be able to like make sure that you're reading that raw signal. When you put up a bunch of shielding and you put it in a vacuum, you get rid of anything you were trying to measure.
And you put it super below, like low below sea level.
Yeah.
Also,
Okay,
don't forget that.
So the Michelson-Morley experiment measured a fringe shift of less than 0.02, and their experimental resolution was 0.02. So it was less than the experimental resolution that they had available.
No, it didn't measure less than 0.02. There's a sinusoidal variant.
Yeah.
He's talking
Sorry,
about
go
what?
ahead.
So
He's
are
probably
you
talking
just
about
saying
Shanklin's
nuh-uh?
analysis.
Are you just saying nuh-uh to what they say they?
No, like I
recorded?
can give you an analysis of the actual data tables plotted in Excel for
I just put it. I just put it down. I just put it down there for you.
Put what down?
Where?
The measurements and everyone done up until 1930.
That's Wikipedia.
Dude, this is
And
not the Michelson
it's a
Morley.
summary. It's a summary analysis. What's your point?
Yeah, so once again, I'll go ahead and give you, like, this is just a table off of Wikipedia. I can actually give you from Michelson and Morley's paper, like the data tables from their paper plotted into Excel.
Okay.
And then
But it
averaged
even says
out.
it right
So
there.
was
Look.
there? The question is, was there the result that they got? Was that within the experimental resolution of the experiment?
Within the okay, once again, I already said that the experiment was able to measure within plus or minus an accuracy of plus or minus half a kilometer to 1 kilometer a second. So a maximum error of 1 kilometer per second, right? They measured a signal of between 6 and 10 kilometers a second.
Way above
So
margin of error.
are you saying that this Wikipedia is fallacious?
No, that's actually correct. It shows it right there.
Where?
4 to 8 kilometers per second. The instrument itself, the error
Where does
margin.
it say 48 kilometers per second?
Upper limit on E not E on V ether right there on the velocity of the ether right there. Upper limit.
What about it?
4 to 8 kilometers per second.
And then if you go down to Miller at Mount Wilson, it's 8 to 10 kilometers a second, right? So.
Okay, but they didn't have an experimental resolution. They didn't calculate it.
Dude, all right, Wesley, you're just saying
Wait, but no, answer.
and you're not even addressing what we're saying.
You're doing this ignorance thing.
No, it's not. No, Wesley, follow me, bro, follow me. The error margin.
First.
Hold on, I want you to be honest.
Hold on a second. I said something and then you just not on it.
Wesley.
So what they did not have an experimental.
Is Wikipedia lying? That's what you said.
They did not calculate an experimental resolution for
Oh
Miller.
my gosh, who did
it?
You're becoming belligerent, repetitive. You're not saying anything. So
they just not on my.
Dude,
there goes Discord
again.
again.
Respond to what they're saying instead of
Gally, stay out of it.
Wikipedia article lying.
We don't need your input.
Go ahead. They're saying nah. They're definitely not just saying nah.
The other guy, what?
Okay, I got you. Wesley, follow me here. Be honest, okay?
Yep.
The instrument that they used had a measurement error margin of what was it? 1 kilometer per second? Plus or minus? All right, you with me, Wesley, so far?
Okay.
If they have a result that is 6 to 10 kilometers per second, is that within that error margin to consider it a null, or is that an actual measurement of something?
So if all they were doing was just measuring it and there was nothing else involved in the experimental resolution, then I would agree with you. But you know that just the error of the instrument is not the only thing you have to take into account, right? When you do an experiment, right?
Could you repeat the question?
Yeah, I'll repeat it.
Yes. The question.
Yes?
The question is
yes, right?
No, the question. If you're asking me if their result was within the error margin of the instrument and that's all that mattered, sure. But you understand, right, that an experimental resolution takes more than just the error measurement.
Why are you jumping
Hold on a second.
around?
Why can't I finish? Are you scared of the question?
It's just non sequitur. It's a red herring.
No, it isn't. The fact that you
what
think
is the
that
question
shows you
that
don't
you're
know.
trying to
answer? I'll ask it one more time to see if you guys follow.
No, you were answering a question that he asked.
I did.
No, you didn't.
And now I'm asking a second question.
No, you did not.
Listen to my question.
You did not.
Gally,
you
why
went
are
off
you
into a tangent that had nothing to do with what he asked.
No, it does.
I didn't say experimental resolution. I didn't say any of that stuff.
Hold
on. You guys are over talking.
Just to show that you were answering the question, what was his question?
Let me ask one more time.
I know you can't. I know you can't do this, man.
Experimental resolution
you don't have the
in
ability
more
to do
than
it.
just. Gally, why are you talking through me? So I'm going to ask it one more time.
Question. Could you just tell us what question?
Gino, could you please get a handle on this?
Yeah, Gally, please. I'm going to ask the question one more time. I answer your question. If all that mattered was the. Holy cow! You guys are so scared.
You didn't answer.
The answer to your question, Beasticles, really quick.
Is yes or no?
If the only thing that mattered was the error of the machine, then yes. But do you understand that the experimental resolution takes more than just the machine error? Do you
I
understand
don't
that?
care about
Well,
experimental
that's why you don't know.
resolution.
Thank you for showing. Thanks
Because
for
that's
showing
not
you don't
where I'm
understand
going
the
with my
experiment.
line of questioning.
Yes, you are. You're talking about the air
Oh, you know
margin.
I'm gonna fucking answer. I'm gonna. You know my
Okay,
next
let's see.
questions I'm
Let's see
gonna
if you get
ask you
there.
after that. Come on, dude.
Yep. Go ahead. Let's see if you get there. Go ahead.
Nah, fucking dude, you're
Yep.
just so
Yep.
bad
Run
faith.
away. Run
Dude, you're
away.
a
Yeah, I will.
sophist.
You're
You ran
retarded.
away from his question. He asked
This
you a
is
simple yes
actually
or
really
no.
So
painful and
scared
bad. Like
of the
for you
question. All
to
three of
accuse
you jump
someone
in.
that you know, shut up, please. Like this is actually offending me, and I'm not even participating in
Aw,
it.
I know. Because you guys won't let me ask the question. You
No,
all
you just told him that
white-knighted.
you know what he's going to ask before he asks it, and then you said, "Okay, oh, you don't want to
Yeah,
say it, and I'll run away."
I'm
Like
a little
the
bit
amount
ticked
of
because
psychological projection you're doing, you don't even
oh my
deserve to be a part
gosh,
of the
you're worse. You're
conversation.
just the same as Galley.
I just tagged you. Look in the chat there. Okay, so if you look in the chat, you'll see that Wikipedia is wrong because here in the chat, it's screenshot along with the paper. You can read it from the paper, or you can see where I just put a screenshot from page 16 in there. It shows
Okay, what
right
am I
here the
looking
data
at?
table. That data table is taken from Mickelson and Morley's paper. And you see fringe shifts up here up to 0.084091.
Okay, and
All these different
what do those mean?
values.
What do those mean?
The fringe shift is correlated directly with velocity in the Sagnac effect or in the interferometrics equation.
Okay,
So
what was the experimental resolution of this for this data?
Again, no one asks about that. No one talks about that. Like, why you keep bringing that up instead of actually addressing what he's talking to you
Because
about,
that's
bro?
very important.
Why is that important?
You don't know why experimental resolution is important?
Oh, you're
Because
gonna
he
ask me a
doesn't
fucking
want to
question.
address
You're
the
just so
point.
bad
Yeah,
faith,
because
dude.
I've told you 3 times at least now what it means.
No,
So
all you said is you don't want to
disingenuous,
know. You don't want to know. You don't want to
No,
know.
I
That's
told you
you.
before this, but you kept talking over me.
He's just trying to deflect away.
You know, so
Yeah,
like
I'll give you guys an equivalent. I'll give you guys an
Oh
equivalent.
my
Beast
gosh,
asked me
here
a
comes Meta
question.
Boy.
Beast asked
All
me a
right.
question, and I said, "But how did Mickelson and Morley feel about the experiment?
Nope.
Why does
Nope.
that
Experimental
matter?"
resolution is not
Wait,
feeling.
can we just
God,
can we just
damn.
try to hold on? Can we try to move forward? So Wesley was
Yeah,
asking
please.
Piezo about experimental resolution. Piezo, what is your response to that?
yeah, so experimental like I answered him about error because I feel like it's much more directly applicable. I mean, he's wanting to talk about like because technically the definition of experimental resolution refers to like how other things, like other factors, like these different things can attribute to what's being measured. So like for example, if I'm measuring a signal and some of it's being contributed by temperature and some of it's being attributed by an electric field, and some by a magnetic field and some by light and some by heat, like all of those different factors, right? Experimental resolution would refer to like the degree to which these different factors can be identified.
Right.
And so if you have like a really really good experimental resolution, it allows you to distinguish between the main effects and like the secondary effects, so that you don't get your results mixed up. But this would be a better question for something like Dayton Miller and his work because he took meticulous care, which is in the data table from Wikipedia, by the way. But he took very meticulous care in order to account for every possible influence on the experiment in terms of variance, and he got the same, very, very, very close to the same exact result Mickelson Morley did. In fact, there's a paper that it might be in this paper actually. I think it is. I haven't. It's the page before this, where they plot the results side by side on a graph and show that they like correlate sinusoidally with sidereal time. But in this experiment, I don't know offhand exactly what the experimental resolution was. I think your data table says 0.01. So if you want to take it 0.01, we've got right here in this data table right here, like I said, 0.09, 0.08, 0.06, 0.05. All of those are well above 0.01, which is what I started out with. Didn't I say, the experiment, the error was plus or minus 1 kilometers per second, and they measure between 6 and 10. So if 1 kilometers a second is 0.01, 6 to 10 would be between 0.06 and 0.09, and those are the values on this table. It's just like what I said before. Like I already answered you. Right here it says after averaging all of these measurements in these 6 columns and these 16 rows, so that's I guess 96 measurements. Averaging these 96 measurements, there was an observable average velocity of 8.5 plus 1.7 minus 2.2 kilometers per second, which I just said 6 to 10 because it's literally 6.3 to 10.2. So that's 6 to 10.
Could you just tell me where you're reading from so I can catch up with you?
I tagged you in the chat at 11:13.
No, I got that. I got that. Where are you reading? What's on the screen or the actual PDF?
Well, I got that picture from the PDF.
I understand. So are you reading the screenshot you sent me, or off another section?
I'm on the screenshot right now.
Okay, where are you saying that? Was it at
I'm
the bottom or the
explaining to you
top?
in words what's on the graph on the data
And
table. Like I'm not reading it.
oh,
I'm
I
not
thought you
reading
were
it. I'm
reading it. I
talking to you.
apologize. My bad. My bad.
Yeah.
You're good.
It's like a way to not respond to what you
Yeah.
said.
So what's your response then?
So you don't have the experimental resolution. So I am
I
going to
already
read
told
this.
you it's
Oh my
0.01.
god, dude! Fuck
I
this
just
guy,
explained it. I literally
Piezo.
just
He's just stuck on one
No,
thing,
hold
dude.
on a second, dude. Beasticles, chill
everyone just
out,
witnessed me
dude.
explain it to you. It's 0.01 according to your data table, and I said
Correct. Okay.
that makes sense because, as I said before, the experimental the accuracy was within plus or minus 1 kilometer per second, and they measured 6 to 10. So if 1 correlates to 0.01 and 6 to 10 would be between 0.06 and 0.010, then it makes perfect sense because what do we see when we look at this data table? We see 0.09, 0.08, 0.06, 0.07. We see these numbers all throughout that range. They average out when, like right here in this analysis, they average out to 8.5 kilometers per second, which would be
So and it also
0.085.
says due to their statistical consistency, one can compute the mean and variance and obtain 0.016 plus or minus 0.006, which would be about 0.01. This is value is consistent, and then it says
With an
this our
observable velocity of
hold on a second.
8.5
Our
kilometers per second.
reanalysis our
No, I'm not going to let you
reanalysis
skip over the
supports.
part that's important here, bro. You literally skipped over. This value is consistent with what? With a velocity of 8.5 kilometers per second, which was my point. You literally
Okay, and
didn't read that on purpose.
okay, no, because we don't have the air resolution in kilometers per second, do we? Do you have that?
Yes, it's
What is
1
it?
kilometer per second. I already told you that.
Where,
He
show me
told you
where it
that at
says
the
that.
beginning.
Hold on a second, Beasticle, shut up. Where does it say that in your?
Yikes.
Oh my gosh, I'd have to find it for you, brother.
Right. Okay. When you find it,
So
just
hold
tag
on.
me. That's all I'm asking. Nothing
Okay.
more.
So
Thank you.
can we continue? Because it's going to be pedantic if I have to do this every time. Can you, assuming that I'm correct, and I'm not just making it up and I'm just a liar, right? Can you answer it as if that was the case? Like, what would your
Yeah.
response be?
If it is 1 meters per second and they
1
came up with
kilometer per
8
second.
yeah, sorry, thank you. If it is that and that's what they came up with and there's no other explanation to it, then I would grant that. No problem.
Okay. So then when we bring this back to the original conversation that you rabbit trailed us all off of, where
Oh
we
my
were saying
gosh.
that, oh, you were like, oh, there's no measurement in ether. Where is it? I was like, didn't the Michelson-Morley experiment disprove it? No, this right
Yeah,
here,
that was my honest
because you were
question.
saying it was a null result, and I said it's only null in the
Okay.
definition that it failed to measure the prediction, but it's not null that it was a zero. So
Okay, I'm going to assume that you're correct in that and verify it. I literally asked what you said. I asked, didn't Michelson Morley disprove that there was motion between the ether and the globe? That was my understanding. You obviously have a different understanding. So we had a good faith discussion on it. So now I'm going to verify your
That's
claims.
not good
That's
faith,
it.
buddy.
Yeah, it is. I know you don't understand pure rigor. Stay in your lane.
Dude, you just fought for how long? And you say that's good faith. Come
Because
the fuck on.
Beasticles had no clue what he's talking about. Jesus Christ as Lord does. He's obviously smart about this.
Okay.
And
Throw me under the bus. That's fine.
yes, I am. Thank
To
you.
bail
Yeah,
yourself
because I
out on your
literally asked the
nonsense.
same exact fucking question. You piece of shit.
Yes, and I gave you my answer, and then you couldn't explain it further, so Jesus white knighted for you. So that's fine.
No,
You're
because
so
you kept asking him
bad faith,
questions.
dude. So
No,
bad
because
You
he
didn't
had no
engage with him,
explanation.
dude.
Jesus did.
I'm
You didn't
There's no way
disengaged.
engage
You're
with
just a
Beasticles
him.
could
troll, dude.
explain this. There's no way Beasticles could explain this. Jesus Christ as Lord did. Thank you very much. Appreciate it.
Oh, you are such a fucking liar. That's
So,
why I hate
anyways,
engaging
back to
with
the
that Tom.
gyroscope. Yeah. So a rotating ether field, right, that rotates at sidereal's time would produce the same exact effect as an Earth rotating, right, and which they also measured to have to rotate and measure sidereal time. So those would be equivalent. So a gyroscope would not be a mutually exclusive proof. That's where we were trying to get to. Just want to bring it back. That was the conversation with Cole. You guys can continue, but We need like you have to come up with a proof that's mutually exclusive, and gyroscopes are not.
Or mutually exclusive means excludes, negates, or denies a thing.
Oh, sorry, I was muted. There's no evidence for gyroscopes being affected by ether movements. There is evidence that gyroscopes move. There's all kinds of evidence that gyroscopes move and they detect movement. And it's just another piece of good evidence that falls in line with all the other pieces of evidence that all match perfectly together. And when you add it all up, it points way more towards the side of the globe than it ever does towards flat Earth.
The Sagnac effect is the proof that that there would be an effect, right? Because when the table rotates, the speed with which the table rotates produces a velocity proportional friend shift, and that friend shift is what's measured and converted to velocity. So you can tell how fast your table's spinning by how much of a friend shift that you get. Now, you could say, oh, well, that's because it's the table spinning and not, something else. But if motion is relative, then you could equally just say it's the other case from the other reference frame.
Yes, you could. That's what I say all the time about the Earth spinning. You could say the Earth is in the center and not spinning, and the entire universe just say the solar system everything is doing the exact same motions, everything, but you could put the Earth in the center and everything could be going around it. That the mathematics is exactly the same. There's no difference. But that's not. But when it comes to gyroscopes, though, there is no evidence that ether is causing them to turn.
So, if you look into the history of the science behind the Sagnac effect, right after George S. Sagnac discovered it around 1912, 1913, other people picked up the work. That's where the Michelson-Gale-Pearson experiment was done. They took a giant, like a super huge one, and measured down to like 99 point whatever percent accuracy the sidereal rotation. But then in between I think it was 1938 to 1942, a couple guys named Dufour and Prunier, it's like spelled like Prunier, but it's like, I think it's French or whatever, Dufour and Prunier, they took Sagnac's experiment and they said, okay, we want to test relativity with it, right? And so, because, relativity says there's no ether and if it's all relative motion, etc. So they took the Sagnac's table, the emitter and detector and the mirrors are on the table, right? And they took the detector and the emitter and took them off the table and screwed them into the wall, and then left the mirrors on the table. So that the only difference is like the light is still tracing a circular path around the table, but now the emitter and the detector are not part of that. The emitter and the detector are not part of any rotation, so they're not accelerating. So there's still the same exact change in path length from the table rotation, but from the perspective of the emitter and detector, they're not moving, right? And what they found is when they had the emitter and detector mounted to the wall, they got an identical friend shift compared to when they were mounted to the table and they spun the table, which proved was that both the table system and the lab stationary wall mounted system were measuring rotation with respect to the lab frame, and that it had nothing to do with the motion of the detector. And so that there's some like preferred absolute space that existed that they were making the measurement with respect to. And they even showed also in the paper the math that relativity would have predicted if relativity had been true, and showed that the relativistic prediction was off by a factor of 10. And so like if it takes you all the way back to George S. Sagnac's original explanation, he explained it with C plus or minus V relative to the stationary ether frame, that the table would be rotating with or against the ether, like around it. And so that was what would create the differential path length, because it wasn't path length, but it wasn't a change in path length between the emitter and detector, because they're both screwed into the table. They don't change separation distance. But with respect to an ether field, there's definitely a change in path length traced. So that's the only way that you can actually predict the Sagnac effect, because otherwise, if you just took away the ether and none of that mattered, then there wouldn't even be a friend shift from the perspective of the detector and emitter on the table, because they don't change their separation distance at all. There's no change in path length in the table frame.
Yeah, I'm not talking about light though. I'm talking about spinning mass gyros.
Oh, you're talking about a mechanical gyro, not a
Yeah,
fiber
that's
optic
what was
gyro?
on the That's what was on the Saturn V. They didn't have fiber optic gyros on the Saturn V that I was talking about a while ago.
Well, you brought
That's
up ring
big,
laser.
giant spinning mass discs. I even said that.
Yeah. So the way that the mechanical gyros would do the same thing, right? Is I'll try to connect it a little bit to the conversation we were having earlier. Remember earlier we were talking about rotation, right? And how atoms and particles, solitons, even were like basically like little
Yeah,
tiny.
that was you, man. You was talking about. So if you remember, I believe that there's an ether anyway. I'm not like against there being the idea of the ether, but I'm just saying that I don't think the ether is what's causing gyroscopes to spin like mass gyroscopes, not light detection gyroscopes.
No, I know. I was gonna let me give you the explanation, right? And let me propose it to you.
Go ahead.
So just as I said earlier that like solitons were little tiny, molecular gyroscopes, basically. If you think of just a mechanical gyro, right? If it is spinning, okay, and it is in a field, like we were talking about Bernoulli's principle, right? Think about Bernoulli's principle. The side with the higher velocity has a lower pressure, right? Okay. So and then compared to the other side, that will create a pressure gradient, which will create a net force. That's how the Bernoulli principle results in the Magnus effect and the Lorentz force. It creates lift, it creates movement, right? Or precession in terms of something that's orbiting. It'll cause it to precess, which is what a gyro does. It precesses.
Yeah.
So if we think about the gyro sitting there stationary and it's spinning, right? It's got its own rotation. If there's also a field that's rotating, you apply Bernoulli's principle. If we talk about a rotating ether, if it's rotating around the North Pole, okay, then the closer you get to the North Pole, the lower the tangential velocity would be. The further away from the North Pole you get, closer to the equator you get, and further out, the greater the tangential velocity would be, right? And so that means that if you place this gyroscope, regardless of how big it is, if you place it anywhere within that rotating ether field, there will be a net difference between the outer edge of it and the inner edge of it relative to the North Pole. So that one edge of it will have a I'll just call it 5x. We'll have a 5x velocity in the positive direction, and the inside, which is slower, will have like a negative 4x velocity in the negative direction. So that plus 5x and that minus 4x sum up to an overall plus 1x, and that plus 1x is a non-zero net force, and that actually will be imposed upon the gyroscope as a precession force. It'll apply torque. And what is cool about it, if you look at the mathematics of how it works, is it doesn't matter where you place it within this, because since it's a full circle, it's a full loop, right? The gyro's doing tracing a bunch of circles. Then when it's placed within this rotating field, the amount that it precesses by will always end up being, or the rate that it precesses at will always end up being the same rate that the field is rotating at, as long as the gyro is spinning fast enough to couple to it. Because you have to get a mass gyro spinning really, really fast for it to be able to pick it up well enough.
Yeah.
But if you get it spinning fast enough, it'll achieve coupling, and so that's how it would work. Is that pressure differential based on Bernoulli's principle at the differential tangential velocity, and it naturally will just precess at the same rate that the field rotates.
Yeah, I guess we just believe different things. Because I just can't go that far.
I don't think you understand how the Bernoulli principle works, by the sound of it. Why does the pressure? Why do you think the pressure drops when the velocity increases of the fluid flow?
Well, I do got to say I did like what he said a while ago, though, about when we was talking about particles and waves. I did like what you said then, so I don't want you
What's
to.
the reason?
Not a hater.
What's the reason? What's the reason why the pressure drops? This only applies, by the way, at subsonic speeds, but why does the pressure drop when the velocity increases?
Yeah, subsonic speeds, right? The speed of sound in the ether would be c. That's because the total energy like has to be the same, right? You got a certain amount of energy in it, right? So it doesn't like energy has to be conserved. So like whatever our energy in our system is, that's how much we're rotating with. So when you have a higher velocity that would be considered in terms of energy an increase in energy because energy is proportional to velocity. So when you have an increase in energy, that would in kinetic energy that results in a decrease in pressure energy because those are two different sources of energy. You got kinetic energy, you got pressure energy. Those two together would sum up to the total energy. So if kinetic energy increases, then pressure energy has to decrease in order to achieve energy conservation.
The pressure energy is actually the same in the whole system. It's just a change in the average vector of the individual molecules of the fluid.
What?
So to say that that's the reason why the static pressure goes up, but the dynamic pressure goes up, right? And the total energy of the system doesn't change. Because all that you're doing is you're changing the average velocity of the molecules that are moving around within the fluid or the gas. The gas or the liquid.
Bernoulli's principle is that when like the side with more velocity will have lower pressure, as the velocity increases, the pressure will decrease.
Yeah, only within a streamline, which means only within a fixed set number of molecules. And it's actually not. It's not that the pressure is going down. The static pressure is going down. The dynamic pressure in the direction of the flow is going up. But that's just because the average velocity of the molecules is picking a favored direction instead of a random direction when it's static. That's all that happens under Bernoulli.
Yeah. So, like, how does anything you just said negate the fact that when you have two interacting rotations in a fluid field, that it will cause a precession or a net force?
Well, that's still different than Bernoulli, though, right? The reason why the precession happens is because the inertia is conserved, right?
Energy conservation is, yeah. But I once again, I don't like my premise was
when you say that the speed of sound is c, I don't know what you mean by that.
the speed of sound in any fluid, because sound, you think of sound as like air, right? But technically, the speed of sound is like a general term. It's the characteristic wave speed in a fluid.
Yeah, it's the maximum speed, right? That it would propagate through. That signal would propagate through the wave.
Yeah, well, it's not the max speed. It is the characteristic speed. Like it's all waves will travel at that speed in that fluid.
In that particular fluid.
You can't. Once you hit the speed of sound, the speed of sound in that fluid, or even in a solid object, you cannot increase you cannot increase the transmission of that wave through that material any further, right? That goes back to you remember Darwinism once said that if he had a stick long enough to go to the sun, he'd be able to push on the stick and then it would instantly pop over on the sun, creating faster than light communication.
It's a good thought experiment, though. That's been done before.
But that's because that's not accurate, because you're still limited to the speed of propagation, which is limited to the speed of sound in that, whether it's a fluid or even a solid, right? The speed of sound through that material is going to be your limit of propagation. You'll never be able to propagate through that material any faster than that. The individual interactions of one molecule bumping into the next molecule, one atom bumping into the next atom.
Yeah, that's it was way back in the day when that thought experiment was first come up with, and some people thought that it showed that it meant that information can be transferred faster than the speed of light, because information is supposed to only travel at the speed of light. But what would prevent it from being faster than the speed of light is the propagation of the molecule. So when you push on this end of the wood, you push on the very first atoms, and they push on the next ones, and they push on the next ones. And if you had the strength to push that whole piece of wood, it would only move at the speed of light because that's as fast as those atoms could propagate. And when
Yeah,
it got to the other end,
because
so it
matter's
would
made
be
of
instantaneous.
matter's made of ether. Like right, the reason that you can push objects through other fluids faster than the fluid speed is because they're not made of that fluid. But
Matter's made
since
of energy.
Speed of sound, not speed of light.
yeah, the speed of light is just the sound speed in ether. But yeah, what'd you say, Cole? Say it one more time, Cole.
Matter's made of energy, not ether.
Oh yes. Well, yeah, but what is energy? Energy is
Well,
technically
that's
just
right. Well,
motion.
yeah, we talked about that a while ago. That would be part of that field with the standing waves in it, wouldn't it? Wouldn't that just be like
Yeah. Because all energy, every type of energy you can ever think of, is all energy, except potential energy, which is just stored energy. Technically, it would still follow the same rule. But every form of energy is measured in some way by some form of motion. Right. So you have thermal energy that's caused by the random thermal vibrations. You have kinetic energy, which is the brute motion of something. You have the electrical energy, which can be measured in terms of like the oscillations of the electric field lines. Like every type of energy is some kind of motion, right? Because that's what energy is it's motion, and that motion gets conserved, right? So when we talk about conservation of energy, that's because if everything is in one big giant continuous swimming pool of fluid and everywhere in the universe, if I move through that swimming pool, that fluid's going to move, and it's going to keep moving like across and transmit that influence with it as it goes. I can't just move something and then have it not have an effect. Right? That's really what the law of
Energy is
conservation
not
of energy
energy
means.
is not motion. Energy is the ability to do work, or more
That is
roughly,
just an abstract definition. That's not
the
a
ability to move something from one place to another. That's what
yeah.
energy is.
That's an abstract definition, not an ontological definition. Energy is an actual material thing. It's not like defined. It's not actually ontologically like a capacity for something. Energy is a material thing.
So, like when you store energy in a battery, what do you think is happening within the battery? How is that energy being stored within the battery?
There is a electrical potential being stored in that battery between the two posts.
But how is that potential being stored in there? What's giving you that potential, and then what gives you the ability to extract it later?
I just said the electric potential.
Is it in the form of motion?
Yeah, on the microscopic, well, that would be potential energy. A battery would be potential energy. I already said earlier that potential energy would be the only one that isn't strictly motion, but that it got imposed by motion. Because like if you have a molecular lattice, for example, right? Like let me take a dielectric inside of a capacitor where you polarize the dielectric and it stores potential energy, which functions very similar to a battery. I'm able to actually reorient the electric dipoles in the material to separate them apart from one another a further distance, which creates a greater elastic desire to rebound, right? That's stored potential energy. It took motion, it required motion to stretch it out. So even though it's not presently moving, it desires to move because it took motion to get it there. So even potential energy it still requires motion, like to be created, to be transferred, I should say, to be transformed into potential energy, just like gravitational potential energy. Something that's a higher altitude has more potential energy. Well, how did it get there? You had to move it there, right? So motion had to be applied.
Yeah, I don't disagree there that the electrons had to be moved from one
Well, we
location
talked
to
about
another.
we talked about earlier, and I posted a really good Veritasium video, and I think they sort of talk about the same thing. It's like there's seems to be the way they are figuring, or some of the scientists have come up with, that there is some type of background medium
either it's like at the smallest levels of existence or whatever, but there's some kind of like medium. And what we look at as when we say an electron or a photon is a particle, or say electron is a particle and a wave, it acts like a particle and a wave. What they're saying is it's like a lump on this medium, and it's made of the medium, so it acts like a wave because it's just like a wave in a pond. Is the wave is actually part of the water in the pond. Well, that's why it acts like a wave when it interacts things, and it can split and go different directions and do different things, or it bends around things like a wave would do. But at the same time, we're looking at it like, since it's like just a standing wave, we're also looking at it like it's a particle, because it acts like a particle at the same time, because it's like a standing wave that can bounce off things and
It
be
can move.
manipulated and curved and different things. But at the same time, it can roll around things and stuff just like a wave would do. It has, and that Veritasium video explains it really well. And they think that, that's maybe what at the smallest levels particles are.
Well,
Or that's
hey,
what some
Jesus,
scientists think now. Go ahead.
Jesus Christ is Lord. Would you consider fields to be what you would call the ether, or is it completely something completely different?
That's what I think. I think I don't know who you're asking,
Yeah,
but
I'm
me
just
personally,
curious if he
me
would.
personally, I would call the ether like some kind of radiating background field, or maybe not radiating, but just background field.
I refer to the ether as the primary substrate. It's the substrate for our material reality. It's what is
Could
underlying
that be
everything.
fields? Could that be electromagnetic and other types of fields, or no?
Well, the ether is what provides the backbone for electromagnetic fields to manifest. The electric and magnetic fields are simply the effects of stresses and strains upon the ether.
Well, so you know the difference between the fields and the actual, like, where there is a electron or something, like that's a disturbance of the field. Is that what you're talking about, or something even more fundamental than that?
Well, very, very close to that. So, like, if you actually look into, like, the historical development of physics and electrodynamics, the ontological status of a field is abstract. Right?
Yep.
Fields are not supposed to, or are not defined as physically real, and what they are is they're just math objects. Like, just like I can create a vector field, just like I can create a vector, like or a matrix, or anything, any kind of math object I want in math, right? That's all a field is. It's defined as a region in space where forces can be measured. Okay,
Right.
that's not an ontology. That's a description of like what it is measured doing, right? But it's not what it is. It doesn't tell me what it is.
Right. I mean, is ether? Does ether cause those fields, or do they cause the vibration in those fields, or you don't even agree that the fields are there?
Oh, no. I agree that the fields are there, but I think the fields are not actually of themselves their own independent entity. I think that they're just like, let me put it like this. If you look at Maxwell's equations, he defines electric field and magnetic field both in terms of something called the A field, also known as
Right.
the vector A potential.
Yep.
And for like almost 100 years, that was thought to be like just a mathematical placeholder, just like the other fields are.
Right.
But the Aharonov-Bohm effect proved that the A field was actually physically real.
What's that called?
Aharonov-Bohm effect.
Oh, boom. Okay.
Sorry,
Go ahead.
Yeah, basically, if you look at the equation for E, the definition of an E field, assuming that there's not a static potential there, right? Assuming like there's no static field, then the definition of E is the DDA of A, or sorry, the DDT of A. Sorry, DDT of A, and the definition of the B field is the curl of A. So a magnetic field is literally defined as the vorticity or the rotation of the A field, and an electric field is defined as the flow of the A field.
So is the A and B fields, is that what you're calling the ether, or where does
A
the
is
ether fit in?
Yeah, A is the ether.
Okay.
Yeah. So the ether exists everywhere, but within the bulk body of the ether, localized areas can have flows, can have rotations, can have static pressure, all these different things, just like any other fluid can. The same mathematical expressions that I'm using right now to describe E and B and all these things are just general accepted fluid dynamics expressions. because Maxwell actually used fluid dynamics to create electrodynamics.
So simply put, how would you define the ether?
I think it is some type of unique, perhaps exotic, fluid or superfluid or elastic solid. We don't really know like what it's made of because we can only compare it to things we know. We can compare it to liquids or gases or solids. It might not. It's probably its own thing. It's probably its own state. Just like we have solid, liquid, gas, and plasma. Ether's probably its own state. It's probably like the fifth state, I would say. But it is some type of just using the generalized definition of a fluid, which is not a liquid, right? Gases are fluids, liquids are fluids. They're all fluids. Using that definition, it's like some type of like fluid/elastic solid that permeates the universe, and the motion of which gives rise to all the fundamental forces of nature as well as matter.
So it gives rise to the fields, or no?
Yep.
Okay.
Because the fields aren't, once again, the fields aren't physical objects. They're
No, I agree.
Yeah.
Okay, cool. I'm looking up this Harper or the Broomfield experiment. Is this the high altitude?
No. Aharonov, Aharanov, Aharonov, Bohm,
Okay.
BOHM.
Oh, there it is. Got it. Thank you.
Yeah, the TLDR on that is basically you take a piece of wire and you split it into two into a circle or in whatever shape. You could just put it into a loop though. You can do it in different configurations, but you make a loop of wire so that there's a clockwise path and a counterclockwise path to get to the other side. So it splits clockwise and counterclockwise and recombines on the other side, and then you measure the phase difference with a detector. Okay, so you send.
Yes. Okay.
And then in the center of this loop, you put a solenoid, an electromagnet. And based on the geometry of a solenoid, the electric and magnetic fields are entirely confined to the interior and the outer edge of the body of the solenoid. So magnetic and electric fields do not bleed out away from the solenoid; they're confined to it. So why this is important is because when you turn this current on in the wire, you can measure the phase difference between the clockwise and counterclockwise paths, and you'll have a what you'd call a base level or a resting phase difference. Then when you turn the solenoid on, all of a sudden you see that phase changes. There's a phase shift that occurs. One half of the loop, like the clockwise direction or the counterclockwise direction, will get sped up a little bit, and the other side will get slowed down a little bit, and the peaks will shift their position. Now, this is incredible because we know, like we can both verify it through math, through the geometry of a solenoid, and through measurement, that there is no electric or magnetic field present externally affecting the wire when we turn on the solenoid. There's the same exact electric and magnetic field around the wire with the solenoid off and with the solenoid on. So both E and B are 0. And since E and B are 0, you should predict no phase shift. However, a phase shift does occur. The only way you can correctly predict and model the phase shift is by accounting for everything in terms of A. Because what we know is that the solenoid, when it's turned on, creates a magnetic field, right? B equals curl of A. So even though there's no magnetic field extending outside the solenoid, there is a curl imposed upon the A field. It creates a vortex in the center of the solenoid, and that A field will curl around it, and that rotation will spread out and reach the current loop. And that A field, when it hits the current loop, since it's rotating, the part that's as the rotation reaches the wire, the part that is parallel with the wire will, of course, push the electrons along because that's a DDT in A, which is defined as an electric field. It actually modifies the electric field inside the wire directly through A. On one side, it adds, and the other side, it subtracts. And so it perfectly models and explains the Aharonov-Bohm effect. It's one of the most fascinating quantum electrodynamics experiments that's ever been done. They discovered it in the 1950s. It has a ton of implications for technology as well, but it's a separate conversation.
Yeah, Cole, was that the Veritasium thing that used this Aharonov? Because I remember watching that a couple of weeks ago.
Yeah, I just saw it the other days
Yeah.
ago. I don't know how old the video is. I don't think it's very old though.
No, yeah. All right, I'm gonna have to go back and watch it because it is basically they were doing this. I can't remember why they were talking about quantum linking or tunneling, but no, that's cool. Thanks for explaining that. Appreciate it.
Yeah, no worries. It's look, dude, like there a few years ago, I didn't even know what the ether was, and I'm like, what is this ether people keep talking about? And bro, like, I literally had like, I know it's gonna sound weird. I started looking into it, and I had like an epiphany at one point where something just clicked in my head, and it literally all just made sense. And I realized, like, wait a second, click, the entire universe is mechanical. And I can just use mechanical interaction, classical physics, and the principle of local action to understand everything. And now everything in physics is just completely intuitive because it just all obeys that principle. And it's beautiful, honestly. Imagine being able to use your intuition to understand things like the first time you hear about them without like as they're being explained to you, they just fall in place and perfectly make sense because you actually are using physical mechanisms to understand them instead of like abstractions of time and space.
So you don't believe in dark matter, dark energy?
Heck no. It's not even applicable. People use that as a pop science term so much and like out of its proper domain anyway.
I'm just pulling your leg. I
No, I
believe
know, I
everything
know.
is mechanical myself. Yeah, for sure.
It's just the principle of local action, bro. Like spooky action at a distance is like not a thing. But if there's an ether everywhere, then you can transmit any influence at a distance that you want if you do it through the right media.
Well, you realize though that when you explain ether that way, it's dangerously close to what they talk about, right? The pseudoscientists, they believe everything is in a field, right? Like atoms are not actual particles, they're fields, and then when they interact with the God particle, it gives them mass and this and that. So it's eerily similar to what the pseudoscientists believe, right?
Well, quant QFT and QED and all the experimentalism that they're doing, they're measuring a bunch of real stuff really precisely and have modeled out the mathematical relationships that makes everything tick. It's actually really awesome. But then what they did is they just applied abstractions as the ontology. Like they don't actually have ontologies for any of it. There is no ontology. They just make up like our abstract description of what it does is what it is. They're basically saying it is what it does. And that doesn't make sense. Like if I ask you, what is a horse? And you say a horse runs fast and drinks water. That doesn't tell me what a horse is. But that's what they're doing.
Agreed. Yeah. Agreed. Just the space-time thing, right, is like, wow,
Oh, that part. Yeah,
space
that's fake and gay. Yeah. Well, you don't need it. Like when you realize like fluid dynamics explains it all, you don't even need it. And that's the thing. Like the one concession I'll make for Einstein, right? Like in all of this stuff that he did, the one concession I'll make to the space time stuff is when we talk about fluid dynamics and we look at like aerodynamics, right? Like Prandtl-Glauert applied to like air and stuff, and acoustics. When you're moving really fast through air and that pressure gradient is being applied to your object, if you were to like imagine yourself as the object, right? From the object's perspective, looking at the airfield around you as you're moving through it, it does appear to that object as if the airfield is warping, so to speak. Like from the perspective of the object, because of the compression of the fluid, the compression of the air, right? Because it's actually like literally a velocity dependent compression occurring, then not space itself, not a 3D fixed coordinate system is not changing, because that would be space. Space is not changing, but just the fluid itself, like the field of fluid itself, is changing. And so if you use the field of fluid as the metric, then it would be kind of like the space is changing. But we know that like actual space, like there's a fixed coordinate grid for space, and then it's filled with, ether. So a airplane wing, even though from the perspective of the airplane wing, the field of air is changing, we know that there's space, there's empty space that the air occupies. So even though if you were to relate it to an air-based coordinate system, you could actually do a Lorentz transformation effectively and say that there was a length contraction in the air field. It wouldn't be a length contraction of space, right? So it's really just a mathematical trick that's happening. Because in actual real 3D space, there's no length contraction. But there is changes in the fluid.
Well, you can relate to that, if I understand you correctly, like a boat in the water. As it moves forward, it pushes the water. Is that what you're saying? Like,
Yeah.
So it's
And
that's
like if it
all it
moves
is.
fast enough, like water is not a great example because water is like extremely difficult to compress, right? But like technically, like it still does a little bit on a
Yeah, it's
micro scale.
compressed at the bottom of the ocean. Like if you go to the
Yeah.
bottom of the Mariana, water is actually compressed together somewhat
Right.
because of the sheer weight.
Right. It does. It's just very little, but it's still I mean, it works. It just air's a bit better, easier to visualize. But yeah, you can use water, Jeremy. If you assume that the water compresses a meaningful amount, then like as the boat moves faster and faster, it pushes really hard on the water, and the water in front of it like squeezes or whatever, it compresses, which shortens the length of like the total body of water by that amount. So that would be like length contraction, but it's not the 3D space. Like the 3D space of like the Earth didn't change. It's just the body of water changed.
Did you call him Jeremy?
Oh no! Sorry, Montreal. My bad.
No, Cole. You called Cole Jeremy.
Oh,
No, he was talking to you, wasn't he?
I was talking to you. Yeah, I just called you Jeremy on
Okay.
accident.
So
That was my bad.
please don't insult me. Don't insult me like that. Calling me
Honest
Jeremy.
mistake. You guys
An
sound
American.
exactly alike.
Oh no! Don't call me that. Don't insult me. Hey guys, I'm not Montreal. Montreal's not me. I can't really do your guys' voices that good. It's kind of difficult.
Jeremy sounds like his nose is blocked. No, when he talks. You got that New York.
I probably was a little too dramatic with my impersonation of each of you, but trying to make it
For
differentiable.
Cole. Try Cole again.
Say something, Cole. Talk a little bit.
You've heard me talk all night. You know I talk.
Yeah, I don't know. You heard me talk all night. I think we should talk some more about that ether stuff. I was watching a Veritasium video the other day, and
You've got it.
That's pretty good. Well, I'm used to people making fun of my voice, so that's no big deal.
I just wish, right, like these conversations, it's possible for them to be highly productive, but like I just wish it was easier for people to like flip the switch and turn like the ego off just to be able, because you kind of have to in order to have it. It doesn't even matter if you're like 110% correct. Like you still have to like turn off ego in order to be able to have a productive conversation in which both people are able to contribute. And like too many people, it happens on both sides, don't get me wrong, but too many people are like unwilling to allow that because there's like an intrinsic like identity connection to some of the beliefs and the frameworks. And so it becomes like an attack on my identity when someone attacks my paradigm. Like that's how people operate a lot. And it's like really bad for conversations.
Exactly, bro. It's like you're attached to this model or that model, this team or that team. best thing to do is be neutral, and it's kind of hard to do that. But yeah, that is a big problem, and we're on combat mode most of the time.
Yeah, I've noticed that, especially when homeboy said his PhD was better than the other guy's PhD.
Yeah, stuff like that. Yeah.
What kind of pissing contest are you in?
I left before I heard that part, but I heard the beginning of all that. Did he say that?
That
My PhD is better
university
than
ain't good
his.
enough, and it's not accredited, and whatever. Yeah, that kind of stuff.
And didn't Geo figure out that like they don't do ABET stuff for PhD? That's not a thing.
Yeah. Geo said that part of it, one thing is not accredited, but the rest is something like that.
Yeah, but we got to the bottom of it. Basically, the engineering department at that college is ABET certified or ABET accredited, but the computer science program isn't of the bachelors. So of the bachelors, which I don't even know, did Mike even do his bachelor's there or only his PhD? But the issue that he had with
Probably
it was
the
that
PhD.
it was that the bachelors didn't have ABET certification for the computer science. So I guess even though Mike did a PhD in the computer science there, I don't know where Mike got his bachelor's, if it was at a different school, whatever it is. But anyways, that was his issue. It's just that the bachelor's computer science part of that school was not ABET accredited.
Yeah, when I was first going back to uni in my first engineering program, the school I was going to, the engineering program was like brand new, and they hadn't gotten their ABET yet. Like they have it now, but they were going through the process. And I ended up changing schools to a different school that did have it. But yeah, like you got to be careful if you're getting in like a STEM degree to make sure that they have that. Like most schools have it now, but it's like if a school doesn't have it, you probably don't want to get a STEM degree there because like if their program's been around for a few years and they still don't have it, like it's kind of a sign that like the program's probably not that good or whatever.
Also, if they lose it, they may have it for many years and then something might happen and they may lose it because they get in trouble for something. But that don't necessarily mean that when somebody went there in the past, it wasn't
That's
a good
true.
school. It just
Yeah,
means
that's
that
true.
they had a bad somebody come along who run the school for the last 10 years, ran it badly, caused them to lose their accreditation. Because that happened in West Virginia, not to WVU, but to a smaller college up there. They lost their accreditation in like 2010. They were a really good school for several years, but then they had a bad director come along and caused a bunch of problems, and they got their accreditation pulled.
Let me ask this question, with all due respect. Does the school really matter if they're teaching stuff like that's not known, like dark matter, dark energy, time dilation? Does that really matter? Like they're teaching something that cannot be proven. So
Well,
no
that's
matter
not.
how high your accreditation is, does that? I mean, you understand what I'm saying? Like, why does it even matter?
Well, what ABET is for, what ABET does is it ensures that you're meeting like a minimum set of requirements in what the kids are learning. So like when you take your exams, it certifies that you had to learn this, and this, right? Like this is our minimum requirement for a bachelor's of electrical engineering or whatever, right? Every bachelor of electrical engineering should be able to know this under our ABET standard. So then all the schools are like, all right, we'll make sure that we incorporate all that in our curriculum, and now we make the standard, and then they get ABET accredited. So like,
No,
you can have.
I get that with like real engineering, real physics. Like, of course, an electrician but I'm talking about like the pseudosciences, what we call the pseudosciences, right? Does that
Well,
really matter? Because
I
they're
don't.
teaching something that nobody really knows.
I don't know if they have accreditations for astronomy programs, to be honest with you.
Okay, gotcha.
I just did a quick search for astrophysics, at least, and it says they're generally accredited under engineering physics, other than or similar titles other than astrophysics. So, I guess it's saying engineering physics programs.
Yeah, just the regular engineering department is ABET accredited, but it's not specific to the astro part.
Yeah, that's what it looks like, just from a quick search.
Yeah, that makes sense. I would agree with that. That's probably because, like, the astro part, dude. I never had to take a single. Like, I take that back. When I was fresh out of high school, and before I like went back to school, like I went to school for a year, and then like tried it because I had like some free money and stuff. I didn't like it, but because of my program at that point, it was something I didn't like. But I did take a like an intro level physics course way back in the day that did incorporate astronomy stuff in it. But it still wasn't an astronomy course. It was just physics. They just used astronomy stuff in it. But other than that, I've never had to take a single class, like not even one, that was astronomy or anything to do with it.
So let me understand what Gio said. Gio, did you say that an astrophysicist it gets like an accreditation like an actual physicist, or it's something different?
Are you asking about just accreditation in general? Because I think there's more than just this ABET. They're just referring to this ABET, this particular accreditation. So I was just saying that it looks like this is saying that astrophysics programs are generally not ABET accredited. But I guess the departments, which would be like their engineering and science departments, for example, like engineering, technology, applied science, computing programs, those would be ABET. And then those have astrophysics tracks, is what it sounds like. So those would have like like a track in astrophysics in that department, and the department is ABET. So technically, the astrophysics is an ABET, but the engineering part of it is, and then they have like an astrophysics track within that.
Gotcha. Okay. Yeah. Because an astrophysicist to me is like a contradiction in terms, right? The physics of a star. You're an expert in physics of a star. Okay.
Yeah, well, dude, it's funny too, bro. Like, there's usually I should be careful how I say this because I don't want to be like dogging on anybody, but there's usually very specific personality types that end up in like the astro departments, and some of those people are nice. Like, I've talked to a few of them. Like I know a professor who I'd like dropped into his office one time and talked to. Pretty nice guy, but like there's not very many people who are interested in those programs. Is kind of what I'm getting at. They're very very niche. Way more people go into like the hard sciences and engineering than do anything astro. So you already have like a very small pool of people to choose from anyway that go into that, and even a smaller pool of people that get like the higher accolades. So like all the astronomy people are like a fraction of any of the other sciences pretty much. So you have basically a tiny group being able to basically, say what goes. Like, oh yeah, we're gonna, we're the leaders in our field, but there's not that many of us. We're gonna invent dark matter and we're gonna invent dark energy, and that's gonna be stuff that they teach now. Like you make a discovery and you can start putting it in textbooks like the next year, effectively.
Are you currently studying right now, Piezo? Are you currently in school?
Oh yeah, dude. I'll probably be in school for a long time because I'm gonna. I'll be studying for a long time. Put it
What
that way.
level of
I also
masonry?
work. I also work though, so I work in the field that I study in. So that's all I'll say. But
It's all good. You said
Good
that was
stuff.
a good
Good stuff,
position.
bro. Yeah, that's the way to do it.
right, because like once I finish studying, I get I can get more money because I studied more.
So something to do with electrical engineering, I imagine, right?
Yeah, something like that.
Interesting. Good. Good. Like I said, good stuff. You sound like you know what your stuff. Like it flows. It's like you're not struggling. So yeah, good on you, bro.
Thanks, bro. No, nothing to me, dude. I'm just a soul in a body. Have the brain that I got dice rolled by God, and it's not. I didn't do anything for it, you know.
Right, the opposite, maybe. We all do, knowingly or unknowingly.
By the way, I see I still have this page open. So it sounds like for astrophysics, they only go by like institutional accreditation. So, you know, if the school itself has various accreditations, then that just kind of funnels into the astrophysics. So I guess this is saying that there really are no actual like specific astrophysics. Well, this is for PhD. I would assume it's the same for masters and undergrad. But so like they just go off like, so if the whole college is accredited by, you know, XYZ accreditation, then the astrophysics just sort of incorporates that. So it is interesting because you're talking about like it's so theoretical, you know, like what could you really have as a, you know, it's one thing in like engineering where you have some very practical things that you're, you know, would want to have standards for. But yeah, with astrophysics, it's like kind of out on a limb and it just sort of gets wrapped into whatever the school has itself, you know?
Yeah, yeah. It's not an actual thing that you can test and hands on, and yeah, that makes a lot of sense. Like when you hear these guys, like these professors and these Michikaku guys, right? This is all theoretical stuff, right? Like all of it. It's all theory. Like not even theory. It's assumptions and I guess observations at best.
Scientific theory is something that's been well proven by rigorous experiments. So it must not be a scientific theory. It must just be like, if you're saying that, it must just be their best guesses.
Exactly. Exactly. It's definitely not a theory, right? So theoretical astrophysics is a contradiction in terms, right? Unless you use the word very loosely. Just the term astrophysics, right? The physics of a star, that's way out on the limb there.
Black and white SE.
I thought you were going
I
to
get
say
you.
the way you're about to, you know how that one Seinfeld where he's like, that's kooky talk. I thought that's what you were about to say. You're like, the way your tonation, that's kooky talk. That's funny.
It really is. Yeah, it really is.
Physics of a star. A twinkling light in the sky that you can't access. What is the most they got? Just spectroscopy? It's about all they can do, and the rest of it's theoretical?
That's basically it. Yeah, the best they can do is spectroscopy. And observation of movement. That's about all they got.
Yeah, and how bright it is, and yeah.
Yeah, yeah.
The conversation tonight was fun, though. I will appreciate, you know, those who participated in good faith. I'm gonna hop off of here for tonight, but it's a good talking with you guys.
Same, bro. Good night.
Take it easy, bro.
Yeah, y'all have a good one.
Yeah,
Never a
sounds like
dull
that.
day.
Asking. Go ahead. Shoot. Dog.
All that timing.
What's up, 24 O's? You tried to get in a few times. You want to say something?
Yeah. Yeah. Well, it just sounds like astrophysics is a long-term education.
Of what? What are
No,
you studying?
well, that's what I'm saying. You're getting the masters, and it gets tighter and tighter field, and it's just a bunch of close knit. And then you get into the Mason. I'm sure I wasn't trying to call anyone out, but it's like being a doctor, but if he's saying it's a real small number of people, it's kind of weird how it's still going. Yeah.
Yeah, well, if you're a doctor, you got something to work with, right? Talk about blood pressure. You can actually take a cup, put it on your arm, and measure it, right? But
Yeah, well,
what does
all
day
these
one in
things.
astrophysics look like?
Well, I guess it would be. I was gonna mention like the whole oh, this star is dimming on this pattern, so we figured out the volume of the planet. You know, but I think that's the thing. You get into it and it gets pretty meta, or whatever, and then it's like,
Yeah.
and only a couple people go on because you have all this opportunity, right? It's like, oh, well, here's this grant, here's this money, and then astronaut. So maybe not that.
Okay, class, day one astrophysics. Look at that light in the sky. Well, today it looks bright. Yesterday it looked a little less brighter. Tomorrow, it might be a little bit more brighter than yesterday. Okay, what does that tell you?
I think it's a little deeper than that.
Well, you'd obviously be
imagine.
full
I get you. I
physics.
know what you're saying, though. I get your point. I know exactly what you're saying.
Like at best, it's guesswork, right? Even with spectroscopy, right? Okay, the readings we're getting of this is hydrogen and whatever, right? Okay, then what? So we got the brightness, we got what it appears to be made out of. Purely, well, I won't say pure speculation, but you know what I'm saying. Then what?
They're working in a field where they could never possibly go and physically test it.
Yeah, my point exactly. Yeah. Even the sun, right? The closest quote unquote star, right? Even that, best they can do is do spectroscopy and see what what spectroscopy says, right? Helium, whatever. Then what?
Well, then you
Even
build
the
a
closest thing to us, yeah.
then you build a probe called the Parker Solar Probe, and you send it and measure the corona.
Okay, let's say assuming they did that, right? No, but let's say assuming they did that, right? So what? Do you know that they say the surface of the sun is 5,000 degrees, but the
Yeah, I
atmosphere?
get what you're saying. I know what you're saying. I'm not arguing with you. I understand exactly what you're getting at. Because
Yeah.
even if they could measure the outside of the sun, still, you're saying that they can't watch a sun form. They can't take samples of its interior. You know what I mean? All the things that they say, how stars are formed, how they begin, how heavier elements are made in dying stars that explode. All them things are just what there is assumptions. They may have, to me, you know what I'm like. I would like to believe that it's real, but I understand exactly where you're coming from.
Yeah.
Stuff and no accountability of where it came from or how it came to be.
Right, and they can't even explain a simple thing like the surface of the sun is 5,000 degrees C, but the atmos, like right after that, is like 1,000,000 degrees. They still haven't figured that one out. You guys are aware of that, right? The difference in the temperature.
Yeah.
It's being too hot to fit the framework.
Yeah, it's like the surface of the log is 100 degrees, but just around the log, it's 10,000 degrees, let's say, as an example, right? What? How does that work out? So even like the simplest thing on the closest quote unquote star, we still have no clue. Like, how could the surface of the log be 200 degrees and right around it be 10,000 degrees? How does that make any sense? So
Right,
yeah,
there's that weird stuff they come up with, but I mean, if you're talking a magnetic interface, right? The surface of a
well, as
I don't
far as
know,
I
like,
know, they haven't figured that one out yet, unless
well, yeah, and
some.
then getting numbers is kind of is ridiculous, but that's, I guess, astrophysics is just making sense of different models and right, and expanding them, and then
Well, don't forget that's their job, right? So they sit around all day long coming up with theories, ideas, doing mathematical calculations, and I mean they got to come up with something, right? They're getting paid for that, so they come up with different theories, different ideas.
Getting paid to theorize about the sky.
Yeah, what a
You
job.
gotta respect it though, right? I mean, people are out there spending their hard-earned hours theorizing about the sky proving a ball.
Yeah, what a job, man. What a job. What do you do? Well, I
Those
come up
groups
with ideas
vessels.
in my head all day long.
It's worse than that, brother. I sit on a Discord with people that I don't agree with and get mad at them because they don't agree with me.
The funny part too, is we get ridiculed for measuring flat, like doing physical measurements that are flat, not using the sky to determine what the ground is, and we're the ones getting ridiculed. It's a strange phenomenon now.
Yeah, that is true, bro. Yeah, the actual people that do the actual measuring get ridiculed. That is hilarious.
That's gotta be some type of like satanic inversion, man. Or like demonic inversion. It's a weird thing.
Nah, bro, it's dogma. It's belief in a pseudo model, right? That it's it's a belief system, and people fight for it like their favorite baseball team.
If it was as
Yeah,
simple as like
their team.
belief in the globe, which I think like most of us have family and friends who believe in the globe, that's one thing. But as he's right, it is belief in a pseudo model. So it's like belief in anti-flat Earth. Like that's a very different thing than just someone who believes it's a ball, right? Like it's a weird. I don't want to say cult-like, but it's like this groupthink oriented, not flat Earth. That's like their whole thing. Because if there was no like flat Earth group or people who didn't believe in the ball, there wouldn't be this anti-flat Earth group. It's crazy when you think about it.
I had never seen evil until I experienced it with a like a money issue with family, like that sort of thing, and it brought out the evil in people. I know that it exists, and that's what it seems like to me. It's just they don't mean to. I don't think they're doing it on purpose. I've seen it take a hold of people in their minds, and they're just someone that's drunk, they don't realize they can't drive, or on drugs, they don't realize what they're doing to the people around them. it's kind of like that in a way. Something just takes a hold of me, and I don't want to say it's something doesn't take a hold of me either. Like I like being right, that's human nature. But the way they do it, I mean, I'm more than happy to say a lot of the things I think of are theoretical, and I can't prove. I openly say that, and I never hear that from the other side, even though it's mainstream theoretical science. They still won't agree with that. That's strange.
I like the way you're putting it, so it's like a influence kind of thing, the way you're explaining it. Like people who are drunk, they're under the influence, people who are, seeking money, they're being
Yeah.
tempted money.
Drunk
I
on
agree.
the globe, right? Or what I'm saying, they just have that bias built in where they can't see it any other way. They don't even agree. That's why they say the sun won't set on a plane until you really nail them down. That guy John the other night was, on a plane you would see infinite far because we see forever. And then when I broke it down, he agreed that we wouldn't see forever on a plane. Like it's just weird, strange.
Yeah, I mean, yeah.
Okay.
Sorry, talking like that is the hardest skill. Like being able to present facts, and like when people want to stop the debate at like square one, like you're about to tell me what, like, or whatever. So, but yeah, you nailed it with that analogy, I guess.
That's an awesome analogy. I mean, I don't think we're even at the point where the equivalence between geocentric and heliocentric modeling is acknowledged. It's like pulling teeth to even get that acknowledged. It's crazy to me.
Well, when there's a standard belief and it's like a mob mentality, right? When the majority of the people believe in a thing, right? If you come out and you go against it, it's like you're a kook. They look at you like a nut job. Like, how could you possibly, like, how could you believe that Einstein was wrong, such a genius? Or it's like a collective, it's like a collective thing, like, what do you mean you don't believe? Type thing.
Einstein who said, right, so like they'll defend Einstein, right? Einstein who said you'd never be able to tell the difference between geocentric and heliocentric, right?
Yeah. No, but I'm saying once a belief is so ingrained in a person, and once a person is judged to be the smartest person like Einstein, it's like, how dare you? Do you think you're smarter than Einstein? It goes to a thing like that, right? Where you can't possibly be like the smartest man in the world can't possibly be wrong and you be right type deal. It's like a mob, like hierarchical, can't even say the word, mentality, like type deal.
Yeah, like it can't all be bad. You can't pick it apart. Can't pick everything apart. It's like just because like yeah, the first step is just kind of pick everything apart, and they sense that maybe, but you have to be responsible because you can mess people up. If you drop too much on them. I mean, we see it, I guess.
They say that the preponderance of evidence adds up, right? It's not one conclusive thing. It's all of it put together, and you have to believe in the globe. But when you really break it down, it's like, okay, it's rotating, and going all these speeds, but you can't feel it. It's not measurable. The curved water obviously hides the bottom of boats and buildings. I can show you pictures of them, but you can't measure it, right? Things like that is just man, that's strange for someone who measures accurately, and the same people will turn around and tell you how they can measure so accurately.
Well, precise but not accurate.
Well, you can't tell me you can measure down to the centimeter accuracy distances and heights and things like that, and take angle measurements over 10,000 feet and over 20 miles and get the accurate on point height above sea level. And oh, by the way, that mountain is 20,000 miles away from the sea. You know what I'm saying? I'm exaggerating, but you can't tell me that's accurate and then tell me you can't measure the drop of water over a mile.
Also with the ship thing, right? Like they'll tell you, well, look, it's obvious the ship is around the curve. Can't you see it? But then if you tell them, okay, if you continue on this body of water and you get to where that drop is, right? Will there be a drop there? Well, of course not. There's no drop there. Well, if there's no drop there, what's the ship hiding behind? Like it's like this ability not to use the critical thinking, right? Like it just astonishes me, especially with water, right?
Yeah, it's a gradual curve.
Yeah, it's a gradual. You see what I mean? But how could it be a gradual curve when you can never see, you can never reach that curve, right? You see what I'm saying?
You're always on that curve. What do you mean? You can never reach it. You're always
Exactly.
on it.
Exactly. Yeah, this is what I'm talking about.
Well, it's
It's
not
like,
hard to understand that you're just on a sphere. You're trying to make it more than what it is.
Well, we used to be told by this same group, right? Not the same people, but same group, that comes in as a group, that we were always on top of the ball, right? So
You
in
can
any
say you are.
direct way, and then they show us pictures of Lake Pontchartrain power lines. Soundly, it's the exact reason why I became a flat earther. I started researching it. Those pictures of the power lines where obviously you're not on top because it goes up and then down.
No, they don't say you're always on top. They say you can look at it as if you're always on top because there's no up or down in space. So if you can be on top here and everything's curving down away from you, and down is straight down, vertical to horizontal, horizontal equals vertical to or perpendicular to vertical. But if you go 100 miles away, you can then say now you're on top because there's no up and down in space. You can say that's the top and everything's curving down away from you. That's what they mean, that no matter where you're at, you can look at it as if you're on the top of the world because they're in space, there's no up and down.
Yeah, we weren't talking about in space, sir. We were talking about on the water.
I'm talking about on the water too. But that's why they
Yeah, well,
say
it
that
has
because
nothing to
in
do with space.
space there's no up and down. That's why they say that.
Has nothing to do with space. If you're on the
Oh my
surface of
God,
a
dude.
sphere, yeah, okay.
we're doing good.
Well,
Let's keep it chill. Let's
Yeah,
keep it
I
chill.
don't understand. I don't understand how this is hard to understand. If you're on a ball, if you're on the surface of the Earth, gravity's always pulling toward the center of the Earth. The reason why you can say no matter where you're at, you could picture yourself as being on top of the ball is because the Earth is in space and there is no up and down in space. So you can look at the Earth as the South Pole's on top. You can look at it as the equator's on top. You can look at it as anywhere is on top because in space there is no up and down. So anywhere could be on top. So then when you come back down and you stand on the surface, you can look at it as no matter where you're at, you're on top. And it's because there's
yeah,
no up and down in space. That is not hard to understand.
I know, and we understand it, but that had nothing to do with what I said about the power lines over Lake Pontchartrain appearing to go up and then go down. You're obviously not on top of the ball in that case. Now, are you? Is
I've
that
never
hard
seen
to
them appear to go up. I mean, if you were standing at the top of the power lines, they wouldn't appear to go up. The fact that you're down at the bottom of them looking up at them gives a perspective view. But if you was on top of them, they wouldn't appear to go up and then back down. They would just
I'm
appear
not
to go
talking about being
down.
on top of the power lines either. I'm talking about being on the surface of the
All
water.
right then. Then
Right?
you're leaving out the idea of
Really,
perspective, and that's
really,
what's
that's
throwing
where
you
you
off.
just gotta can't even let me explain what I brought up. You're just
You
in
just
my head.
did.
Good.
You just
No,
did.
you just interrupted me for the third time. I let it go the first two, and now it's like, man, this is the MO. You weren't even in the conversation.
Dude, I've been
So
in the
anyway,
conversation
I'll finish
all
my point. It's
night
still
for like the
not your
last
time to
6
talk.
hours,
It is
5 hours.
still not your time to talk.
Cole, let him get it out, bro. Let him get it out.
Again, I'll say, and I can post the picture. when you are looking at power lines, that you are not appearing to be on top of the ball, like the top of the arc or the curve or the bulge or whatever other thing you want to call it, that usually I've heard people deny, and so is SE. There is no bulge. There is no arc. There is no top of the arc, or, you know, one boat could be lower than the other and one could be on the, in the middle of them would be higher. There is none of that, but there has to be on a sphere.
All right, you got it out. Now I'll say it again. You're not adding, you're not factoring in the idea of perspective and where you're standing, where that picture was taken. If that picture would have been taken on at the top of those power lines, they wouldn't have appeared to go up and then back down. It's because you're so much lower than them and you're looking up at them when you take the picture, that perspective makes it appear as if they rise a little bit before they go around the curve. Just like when you stand on the beach and look at the water looks like it's almost as high as you are.
You're always on top, Cole. Come on, right? Always on top of the globe.
You can picture yourself always being if you want to. You can say that you are if you want to.
On a ball, where
So
you
no
are,
curve,
Yeah, on a
wherever
ball.
you go.
no curve then, no physical curve. It's just an apparent curve that you can picture yourself up
No, it's
looking at.
physical.
Oh, it is?
Yes.
How do we know
it
that?
is.
Because we've seen it from space?
No, because well that too, but also because we got people who come in here who's done experiments with theodolites and show that all verticals aren't parallel.
So let me try this, Cole. Let me try this, right? What Rakia just said now in Lake Pontchartrain, right? One side or the other, it's 24 miles, I believe, right? Give or take. So in between those 24 miles, would you say at the center, the 12th mark, there would be like an apex? There would be like a higher, because
Yeah.
you envision yourself. Sorry.
Yes.
So it would be higher, right?
Not higher, but it would be higher to the line that you draw from your point to the point on the other end. If you stood at one end of those power lines and somebody stood at the other and you drew a straight line that went through the water because it's curved, then the middle would be higher compared to that straight line. But if you just follow the curve, since gravity pulls towards the center of the earth, you're not actually higher, you're still the same elevation. You just fall on a curve.
Okay, so with respect to, let's say, the shoreline on one side where Rakia is and I'm on the other side, like A and B, in the center, C, let's call it C in the center, right? In relation to those 2 points, the water would be higher, right?
Yeah, if you and him had a string and you was both holding one end of it, you was holding one, he's holding the other, and you pulled it tight, the middle would dip down in the water. And on each end, it would be basically where you guys were, but in the middle, it would be, the water would be much higher than the string. The string would dip way down in the water if you both had the end of each opposite end of a string from shore to shore, and you pulled it tight.
Okay, so if I was in the center of that point C, I would have to look down. If I turn to my right, I would look at Rakia. He would be lower than me, right? And if I would look to the left and I had a twin and look at myself, that would be lower to my point as well, correct?
Yeah, you would have to. Yes, you would have to look down. Once you looked in both directions, you'd have to look at a very, very slight downward angle to see them.
Okay,
But
I
from
believe
their
we're
point,
getting somewhere.
yeah, but from their point, since they're vertical, their horizontal is perpendicular to their vertical. And if you're on one shore, your vertical is different from his vertical on the other shore. So when you look at each other, if you look perfectly vertical, you would look over each other's heads. You have to actually look down very slightly to look at each other. And that's exactly what's been shown with two theodolites. That's been shown to be the case. You have to look over each other's heads when you look horizontal perpendicular to vertical from two distant points, as if you're on a sphere.
So if I had a theodolite or a telescope, whatever, and I looked from one point, from one end to the other, right? There would be like a hump of water blocking my view, correct?
Yeah, you'd be trying to look over the horizon.
Okay. Okay. A lot of your guys don't believe in that. They call that crazy. There
No,
is
that's
no hump.
exactly what they
There is.
believe. They don't call it a
Sorry?
hump because they don't call it a hump because it's the same elevation. But like I said, if you pulled a string between the two onions, then there would be, you could say, a hump of water in the middle. But it stays the same elevation because it's the same distance from the center of the earth, so it's the same elevation. It's just like if you was on a solid basketball or billiard ball or something, and everything down was towards the center. If you put a line between, then you could say there's a hump in between you two. But if you walk the ball, you would always be the same distance from the center, so you'd always be the same elevation.
Let me ask you this question then. Let me ask you this. If I had a gyroscope, right? And I started spinning it, right? And I went and we all know a gyroscope keeps its rigidity in space, right?
Yeah,
And
it's supposed
I
to.
proceeded from point A to point C in the middle. Would I see any change in the base of the gyroscope? Since
You
we're
should.
technically going up this curve, would I see any change, or will the
Well,
gyroscope
you're not
remain?
going up a curve. You're only going sideways. You're just
You see,
walking around a
this is
curve.
where, yeah,
But
this
you
is
would
where
see
the
a
duality.
change. You would see a change, though. You would see a drift.
No, not a drift. If we were going up a hill, right, or up this theoretical hump that you say, we would definitely see a change in the base of the gyroscope, right?
Yeah, but
Because
you're not going
the
up.
spinning wheel, what?
Go ahead. Go ahead. I thought you was
Yeah,
finished.
because
Finish
the
up.
spinning wheel keeps its rigidity in space, but the base would change, right?
Right.
You would see a change.
Yeah, but you're not going up anything because there's not actually a hump. There's only a hump compared to the straight line drawn between 2 points. Since it's the same distance from the center of the earth, as you walk it, it will feel like you're walking horizontal. You're walking flat because as you walk it, gravity constantly pulls you down. Even though you're going around the curve, your down constantly shifts to constantly pull downwards. So you're not actually walking up a hump. You're walking straight. You're just going around the curve. And what makes the effect is because gravity pulls down, straight down, no matter where you are. It's not like it pulls, backwards on you once you get so far away from one point or something. And
Yeah,
that's what
this is
makes
where the
that weird
model.
effect.
Yeah, well, this is where the model convinces you to say such a thing, right? Even though you are theoretically going up, right? In your mind, you're not really going up. Nothing is changing because gravity is keeping you at a certain angle. This is how you're thinking of it, right?
Yeah, if you
But
wanted
think
to say
about
the
it, if
north
you were on an actual curved surface with a gyroscope, it would most definitely change.
Yeah,
There's
the
no doubt
gyroscope would
about it.
drift. Yes, as you walked around the curve, the gyroscope would it would stay the same as far as the spinning mass, but the frame of it would move. But what you would perceive it as is the frame staying the same and the gyroscope drifting is what you would perceive it as. But
Right,
in
and you're saying that doesn't happen
no,
because
I'm
of your
saying it does
belief in
happen.
this model.
No, it does happen. It drifts as you if you start a gyro. That's exactly what I was arguing a while ago about the Saturn V. This is the problem that they had when they fired up the computer on the Saturn V rocket. The thing had like 4 or 5 spinning mass wheels, big, heavy mass wheels that was their gyros that told the thing which way it was pointing. Well, it took them hours to get the thing ready to launch. Well, they would fire everything up hours beforehand to make sure everything worked, go through all the checks, get everybody on board, get everything going. The whole time those gyroscopes were spinning, if nothing was done as the Earth turned, the gyros would think that the rocket was literally laying on its side because it's literally the Earth is turning and it's on the ball, and as it's spinning, the gyros staying the same, but the Earth is turning. So
Okay,
eventually, after enough hours, it would think it's on the outside. So they had to actually have a system built, set up that constantly updated the computer to tell it where vertical was, all the way up to
okay,
launch.
Okay, I'll let you finish. I don't want to interrupt you, but before
Yeah,
we
I'm
go
sorry.
into
Go
space,
ahead.
right? Are you saying if Rakia could do this tomorrow, right? He has a boat and he has a gyroscope. Are you saying if Rakia proceeds to go from point A to point C, which is the middle of Lake Pontchartrain, are you saying Rakia is going to see a drift, a change in the base of the gyroscope? Is that what you're saying?
If he has a high quality enough gyroscope and he can get good readings from it, if it's not real choppy water making it hard to read, yes, he will see it drift as he goes across the lake.
I don't think that would happen, bro. I really don't think that would happen.
Well, I mean, boats have ships have what's the real fancy
gyro compass?
Gyro compasses on them, and that's exactly how they work. They literally have a gyroscope built into them that moves as they go around the world.
No, I get that, bro, but that's not what I'm talking about. I'm talking
It's the
about a
same thing.
gyroscope, right? Because we know a gyroscope is designed to keep rigidity in space.
Yes.
So if what you believe is happening, if there's an apex there, like a curve, right? And Rakia would get his boat, you're saying that the base would have to move, right?
Yes. If you set it to vertical,
right.
then as you went across the lake, you would notice it drift.
I bet you anything, bro, that will not happen. I'll bet you
Okay.
anything. I'm willing to bet you anything.
All right.
Well, within reason.
They use them in planes every day. Millions of planes around the world have gyroscopes that very thing happens on. And boats too, ships too.
It wouldn't
So I
happen,
mean,
bro,
it's a pretty easy bet to win on this. It's not.
Well, I don't know if
It'll be
Rakia
a
is willing to do this, and I'm sure he's a busy man. But if I had a boat, I would show you tomorrow, bro. That thing will not. Wouldn't change. It would stay completely level. I'm willing. Like I'm almost certain of that. But that's a pretty easy test.
Yeah.
What airplane
I had
has
both.
a gyro in it that processes with the curvature of the Earth?
Every airplane has a gyroscope in it.
Oh yeah, yeah, I know that. No, what was the last part of my sentence?
Yeah, that processes with the curvature of the Earth. If they're not constantly updated, they will get out of whack. They have to constantly be. They have to calibrate them before they take off flight to calibrate them, be level like they're supposed to be, and everything else. And they literally, as they fly around the globe, they move. That's how they know different things that's going on around them.
That's how they
They
know
pick it. They. Yeah, I'm not trying to go into details right now. I mean, I can
hear you.
start if you want me to start like Googling it, which is pretty easy to do. You know, I'm
No,
not
I don't
going
want you
to.
to talk shit.
I'm just trying to make it quick and simple.
No, because you're talking about pendulous veins correct for the curvature of the Earth. Is that what you're trying to say using a vacuum system? What
Yeah,
about a
and
mechanical
why would they
gyro?
have to do that? Why
Well,
would they have
they
to
I don't.
correct for the
That's the
curvature of the Earth?
reasoning they give you, but I don't think that's what the pendulous
All
veins
right,
are for.
all
When I
right.
look at them, that's what
Great
I've heard
answer.
from here. But what about a mechanical? I
Great
don't know
answer.
why you got to quote me, dude. Do you have something wrong with you?
No, it's just funny that you say, "Oh, I just don't believe that." It's like
No, I've looked
physical
into it.
things in
Obviously,
reality that you can go look
you
at.
didn't even
If you
mention
don't believe
pendulous
them,
veins. You didn't even. You
then
said,
that
"Oh,
tells more
oh, they
about you
just
than it
use
does
it
me.
to correct when they're moving around." I mean, that's what happens. I brought up pendulous veins because I know what you're talking about, and it didn't seem like you did. But I'm asking,
Oh,
what about
actually, I can't remember the name of it.
You're clipping again, bro. What about mechanical gyros? Like
What
when
about
you
them?
spin a mechanical gyro up and nothing's going to correct, it just holds rigidity in space. When you went across the bridge or over the water or flew in an airplane, wouldn't it have to adjust for the curvature of the Earth somehow?
It does. You just said pendulous veins on airplanes, and gyro compasses do it on ships. And you can do it, and you can
Mechanical.
do it in your own car. Like literally, you can literally.
Please, I'm big
Bob
time.
Nodell built one and showed a 15 per hour drift on his table. All right.
Yep. Why
Like
you believe it?
literally,
That's
I
Earth's
mean, it's something
rotation.
you've
That's not.
never done, but you just
It's
don't want to
Earth's
believe.
rotation you're talking about now, bruh. Not curvature. What
You
is
think it
wrong with
rotates? You
you,
think it
man? Because
rotates and
that
it's
dude
flat?
said he picked up the precession of Earth's rotation. He's
You
one
think
of
it?
the only people in the world that's done that.
Are
That you
you
just
kidding?
blindly believe
Are
it, and we're
you
not even talking about
kidding
that. We're
me?
talking about going over the curvature of
Oh my
Earth,
God!
not the rotation of Earth. Do you know the
One
Yeah,
of
those
the
difference?
are
one
two
of the
different
only
things.
people to ever do it. One of the only people you're telling me to ever do it, which is an absurd
He
statement.
was joking. That was sarcasm because people bring up
Yeah,
Bob Nodell, a man who has passed. It's very, very rude and toxic to be trying to assault somebody who passed on because Bob was obviously he's joking because Bob was not the first one or only one to do that. These devices work that way. It's been known for eons of time that's how they work. In addition, Bob did not think that was Earth rotation. So it's very, very
Right.
unfair
just
and many
continue.
other things I could say to
So
bring his name up in any of these conversations. And we're trying to disparage his character when he's passed on. And he himself did not think it was Earth rotation, nor did he discover that 15 degrees. That 15 degrees is called the Sagnac effect. It's been known for eons of time, way before him.
to start with, I did not discourage him. I said he built one that showed it. And secondly, Geo, you allow people to say that the astronauts killed on the space shuttle have twins and it's all fake. You allow people to say things like that Charlie Kirk is still alive. You let people come in here and discourage people who have lost their lives all the time. So don't give me that bullshit.
Okay, that's a different thing, actually. So if somebody in here said Bob Nodell faked his death, that's not really a problem. That's not necessarily desecrating his a deceased person. That's a different thing. However, misrepresenting him, slandering him, and trying to assume that
And who
trying to claim that he
misrepresented
measured
and
Earth rotation, trying to slander him and say that he measured Earth rotation, use him as a citation, is desecrating the deceased.
who misrepresented and slandered. Never once did I say anything bad about him. Never once did I say anything wrong about him. All I said was he built a gyro and measured 15 degrees per hour drift. I didn't say what it came from, and I didn't say one bad word about him. So
So
hush and
why'd you
get off
bring
your
him
high
up?
horse and quit
Why
acting
did you
like
bring
that
him up?
you're
Why did you
somebody
bring
who
him up?
of this great
Why did you bring up Bob Nodell? Because
set
the Sagnac
is or
effect is well
whatever.
known beyond Bob Nodell. Why are you bringing up a man who has passed on that you have hate for, apparently? Why are
I
you
don't have
bringing
no
him
hate
up
for
then?
Bob Nodell
Why are you
because he
bringing him up? What
because
does
because
Rakia have to do with Bob Nodell?
because Bob
Because Bob
Nodell used
Nodell
a
was involved in
gyroscope to
flat
measure
Earth, you just need to
15
disparage
degree an
his
hour
name?
drift.
Because Bob Nodell was involved in flat Earth, you need to disparage his
How am I
name and
disparaging his name, Geo? Explain
try to make
that.
he measured Earth rotation, which he did not.
How do you know? How do you know it wasn't Earth rotation? You're just asserting.
Well, we weren't even talking about Earth's rotation. So you brought Bob Nodell in something about using gyroscopes to process over Earth's curvature, and then all of a sudden you're bringing in Bob Nodell brought up 15 degrees per hour Earth rotation, which wasn't even the topic. You
Yeah,
just
because you
off
said
the
nobody
rails.
has ever done it to begin with, and I named one person who did measure
That's what I
rotation, whether
said.
it's rotation from the sky or the ground or whatever. It was still measured with a
Rotation
gyroscope.
for the ground. We're talking about curvature rate, processing over a curved surface, not
Yeah,
rotation. Are
yeah,
you lost?
Yeah,
yeah.
left lane. Those are two different things, bro.
This isn't left
We're
lane.
talking about the displacement of the base due to the spinning wheel, which keeps rigidity in space, going over a curved surface, not rotation. We're not talking about rotation here.
No, but the flat Earth, I'm sure, doesn't rotate to make a gyroscope rotate. And also, like these things go on all the time around the world. They're used in navigation constantly. They constantly show that as they move, they drift. That's how they get their readings from them. The drift is what gives them their readings.
Yeah, but left lane, we're not talking about
This
that, bro.
isn't left lane.
Sorry, Cole. Sorry, bro. Cole, we're not
Oh,
talking
man.
about that. We're talking about two different things.
I
Like,
know you're not talking about rotation. I know you're talking about going around the curve. I just brought up rotation to show that it has been that gyroscopes are used to measure different aspects of the curve. And if something
let's
is round,
reset.
we say it's
Let's
round and it's
reset.
rotating. So that's what's going on. But if you don't want me to talk about rotation, then I'll just stick with Earth curve.
Oh, we can talk about rotation later, but
any mechanical gyro that shows precession of Earth's curve. Can you post any one? Just one? There must be millions of them.
Here, let me look one up.
Gyro spins up. It's at its level, right? They spin it up. It's at 0, no degrees, and then it goes for a distance over water or whatever you say is curving, and shows that precession 1 degree per 69 miles. Go ahead. Good luck. You know that's what it would have
that
to
was
do,
my whole
right?
point when I brought up the
Every
Lake
69
Pontchartrain.
miles, it would have to process 1 degree.
Yep.
Yeah.
That's what I'm talking
Every
about. That's what
69
we're
miles.
talking about.
Can't show that. You will never show a mechanical gyro going over water or anything else you say is curving on Earth like that. That processes 1 degree per 69 miles. If you could, it would be posted right now.
Yeah, I'm looking one up right now.
Yeah. You
Guess
think we're
what?
just
Guess what?
here for
Guess
nothing,
what?
right?
Guess what? Guess what popped up when I typed in an experiment where a gyro shows drift as it moves over the curve of the Earth? I want to read to you. I'll post in the chat what popped up. It says the most notable recent experiment where a gyroscope demonstrated drift, or more accurately, detected the rotation of the Earth. And I know we're not talking about the rotation. I'm just going to read. You'll understand why I'm reading this to you.
But
It
why
says,
are you going to read that,
listen,
bro?
no,
That's not.
you will understand. I promise. It says the rotation of Earth is drifted relative to the instrument occurred in the 2018 documentary Behind the Curve. Flat Earth proponents, including Bob Nodell, invested $20,000 in a high-precision ring laser gyroscope intended to prove the Earth was stationary. That's what popped up when I typed in an experiment where a gyro shows drift as it moves over the curve of the Earth. It even brought up Bob Nodell.
So you guys
Oh,
go to
with all
Flat
due
Earthers?
respect-
So you go to
No,
Flat
I
Earthers
didn't.
for
I
your
went to
information?
Google.
You went to Flat Earthers?
No, I went to Google and typed in something that had nothing to do with Bob Nodell or Flat Earth whatsoever, and that's what it showed.
So Google is the one that's going to trying to propagandize and be deceptive
It
about Flat Earthers?
must be, because that's what popped up, and
So
and
that's
I
what Google
promise.
depends on for gyroscope testings?
I don't know
Yeah,
if
can
that's
we
what
get
popped up.
back
I
to
just thought,
the gyro
it's crazy that
precession over
popped
the
up.
curvature of the Earth, not because of rotation, but because they're going 69 miles per 1 degree? Can we show that video? I'm waiting. I got an hour and 44-minute drive ahead of me. I'll wait all hour and 44 minutes for you to post one.
This AI overview thing is also deceptive because Bob did not get that to try to prove the Earth was stationary. That
Yeah,
was not
I don't
what he did
trust
at
AI.
all. Bob
Don't
was a
trust AI.
pilot and knew very well about the Sagnac effect way before he experimented with any of those gyroscopes. He was fully aware of that. He wasn't expecting it to be 0. He knew it would be 15. He knew about the Sagnac effect. He's a pilot and he was in that field, as far as I know. So that's just totally false. That AI thing is just deceptive and wrong.
It says artificial horizon in aviation. Aircraft use attitude indicators, not altitude, attitude indicators, artificial horizons that employ gyroscopes to remain upright. As an airplane follows the curve of the Earth, the gyroscope remains fixed in space while the plane pivots around it, causing a slight calculated drift that is managed by the instrument's self-correcting mechanisms. There you go. There's something moving around the curve with the gyroscope staying stationary. I told you,
Not a
airplanes do
mechanical
it every day.
gyroscope.
Oh,
And
okay.
not
Move the
a
goalpost.
mechanical gyroscope. Do you hear me? I'll
No,
state
we
it
couldn't hear
again.
you. Say it again. It was over talking.
Post
Say it again.
a video, please, of a mechanical gyroscope that doesn't make any corrections, right? That would show 1 degree precession over 69 miles of your curved Earth. Because one
Yeah,
that
that was
doesn't
my
make those
original. Sorry, Ricky. I thought you were done.
Yeah, I mean that's the original point, and he keeps obfuscating to ones with pendulous vanes that are supposedly correcting for drift as they go over curved Earth, but that's not correcting for curved Earth. I
Yeah,
mean, he
and
doesn't
the
even.
example.
Let's put in a mechanical gyroscope then.
in the example that I gave, right, in Lake Pontchartrain, it would have to show 12 degrees of tilt, right? Because it's 12 miles in the middle. So it would have to show 12 degrees, correct?
No, it's 1 degree per 69 miles.
Oh, my bad. Okay, yeah, I'm off on that one.
Yeah,
So it
it's
would
1
have to be
degree per
longer. We would
69
have to
miles.
travel a longer length. Okay, yeah.
God,
But it
Google
would
knows
still
us
have to
behind the
show
curve.
some drift, some tilt, right? It will not be in the same starting point.
It would drift. I've typed in 3 different things that had nothing to do with the flat Earth whatsoever, and all 3 things just give me back that.
Yeah, it's because the
one
people who run Google are on
one
damage
over there.
control mode. They're on extreme damage control
Behind the
mode, and they're
curve.
very afraid of their deception bubble being popped.
I know it.
They're
I don't
gonna-
want nothing to do with it. I'm trying to just find the regular, what he's wanting, and it keeps giving me the behind the curve thing.
Yeah, because you can't find one. If there would be not millions, there would be at least 25 Globers that have come in here over the last 10 years that would have taken a mechanical gyroscope and traveled on boat 69, 300, 400 miles and shown the precession of a mechanical gyroscope. It doesn't happen. It will never do that. And oh, by the way, you could double check it by, if you say the tangent line over Lake Pontchartrain is going to be 80 feet above each shoreline. If you touch the water at 12-mile mark and you go in each direction 12 miles towards the beach, you're going to end up 80 feet or 90 feet above the beach, whatever it is. I think it's 90. Then you could do that line with a drone or whatever and show that it doesn't precess. And then as it goes over the water, it should precess, or opposite. One or the other. It could be easily tested. The other thing that Globers don't have is a horizontal line over static water, and then just taking a simple tape measure and measuring the 6 feet that you would have over 3 miles or whatever drop from horizontal. That's not a video that you can post either. It's weird. The 2 easiest would prove flat Earth wrong, which have nothing to do with the sky, which would be physical first order measurements, can't be shown. Don't exist. It's why y'all go to the sky every time in space. Even you, when we're talking about the surface of water, bring the conversation to the center of the Earth with gravity and space.
Yeah, because I was explaining to you why they say that. Should be able to follow that.
You're agreeing you did that. Yeah, it's awesome.
Yes, because it was explaining to you why people say that.
Yeah, like I don't know. I've been here 10 years. You think I'm stupid?
Apparently you don't. You keep repeating it was crazy for me to say that.
Water, you need to explain how we see it from space.
I didn't say anything that didn't have nothing to do with how you see it from space. So you didn't even listen. You don't even understand the concept. Yet you want to say the statement. You want to say the statement without having any comprehension of why people say
sir.
it.
You're just so ready for me to be wrong.
I didn't make a mistake. I didn't make a mistake. No, I'm just telling you why.
I made a mistake. You are just so ready for me to just be wrong and you be right. You didn't even listen to me saying I made the mistake. I said you saw it from space. That was my mistake. But what I am saying, when I was talking about the surface of water, you brought up the center of Earth. Is that true? With gravity.
Yes.
Yes. And you brought up space, correct?
Yes.
Thank you. That's all I was saying.
And Bob Nodell measuring the Sagnac effect.
When we were talking about measuring the curvature of Earth, not the rotation. It's weird.
So
why is it weird to explain how something why people say something? How's that weird? I was explaining to you why that's said, why people say that you can say you're always on top of the Earth. I was explaining to you why people say that. There's nothing weird about that.
But another thing that's weird, I'll point out, is 10 other Globers that are not listening right now could come in separately. I could do the same thing and they would give the same exact responses.
Yeah, you know why?
And that's why we
Because
say it's
the truth always stays the same. A lie or
you don't
something
know if it's the truth or
misunderstood
not.
constantly changes. That's why my
No,
side
what
always
your
gives the
bias
same
is remains the
answers.
same. Y'all all have the same bias. You all have the same textbook that you learn from. You all have the same authority figure that you think are truthful. That's what you're saying right now. What I've read, what I've learned, what I can Google, as you didn't know what you were talking about a while ago, said you could go Google it, and you did go to Google. Whatever that says, you're good with.
I'm googling what you wanted to find an experiment because I don't know. I don't have every experiment done with gyroscopes just on my head
Okay,
to rattle off. But
fair enough.
when it,
Fair enough.
but right, but when it comes to things like what I was saying, like about the water and stuff like that, no, I have learned that. But the thing about it is, those science books it wasn't just like somebody sat down and said, well, I think this is how it works, and they wrote it down, and I think that's how it works, and they wrote it. No, all this stuff in these science books were figured out by meticulous experimentation.
Right, right. And don't you think it's a little strange just using your common sense, forgetting about everything, that there are no videos being posted right now in chat on a flat earth forum showing a mechanical gyro processing at 69 miles, 1 degree?
I'm sure they probably are. I'm not on YouTube.
Yeah.
I'm
Yeah,
on
they would
Google.
be in here right now.
I'm reading. I'm not watching videos.
So
It
did we
says
finally did
Foucault's 1852 gyroscope experiment was a pretty popular one.
so guys did we finally come up with a slash quote unquote experiment? Did I finally come up with something that we can both agree on, both sides, that if we have a gyroscope on the water and we travel 69 miles, it has to show 1 degree?
It should.
So we finally
Yeah,
found
but
something.
it does
Not
everything.
fishing wire, not ropes, not lasers. We finally found something that we can easily do and agree on.
No, it won't work. You want to know why? I see. Because
Why?
the 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 very smart engineers that have learned from all these scientists are not capable of making a gyro accurate enough to show the 1 degree over 69 miles. Now, just imagine that another very precise tool that's used for the safety of all human beings, basically, and is used in all types of mechanical instruments to accurately predict rigidity in space. Can't mess with it. I wonder why.
But I think we got called to agree there, Ricky. I think we got called to agree on that.
Yeah, I mean, I think it would drift
Yeah,
in
I don't think he knows
uniform
what he's.
work.
I don't know what you're agreeing. I don't think you know what you're agreeing to. You realize what you're agreeing is if you had a mechanical gyroscope, you could keep spinning at a certain speed long enough. If you traveled around the Earth, it would flip over.
Yes,
Yeah, I know.
that's what it would do. That's what it would do.
That would be a cool video to post right now too, wouldn't it? Good luck.
Well, that's my whole point. If they can agree on that, we can easily show that. That's an easily thing done. We can rent a boat, or we can use your boat, Rakia, if you're willing. You can get a gyroscope, and we can easily show this. We finally came up with something. How do you like that?
Yeah, I brought that up a year ago. Like, get on an airplane, let it level out at altitude, spin up a gyro, and you're going 500 miles an hour. So in 1 hour, you've gone 500 miles, however many degrees that is. A mechanical gyroscope should process 8 degrees or whatever it would be.
So
They
ballers,
said they don't make gyros that accurate enough to do that.
we got one baller to agree with it, Cole. How about the rest of y'all? What do you think?
It's you all.
Well, I'm trying to be Southerner, y'all.
Y'all.
Going through Lafayette right now. It's definitely you all here. Y'all.
Wouldn't
y'all?
wouldn't the ring laser gyroscopes that they have already, where they calibrate them for the Sagnac effect when they're on the ground before they take off when they're at rest, they calibrate them for the 15 degrees and then they take off, and then now after they take off, because the 15 is accounted for, now if you do pitch and yaw and roll as you go XYZ, it's going to pick that all up. Why wouldn't those pick up the axis change of the plane going over the globe if it was there? Because those are very sensitive. They can pick up all the pitch and yaw of the airplane very sensitively. So why wouldn't that pick it up if
It
it was
does
there?
pick it up, but like you said, it has mechanisms on it that keep it to where it's constantly oriented with the
Well,
level
so
with
Cole,
vertical and horizontal.
you realize what you're saying. If you take these real accurate ring laser gyros with pendulous vanes and you travel over Lake Pontchartrain on the water, right, it wouldn't show any precession because they're accounting for the 1 degree.
Yes, with pendulous vanes, it wouldn't.
Right. But then if you took the same gyroscope and did the tangent line, right, because you can calculate that, you need to start 90 feet above the North Shore, barely be over the water or touch the water at the 12-mile mark, and end up at 90 feet above the other shore in a straight line, then it should persist, right?
Yeah, it should.
Yeah. Yeah. Good luck on that one, too.
Yeah, that's just having a gyroscope and moving around a curve.
So we
Yeah.
finally found something that will.
Yeah,
You're right, though.
we have
You're right. Every video that I see, though, is just saying stationary gyros that pick up the Earth's rotation. I can't find any that shows somebody actually carrying one. Now, there's a bunch on airplanes. There's a bunch on airplanes that has them on board, but I can't find anybody on water or on land doing it.
They're required to have them in the airplane. What the
It could be other
altitude?
reasons, though.
Yeah, but those are self-correcting. Those don't count, bro. That's what we're trying to tell you.
But he's correct.
Well,
You can't.
use the
I haven't
self-correct.
seen one yet of somebody traveling across the land and it showing it.
You could use the self-correcting. You would just have to use the tangent line. And the tangent line doesn't have to touch the water. You could start 10 feet above the water and then add the 10 feet to the distant shore. So instead of 90 feet above the beach, you start at 100 feet above the beach and then you fly over the middle 10 feet above the water, go to the opposite end, opposite shoreline, and be 100 feet instead of 90 feet, which would be the curvature rate, the drop. But you add in the 10 feet of that you're above the point where the tangent line would touch the water in the middle. And that very accurate with pendulous vanes gyroscope should process because the curvature is underneath it that it's adjusting for, but you're going in a straight line, the tangent line, horizontal. Can't have it both ways.
Well, the pendulous vanes always keeps it set to where vertical is straight down from its current location. So even though verticals change, the pendulous vanes work to constantly reorient the gyro to where it's always perpendicular to vertical no matter where it's at, even though vertical is changing underneath it. That's the point of it.
But you realize driving over that bridge, they say you're following the curvature of the water, right? Because the bridge remains constant 16 feet or whatever it is above the water. So if you drive in a car with that gyro and it doesn't that means to you, that means you're following the curve. But then if you got out of the car and put that, yeah.
No, if it doesn't process, that means it's flat.
No, one with pendulous vanes is correcting for the curvature.
Yeah,
that's what they.
But I'm talking about if you just use the regular gyroscope. Why
Well,
would
this
you
is
want to
why
use one with
for this
pendulous
test,
vanes?
the way we've talked about doing this test is to have both. Have one with pendulous vanes and one without, and have them right next to each other on the airplane, and then do it that way.
Yeah, that would be a cool test. I'd like to do it on a boat or on like a bridge, like he's talking about. That's. I would love to do that.
Hey,
yeah, boat. The boat would be better.
I like Jesse's pulling the buoyant line through water, creating a cord line because you can't do it in the air because it's going to have too much dip, like sag because of gravity, of course. But when you put a line underwater and it's supposed to go to the bottom when you pull it tight and it doesn't, or it's either way, right? you could test it several different ways. Like you could lift it up in the middle with a slight cork or something that would make it float towards the top. And when you pull it tight, it's supposed to go underwater as a cord line, and it doesn't. You got a problem.
Yeah.
I actually think Jesse performed that test and is now, you know,
Not wanting to reveal the results.
if he's done the test and done it like I'm saying, because I saw a guy that had done it, and he said it. This guy that I saw said he was going to do it longer distance. He had woven a line that shouldn't sink or do, because that was some of the issue, and he pulled it tight on top of the water, and it didn't go above the water or below it. It stayed on top. But he said he wanted to do it for a longer distance, but I've never really looked into it that he did.
I don't think it would be very accurate because I feel like even a line that's supposed to sink buoyant down in the water or whatever, when you got that much line stretched out apart, it's hard to get it pulled tight. It'll still want to float. It'll want to move out in the middle of the lake that you've got it stretched tight across. It'll want to drift one side or the other a little bit. I just don't feel like that would be. You'd have to have a really strong line to pull taut from a long distance.
But follow me for a minute. Say you have it anchored at water level, right? Like it's where the sand and the water on the shoreline of the lake or whatever meet.
Right.
That's where the top of your line is anchored, and on the other side, you have an anchor and a pulley system at that same level, the water level, right? And then the cord line that you're pulling is supposed to be, let's say, 5 feet, just to keep it. Let's say 10 feet. It's easy to think about. When you pull that cord line, it's supposed to be in the middle, 10 feet under the water. Okay. So what I suggest that is done is that you put a weight or whatever that would in the middle make it the cord line where the cord line would be 10 feet, right? Let's just use that as an example. And then pull the line tight. And I will be willing to bet that it's going to pull and go up towards the surface or to the surface. And it shouldn't if it's a cord line, right? It should be under the water. I think that's a really good test. It's hard to make a straight line, but it's not hard to dictate, especially fishing line like that, pulling it tight, going up and down when it should be 10 feet under the water in the middle and it goes up to the top, then you got yourself a flat surface there, sir.
Yeah. Yeah, you would.
What distance are you talking about there?
Long enough where you would have 3, 4, 5 feet of a cord underneath the midpoint, right? Like your tangent touches, like Cole was talking about a while ago, the cord line would be underneath the center of the water. It would cut through the earth, cut through the water. So if you're at the surface on each shoreline and you pull it tight, it should go underwater to create a cord line. Depending on the distance would dictate how far under the water. So when you do the distance according to the curvature rate, you would figure out the cord line distance under the water and pull that line down. And when you pull the line tight, if it goes up, then it's not a curved surface, it's a flat surface.
Oh, absolutely. Yeah, absolutely. But then they're going to tell you sag and this and that. That's why, I mean, I like that, but I think the gyroscope would be a little bit better than that. But yeah, I mean, if you can figure out what distance that 3, 4 foot would be, what would it be? A couple of 100 feet, 1,000 feet? What would be? You have to figure out.
Like over Lake Pontchartrain, it would be 90 feet. I mean, you wouldn't have
Yeah,
to
but
do
you're
it
talking
24
about
miles.
a 24 mile line now. That's
Yeah,
kind
I
of
don't think you could do that, but think about it. Even you start cutting that down to 5 miles, you're still going to have, a good enough distance under the water where if you pull that line physically underwater, you dictate that the line starts underwater and you start pulling that winch tight and it pulls the middle towards the top of the water. Houston, we have a problem.
Yeah, well, somebody can do the math quickly, right? somebody could do the math and figure that out real quick.
Oh yeah, there's smart people in here that can do that. But I brought up the gyro on an airplane, and then I think Gio or one of y'all in here came up with doing both of them at the same time, which because when I brought up the mechanical gyro, which would do away with the pendulous vanes and everything that auto corrects perfectly for the curvature of Earth, which is ridiculous in itself. But if we use a mechanical, they said there's not one that's accurate enough to measure the Earth curve. That was
Well,
the
they said the
excuse given.
rotation. There's not one accurate enough. They told me all the time because I wanted to do this for a
Yeah,
while.
only a mechanical for that. Yeah, but we were talking about 500 miles an hour. In 1 hour, you're going. What is that? I can do that. Hang on. 500 divided by 69. That's 7 degrees. I was a little off. I think I said 7 earlier, doing it in my head. But 7 degrees. If you can't get one, it wouldn't even have to show 7 degrees. It could show 4 degrees, right? And I would believe that it's curving. It just might not be accurate enough to measure the 7 degrees that you would need, right, to be accurate. But being not accurate doesn't mean it's not curving when it's supposed to be 7 and you get 3 or 4 degrees over 500 miles. Then I'm on board then, right? I'm thinking the opposite way than what I'm thinking now. I promise you that. But you'll never find that. If you would, it would be posted right now. You know how adamant these guys are proving us wrong, and this hadn't been done.
Yep, I'm with you. I don't think it'll show anything. I'll think it'll be exactly where you started off from point A to point B, over 400 or 500 miles, as many miles as you want. That's what I think.
Yep. And if you don't think these little toy gyros are accurate, just get one, put it on your dashboard, and make any slight movement or go up a hill or down a hill or do anything. It shows the tilt of the road. Like, you know what I'm saying? They're amazingly accurate. You can do it on your table, right? Just get this toy gyro. It doesn't cost very much, $50. Spin it up, put it on your table, and tilt the table very, very slightly and watch that thing tilt. They can't help but be accurate. It's like water. It's like bottled water, right? As soon as you barely move it, it creates that angle.
That's why it would
No
be
way
cool to
around
have
that.
one. That's why it would be cool to have one and start on one side of Lake Pontchartrain and drive across that bridge to the other side. Take you a measurement of it when you first started to see how much, where it was at to begin with. And then take a measurement when you got to the other side to see if your local vertical was had changed or was stayed the same. If it changed, your gyroscope would be showing a drift. Local vertical changed, and was it the same as where you started?
It would have
You
to show
would be
like a
showing a
third
drift.
of a degree or
Yeah,
something. Yeah.
but if it was flat, it would stay the same. That would be a cool experiment to do. I'd like to do that.
I don't have a good enough, expensive, accurate enough one to really waste my time doing. I've done it with the toy ones. I call them toy ones, the ones that you can just buy on the,
Right.
on the web or whatever. And when you do it, it shows every time you go up one of the angles, like you get on the bridge from the land, it shows that, and then it evens out on the flat part of the bridge, and then it's even for miles, right? It don't show a tilt, no angle change, and then you go up where the boats pass underneath. There's 5 of those. There's 2 big ones and 3 short ones, and it shows a whatever degree that you're going up, and then you go over the other side and it shows the opposite degree going down, and then you go on the flat part and it levels back out to the same level you were on the other part. It's as accurate as, you can't. I don't know. I don't know what to tell you, man. The airport's right there. You can fly there with your own and prove it to yourself. I don't ask people to believe me anymore because it's futile now, right? They come up with excuses and they'll tell you that me using that cheap gyro doesn't prove anything because it wouldn't be accurate enough to show any type of earth curve anyway. But what it does show is that the bridge is miraculously level, right? So and people say it's following the earth curve, then that gyro should show some type of change, and it doesn't.
I disagree. I'd say it does, but we would have to do the experiment to see.
This is not that difficult to do. This one is not really that difficult.
It's quite easy, actually.
Problem with doing it on a boat is if it's rough, you're gonna get a lot of banging around.
It won't affect
traveling
the
long
gyroscope.
distances.
It won't affect it.
Well, you don't think so? If it's banging around in
No,
a boat,
It's point A to point B. It doesn't matter if it's rough in between. If point A is level, right? You spin it up and it's level, and you go 24 miles across the lake, and you're supposed to be curving. You would check it at the 12-mile mark and 24, or however far you go, 100 miles. I mean, we go offshore fishing. We're 200 miles offshore. You think we're going over a curve? I mean, you think a ship is hitting, the curvature of the earth is hiding a 6-foot observer from the beach. 30, 40 feet of the ship is missing, or it totally disappears, and it's 40 feet tall, and you can't take a gyro and show that angle?
right?
That's
Well, that's yeah. If
hard.
boats were, that's a good point. If boats were cutting off because of curvature, you should easily be able just to ride that between your observer and the boat, since they claim that that's all curvature, and measure the gyroscope tilting. Yeah, absolutely. If that actually was a thing, and like you said, it would already be done by now. That would be so easy to do if we were on a ball. That would have been done over and over. This conversation would have been in a much different thing if that had been done and shown. But
Well, it
it
is.
never
That's the
has.
point of pendulous veins.
Yeah, so remove the
I think
pendulous veins.
it's precession of the gyro. Like if it's spinning left to right, anything that rotates like that is going to have a torque, and I think those gyros keep it from precessing in that way. You understand what I'm saying, Cole? Because you're smart enough to figure that out. What they say is that it's spinning so fast, they have to be spinning in a certain direction, right? That's what gyros do, left to right or right to left, right? So if something's spinning like a top or whatever is spinning in a certain direction, it will tend to drift to that direction. You agree with that?
Yeah, it drifts. It has. They got a name for it. I know what you're talking about.
Torque or whatever you want to
It
call it, right?
processes in a certain
Right.
direction.
I think those pendulous veins are made to keep that, to correct for that, and they took over the pendulous veins as precession of curvature, and I just don't think that's right. I mean, I didn't know anything about the laser gyroscope and pendulous veins before this topic, right? The gyros that we have are vacuum operated and don't have pendulous veins in our smaller aircraft that are cheap. I mean, these gyros are more. They cost more than the plane that we own. You know what I'm saying? So you don't put them in those type of planes. I think they've come down in price a lot now. I think you can get a decent one for like 10 grand or something like that. But still relatively expensive, and a lot of maintenance and a lot of highly technical things that you don't really need in a smaller aircraft. They use them in the larger passenger jets, of course.
That's what I was going to say. Do small aircraft use the light ones, or do they still use like mechanical ones?
The older ones don't have the pendulous veins, but the newer ones, like especially like small 7, 8, 9 passenger jets, they have them. Like my friend's twin engine jet, he has a really nice gyro set up, and it's expensive. I don't know the brand or whatever, but I've talked to him about it before. He's a pilot that still thinks the Earth is curved, but I have several friends that are pilots, my brother and my nephew, that my brother's plane doesn't have a pendulous veins in his job.
That's cool.
Now my nephew flew for the Navy, and they had, of course, the most expensive and whatever.
Cool that you
I
got
tried to
pilots
call
in your family, brother.
I have a lot of pilots, family and friends. A lot of people fly here, like personal plane, like just a lot of people fly. We build a lot of. Matter of fact, I'm driving right by one of the developments we did that has a runway, and off the runway, left and right, are houses with hangars. So they fly in, park their plane like you would in a garage, in the back of their house, and then they have cars in the front of the house in the garage. A lot of oil money. A lot of people around here have planes.
No way.
That's really cool.
Yeah, yeah. My friend, he runs we actually play poker at his hangar, but he runs a service, a plane service. They have 4 jets, I think, 3. But like we'll fly, when we go play poker tournaments, we'll get our friends and fly on this plane. It's out of my league. Things are like 9,000 an hour to operate. It's crazy. But they charter them to all the businesses around here.
Like jets. Or
Yeah, all his
turboprop.
planes are jets. Yeah. My
It's
brother
not
has
a
a Tiger in
else.
England. Go ahead, Essie.
I was thinking, what do the ballers think about the salt flats? They think that curves as well, right? There's a curve there.
Absolutely.
Salt flats.
You've got horse sense.
Sorry.
That's a good thing. No, I know how many. There's a lot of flats. There's some in Africa.
The
Some
Bolivian salt flats where they do the car things and speed records.
Zanuck might not say they're curving. He says that on a sphere Earth, there's water and land that doesn't curve in large sections. Like somewhere near India, there's a patch of water or ocean, I think he said, that doesn't curve.
Hey, realize what
I
that
don't know
does
why.
to the oven?
Yeah,
What?
The lap
that
time.
Yeah,
Just and you stop. I'm sorry, that was
yeah, that
an
Bolivian one.
hard to fall when you got flat spots.
Yeah,
Say again. I don't think I heard that correct. Say again.
For me,
I was
Who you
trying
yeah, I
to
talking?
mean,
say. Go on.
We can't really hear you. You're breaking up, man.
okay.
24. I don't know what you got to do to fix your mic, bro, but it's just been choppy since day one, man. We can rarely ever hear you. I don't know, try to get a new headset or I don't know, something, man.
I was going to say that Bolivian one, they actually done a test and they measured Earth curve on the Bolivian one, which is ridiculous.
Oh, they have? Okay. So my
Yeah,
next question would be then, we don't have no waves, we don't have no chop. How about a car, right? And a gyroscope there. What do you think that would show?
not not Earth curve, that's for sure.
Oh, I know for sure it won't show it, but that's a question for the ballers.
One of the easiest things is like the image it gives is a perfect mirror image. If there was a curvature or any deviation in the level of that water, when it has to be full of water, and it just, if you ever look at a building, like there's one in Valencia, it's a glass building. When you look at that glass building, you think, yeah, that's absolutely straight and it goes up vertical. But when the image is on there, because of the deviation of it, just, and it must be very slight because you've got glass panels and they're mirrored. And when you look at the actual image, it's so distort that it can't be, like it must be really, really slightly out. But
The image in your bathroom mirror is actually more distorted than the image of that water. If you blew your bathroom mirror that you think is flat, and when you look in it, you think this, but it's just flat, it shows no distortion. If you expanded it up to the size of one of them flat salt lakes when they got water on them, you would see like slight humps and everything because the mirror on your bathroom wall is that much more distorted than what that water is. But yet, when you look in your bathroom mirror, it looks flat. You don't see no distortions.
yeah, but what you're saying actually contradicts what actually happens, because when you go to the salt flats, there's no deviation in the image what you see on the water. So that what you just said contradicts what's actually in reality.
Oh, I can show you a picture of a curved mirror that looks that things in it look flat and straight.
Yeah,
I mean,
you can.
I got four of them on
I dare
my
say you
truck that I
can't.
drive.
You know, I'm sure you
The-
can, but it doesn't. You know, like we can post images all day long. It doesn't really, you know, give what's
Well,
what's reality.
Well, it does. It shows that you can have a curved piece of glass, a curved mirror that will still appear to show flat reflections, not distorted reflections. And
No.
if it's as
Well,
slightly
I tell you
curved,
what.
and if it's as slightly curved as the Earth, which is very slightly curved, it's curved less than, like I said, than your bathroom mirror, far less than the mirror on your vehicle. And yet we still see things in those mirrors as undistorted.
See what it was when I was looking at this building because I'm in construction, and I thought to myself, how comes that wouldn't show a perfect mirror image? And it's all this. You can see like palm trees; they're like stretchy and all skinny, because obviously the heat which is created is causing some effect as well. So you think when you're in salt flats and it's only a shallow bit of water when it fills up, and the heat, and it still doesn't give that distortion. So
Yeah,
what's going on? I don't know.
when it fills up, you don't have heat waves and stuff coming off of it like
Yeah,
you do
you
when
will
it's
have
dry.
heat because it's only shallow.
You may have heat, but you won't have like heat waves and stuff like when it's
Yeah, but
dry,
you'll
like
still
when you're
get
looking at
that.
dry sand.
You'll still have that sort of where it heats up. You'll have that kind of distortion, but it
Well,
doesn't.
well, flat or curved, that heat would cause a distortion, but we don't see that, so that's not really changing anything. I mean, if it was flat,
Well,
you and it has heat, you would still see it whether it's flat or curved. But what I'm saying is the curve is so shallow that it's not going to distort the image.
well, this curvature, this experiment which they done on, I think it's the salt flats. You're not. Oh, I can't remember how to pronounce it now, but it it's kind of, I don't know. They say it's an official one. It don't look very official when you start reading into it, but you can go and have a look at it. I think it was that, who's that guy from out South America, Max or whatever his name is. He come up with it. I think he's a very dishonest person.
What you guys are talking about is heat haze. Look at the picture.
Yeah,
Yeah.
it's where you got like water is shallow, and then the water heats up, and it gives that sort of, like when you look at the road and things like that, and you get that kind of I don't know how would you, just distortion from the heat.
Yep.
But curving mirrors, it's just ridiculous to say a curving mirror is gonna. I don't know.
Dude, you got like the mirrors on your vehicle are curved; they're not flat. I've got mirrors on my big truck that I run at work that are curved enough that you can easily see them curved. Yet when you look
What
through them,
happened
they're
with your
flat.
rocket the other day
You
then?
see an image, you don't see a distorted image.
What happened with the rocket the other day then? That must have blown any pushback
Even know what you're
completely
talking
out of the
about.
water.
Happened with the rocket the other day. I don't know. I must have missed it.
What is it called? Artemis.
Yeah, I must have missed it.
I don't know. I would have thought that would have just, you know, there you go. There's the curve of the Earth. They went.
Oh, they
They must.
did. They showed the curvatures multiple times.
I don't know. Maybe I was
There's
watching
a
the wrong one because what I saw is just not.
the if you look at my avatar, the image inside of my visor on my avatar here on Discord, that's an image from their trip coming back or going to the moon. They actually set their cameras and took a picture of the Earth in shadow, and they had to
Get out of
really
town.
adjust. They had to really adjust their shit. What do you call it? Their aperture, or whatever, to where they can pick up low levels of light, just to pick it up.
So on that NASA website, and they show things that weren't no simulation. It was like live pictures. Yeah, or am I got that wrong?
I mean, yeah, the ones that says they're live pictures, I assume, are live pictures. What do you mean? What are you getting at?
Right, they had cameras on the rocket, yeah.
Mm-hmm.
So they must be having a transmission uninterrupted of what they were seeing. Even the cameras, even if the cameras were looking at the rocket to make sure that bits weren't falling off it or something like that, they must have images of what was outside. Like even if you're looking at the rocket, there must be a bit, like you can see space or whatever it's.
Oh, they do. They did. They had images. They got all kinds of images where they're looking from the rocket. And you can see like part of the rocket in the side of the screen, and then you can see the background and and space and stuff in the other part of the screen. All kinds of them.
No turbulence whatsoever.
Why would you have turbulence in space?
I don't know. You tell me.
You wouldn't.
But when they was going to space, it was just like a steady Eddy. There was no like, I get in a plane. My God.
Dude, the thing is 300 foot tall. The craft is huge. What the little bit of like vibrations that it does, or the vibrations as it does, is not going to be very apparent compared to the size of the craft.
Would you have vibration on liftoff and going through the Earth's atmosphere?
You must
I would
have.
imagine. But what I'm saying is, when you're watching the
That'd be
video
cool
of
to
it,
see.
it might not be that apparent because the craft is so huge. The damn thing's like a battleship turned on its edge, turned upright. It's the size of it. It's enormous.
Yeah, but those rockets are putting out millions of pounds of thrust. Any camera
Yeah.
on that rocket, people inside are going to feel it.
Yeah,
And
oh
if
yeah,
you're
they
going
definitely
through,
feel it.
Do you know
if
what?
you're going
It would
through a
be
layer of
vibrating
atmosphere
so
that pulls
much.
in all its glory, right?
Yeah.
Escaping that, you're going to have some of that, and then coming back through as the shielding is keeping it from burning up. It's got to create a little friction there and some vibration.
Yeah, definitely. When they're going up to space, the Saturn V rocket, those astronauts talked about, said it was like being inside of a washing machine on or a dryer on tumble dry. They said it about beat you to death on the way up because of the vibrations and because the rocket engines on their bottom are steering back and forth trying to keep it going straight, and it creates an oscillation. They call it the pogo effect, and they have to do things to try to keep that effect from tearing the rocket apart because it can get so severe. And
That'd be cool. Hitting the water at 18 miles an hour, that'd be a pretty good video. Jolt of
yeah,
that.
coming back down, they say it's rough too when you're slowing back down in the atmosphere.
Any
Is there
videos
like
of that?
I don't know. I doubt they have any outside videos of them coming back through the atmosphere. They may have some once they pop their parachutes or once they got slowed down, but when they're burning through the atmosphere, I seriously doubt they got any cameras sticking out on the side taking video of it.
Yeah, but there must
How
be.
fast are they going when they're re-entering?
What, 25,000 miles per hour, something like that?
So from how high up is that? 80 miles?
Yeah, wherever they hit the atmosphere at, the carbon line.
So 80 miles up there, they're going 25,000 miles an hour. Deploy 2 or 3 of those initial shoots and slow down
No,
to a certain miles per hour.
no, they don't. They use the air to slow themselves down. That's why they burn. That's why they become a fireball. They're hitting those molecules so hard, coming in so fast that it turns to plasma. But that air slows them down. They don't pop their parachutes until they get well slowed down. They don't pop their parachutes. I think their parachutes don't pop until they're like 1,000 miles an hour or something. Way slower
The,
than
the
way.
initial parachutes don't come out, so the air slows them down from 25,000 miles an hour to 1,000 miles an hour.
Yeah, yeah.
Don't you
Let me get
think?
this straight. Capsule moving that weighs umpteen thousand, let's just say 1,000 pounds, comes through the
That's
atmosphere
not
at
even.
25,000 miles an hour, doesn't burn up because of shielding. I get it, right? But that slows them down to 1,000 miles an hour.
Yes. Have you ever stuck your hand outside of a car window while you're driving down the interstate at 70 miles an hour and felt how hard it pushes back against your hand? So if you can imagine a big old 25-foot wide round disc slamming into that air at 25,000 miles an hour, the G forces is like 5 or 6 G's that they experience because they're slowing down so hard that it's shoving them into the seats, and their backs are against the back wall that the heat shield is on. That way, all the force of them,
Yeah.
those G forces, is pushing them backwards, not down or up or any other direction. And they're slowing down so hard that it's like 5 or 6 G's they're pulling as they're coming through this atmosphere, slowing down, because it's basically a big barn door hitting thick air as it comes in. And
You also
even though
need
the
the
air's
paint.
staying high up, as it comes down, it gets thicker and thicker, and that air slows them down.
We also need the paint for the. We also need the paint that. We also need the paint that they use for their logos, because it goes to what 2,800 degrees and doesn't burn off.
They don't paint logos on the bottom of the craft.
No, it's on it. It's
They
on it
don't
though,
paint
right?
it on the. They don't paint it on the heat
So,
shield
so
part.
is it just the bottom that gets hot, or is the whole thing gets hot?
Yes. No, just the bottom.
What?
That's why it's made in a cone shape,
Well,
because all the heat bleeds off, but since it's made in a cone, it don't bleed back onto
so
the
what's the
cone.
temperature
It
on the
blows
sides?
off around it.
So what's the temperature on the sides?
I'm not sure. Have to look it up.
That speed profile is pretty awesome. Shoot, I'm talking.
I mean, I don't know where I would consider a low Earth orbit, but I don't necessarily think it's not possible, right? That doesn't, like, that don't bother me. But even the staunch space people like that I'm seeing on Facebook and whatever, they're like highly disappointed we don't have, you know, even us, we're saying continuous video, but in the past it's been, oh well, they're not going to do that for the flat earthers, or spend the money on 4K cameras to give these videos. It's not really expensive. I mean, I have a video system and a thing that records all motion, 24/7 on my boat and at my house, right? I mean, so if you're saying that NASA on the spacecraft that goes to the moon and back can't afford it, it's kind of weird. I don't really buy that. But I'm just wondering why there isn't more continuous live footage, that's clear and all that. For me, I kind of believe in that part of it. So it would be interesting for me to see them coming into the Earth's atmosphere and slowing down from 25,000 to 1,000 miles an hour.
Well, how would you see that? I mean, all it is a camera showing a metal craft get hot for a while and then cool back off. You ain't going to see it from a
I'm
third
talking about
party
the inside of
perspective.
the capsule, the
Oh,
inside of the astronauts, not
I'm
the
I- I'm
outside.
I'm sure that they like if they had 20 cameras on that thing, I'm sure that they recorded everything. NASA's probably got footage from every one of them nonstop. But
Yeah, but
I don't think you're ever going to see a nonstop video because it took like a week and a half to get there and come back. So I
No, I'm
mean,
talking about a certain section.
but
You would want a nonstop as you orbit the moon. You would want a nonstop as you orbit the Earth, and you would want a nonstop of the takeoff and then descent.
yeah,
On
I
a
don't know. They may
Cole,
release
what
them. I
about
don't
these
know.
amazing telescopes you've got, like the Hubble Bubble and the Huawei? How comes they didn't
Because
capture
they're
this?
not designed to capture things that close. They're designed to capture things out in space. But there were many people on Earth that tracked it all the way to the moon and back.
What, just amateur people?
Yeah.
Did you?
No.
Not shown. Name.
I don't. I wouldn't have had the first clue on how to do that.
But you must have a like a friend who done that and give you it. Oh, look, I got the capture. No?
No, it's just people that do that kind of stuff.
I must admit, I was looking for it, but I was only looking by eye. I didn't see anything.
Yeah, I've seen all kinds of footage from it.
No, I was looking myself. That's what I mean to say. I wasn't looking at like people
Oh, no,
posting
you
videos.
you wouldn't.
I was-
You're not going to see something that small that far away.
I thought for it being such a big rocket, maybe you'd see like, you know,
It
when you see
was.
shooting stars or something like that. I thought maybe you might see the tail of the rocket blasting through.
You would have if it would have been close enough to you, but I mean, it's only big when it lifts off. It after like 4 or 5 minutes, it's already separated down into its later stages, and they're much
Let me ask
smaller.
you a question. Do you feel elated or maybe a little bit disappointed with this mission?
I don't feel much of nothing. When they land on the moon, I'll be happy.
I would imagine this was the trailer. This is the pre. This is the trailer for the moon landing. Did we get enough gratification?
He was in love with that.
I even thought that was the when they got on stage and they was talking about their mission. Even the woman, she actually stopped at one point and thought. I would imagine what was going through her head was like, "Shit, I can't even believe I'm about to say this stuff," and just come out with the most nonsense. I was thinking, man, you've just been on the most amazing trip in the world. I would be out of my skin to describe what I just went through. It was kind of
Well,
disappointing,
they're
to say the
excited
least.
about it.
It was like a badly scripted.
They were definitely excited about it, about
Yeah,
going and coming back.
I don't know.
Like there's been they've been all kinds of interviews
So,
of them
yeah,
talking and everything.
not one. Holy shit! We were doing 25,000 miles an hour.
Well, there's a clip. You guys seen this one where the channel just reset. There's a clip of the Christina, not an astronaut person, and she said where she completely like lost her script and she like didn't know what else to say. Have you guys seen that?
It's brilliant. I was laughing my socks off when I see that.
Is that the
That's
one you're talking
amazing.
about?
Yeah, she just I think she came to the realization that what she was saying was absolute nonsense, and she just froze up.
It's like she forgot her lines. Yeah.
Yeah.
Elbow sent it to me. Here, this is it again. I actually
yeah.
just watched it. It's funny because I literally just put the live stream on mute and went and watched it. And I came back and I was like, "Are you guys actually talking about this?" When I happened to
Let's
just go
stream
watch
that.
it.
It'd be so funny.
You guys really believe that they faked all this to try to hide
Yeah,
the shape of the
100%.
Earth?
Bro, does any of that seems convincing to you, bro?
Worse,
Yeah, all
bro.
of it.
Believe in her or
Really?
no?
Yeah, they've been doing it for decades.
Yeah, I think this is minuscule. This is just business as usual. I was going to ask you earlier when the other guy was talking to you, but Cole, what percentage? I know it's going to be small. Would you think that it is fake?
None. Zero.
Are you? This is the one thing you're 100% sure of, bro.
Well,
That's
I ain't 100% sure of anything because I think we live in a simulation. But to me, I think that they
So it's
definitely
fake.
went.
So that therefore it's fake. I mean, if you believe it's
Well,
a simulation, then whatever they did was just definitely fake if it wasn't real.
well,
Oh,
it's
they're just
real in
simulating a.
it's real in
It's,
our world. It's real in our
no, it's,
reality.
it's simulated if you think we're in a simulation.
It can, yes, but it's still real in
Oh,
our
NASA has the
reality
cheat codes.
because in this simulation, reality is
wait.
real to us. So it's real in our
Give me one.
simulation.
I think I'm misunderstanding again, and it could be right. My brain is small. You think the entire world and all human society is a simulation, but you don't think they can simulate going to the moon?
Yes, I don't think that humans simulated going to the moon.
Okay, okay. I've lost all hope.
Okay, good.
I mean, you get what I'm saying, right?
Not really.
To put the cat amongst the pigeons, watch that video, Cole. I'm sure you're gonna have doubt creep into your thoughts.
No, I won't.
You will.
What
She's
what
just so.
what Rakia is saying is, you believe a whole entire existence is simulated, but they won't be able to simulate going to space.
I didn't say they wouldn't be able to. I said I don't think that they did.
So it's real within the simulation.
Yes. Our reality is real to us. Even if we're in a simulation, our reality is still real to us. And I think they
So
I think they really did exactly what they said they did.
I mean,
you get
at
what
this point, it wouldn't even matter. Go ahead. Sorry.
That's your
someone's able
opinion.
to simulate our reality, but in our reality, no one can simulate going to the moon. That's
Again, I did not say they can't. I said I don't think they did. Big
right. But
difference.
I asked you what doubt you had, and you said you're 100%.
Yeah. I don't think
Yeah,
I don't think a bit that it was fake.
bro.
But I said I'm not 100% sure about anything because I think that there's a good possibility we live in a simulation.
So you're not 100%, but you're not 100% about anything, but you are 100% they didn't fake it. Is
No, I
that what
didn't
you
Yeah.
say that. No, I didn't say that. I said I just specifically said I'm not 100% about anything. But I do think in our reality, I believe that they really went.
Right, but he asked you what was the percentage you faked it, and you said 0, which means you're 100% they didn't. So now you are 100%.
Well,
I think
99.9999. There you go.
that's outrageous. That might be the most outrageous thing I've ever heard in my life.
That's the parachute, just in case you were wrong.
Gio, am I off here? Like I might be misunderstanding. I give because I think Cole is like, whatever.
Did you simulate a fake mission? Yeah.
I have to be thinking about this wrong because if not, it is by far the most outrageous thing I've ever heard someone say.
What, that they're 100% sure?
No, that they live with their reality is living within a simulation, which means someone or something is creating all this as a simulation. But in that reality, people can't simulate going to the moon.
Again, I did not say they can't. How many times are you going to keep repeating something I did not say?
So they could have faked the whole thing then, Cole?
Yes, I'm not saying they can't do it. I said I don't think that they did fake it.
Well, just take it as that what I get what you're saying. So however I say it, I'm not trying to, misrepresent you. But no matter how you're saying it, it's very strange to me.
Yeah, but I think what he might mean is like, okay, you'd have to ask him what he exactly means by a simulation. But let's say some kind of philosophy or idea that all of this whole world is some kind of a simulation of some sort of being a human, and all of this. But within that simulation, it could be said that there are things that are still real. Like if I go get in my car and I drive to the store, that's
It's real to
real
us.
within the simulation. That's how the simulation is working. So I think he's just saying in the same way that like the whole world could be a simulation, but I can still go get in my car. Maybe someone gets in a car accident, they break a bone. Like that's all happening in the simulation. So I think what he's saying is that in that light, he thinks these astronauts got in a rocket and flew 250,000 miles and went around a rock in the sky and came back in the simulation. That
It's real to us.
it's
Yes.
real.
I
How
get
did
that.
the
Gio
sorry, go
said
right
it
ahead.
exactly correct. Exactly what I'm
Go ahead,
trying to
Ricky.
say.
And I'm on the same page. I get everything that Gio just said. And if that represent you, I got you the first time. What I don't get is how you believe that there's no percentage that they're faking it. Because if we're capable of faking it, you would have to come up with some percentage. Like even I think there's a percentage that it might be a sphere, right? Or that the moon landings might be real. And I just don't say 99, I'm 99.9% sure that it's not real. I don't say that. I mean that's
Well,
just like
if I believe something really happened, I believe it really happened, and I've watched enough of it to believe it really happened.
yeah, but you live in this deceiving world. You have to have people around you that's deceived you. You have to have heard the news where there's deception. I mean, National Geographic has deceived you. There's all types of different agencies and things that are deceiving. Like the CIA deceives the Congress. They lie to the president. You understand what I'm saying? There's deception in almost everything we do. Like every man has lied before. You've lied. You've deceived, right? And to say that they couldn't be making it up to deceive you, there's 99.9% chance that you believe it. I don't know, bro.
Yeah, but I didn't say they couldn't. I said I don't
You know,
think they are. I know what you're saying though, but I just don't. I've watched enough of it to where I just don't think that they're faking it. I think they're telling the truth about what they said.
Where they going?
I get it. All right, cool. I mean, I respect people that stand on their grounds. Like there's nothing to it. I don't like people trolling me, but someone who believes in whatever they believe, everybody's on their own walk, right? I teach that, so I'm not against it. It's just strange for someone who you know can reason through a lot of things and see all this complicated, astrophysics, and you have a good grasp on a lot of things, right? To not believe, just blindly believe that it's true, or take all the evidence you've gathered and it can't be any other way. You're 99.9% sure it's true.
You just can't. You just can't understand how somebody could think that way, can you? That's
So
fine.
you're 99.9% sure the government is not lying in this case? Because they are the government ultimately.
Yeah, I mean, I believe that NASA's telling the truth.
So you trust
I wouldn't bet my kids' lives on it, but I wouldn't do that on anything, because if I'm wrong, then, you know. But as far as saying, do I believe it? Like, if you just ask me, do I believe it? Yes, I believe it. The percentage don't really matter anyway. It's just whether you believe it or not. And yeah, I believe it.
I don't think that's true either. I can be 60% on some things and 80% on the other. That's a huge difference.
Well, that's true. I guess I shouldn't have said it that way. You're telling the truth because
Rakia, what
percentage.
percentage do you think that they actually took that trip and went 250,000 miles and circled around a big ball in space?
Oh, it would be, I'm probably 80-20. 80 that they didn't, 20 that they did. I really bet, you have to understand though, I'm that high because of my faith is in what I believe my interpretation of the book that supports my faith is that man can't ascend to the moon. Like the Tower of Babel trying to ascend into the heavens. And it tells me that the moon is in the heavens. So that adds up to man can't go to the moon. So that's where, I would put some of my percentage in my faith base. And then knowing that these agencies are capable of deceiving and do deceive often, like I don't know any agency or I don't know any man that doesn't lie, right? Like it's not, I don't think it's possible.
That's fine.
So
It's totally fine that you believe that way. I accept, I accept that completely.
I can see why they would do it, right? Like if they had good intentions in the beginning, back in '69 or whatever, or before then, they started the space race, and they had good intentions, and they thought they could go, and then they figured out they couldn't, but they were already getting funding from Congress, and they're supporting their black budget stuff in their own pockets with these things, and it drives the economy. You take away the government, NASA, and things like that, you talk about depression. The country's economy would fail. It's a huge part of our economy, our way of living, it's also our way of life. I mean, if people found out that NASA was a deception, who would go fight for this country? Who would go, support all the other stuff that they, or there's truth and lies and everything, right? So I believe, I don't want to put words in your mouth, but I think we're grown enough men to figure out that we're not being, they tell us they're lying to us. They don't even hide it anymore. They're like, you're not smart enough to be able to handle this. We don't trust you in this way, right? We keep things from you. We black ink things because we don't want the American public to know. Hell, they buried the Epstein files on the moon. Did you know? I got a meme of it. I got them digging the hole. I mean, what I'm saying? Come on, man.
I wouldn't doubt it. I doubt that a bit.
It's just so strange, bro. I don't
So
know.
as well, it's that just quickly. Extraordinary claims demand extraordinary evidence. So I just haven't seen any extraordinary evidence from this
They went
mission.
to the moon.
We've they fire a rocket off the ground. Well, they've been doing that for decades. That's not extraordinary. They got one coming back to land. They've done that for decades. That's not extraordinary. We've seen some pictures on a screen, but we've seen that from Hollywood. We've seen representation of NASA's mission control in Hollywood movies. There's nothing extraordinary about that there. I've seen movie astronauts give better interviews than the real astronauts. So Cole, what's the extraordinary evidence that would support the extraordinary claim that we've just gone all the way around the moon?
I would say all of the evidence put together, all of the video and everything. Just because it wasn't enough for you, don't mean it wasn't enough.
Man, that's fine. Like Dave said, that's fine. If it's enough for you, that's all good. We've all got a different level of convincibility or a journey to walk or whatever. But that's just explaining my position. I would want to see something like if they set up a motel on the moon that I can go and buy a ticket and stay there for a week. Well, that'll prove it to me. But outside of that, I'm not sure what will.
Right. Well,
Have you
they
seen the
might be working on it. Have a what?
Sandra Bullock and all the Martian and all the other movies where they're floating around in the capsules and doing all that, and to say it couldn't be, like it's easily done. It's not even
Again. I've never once said they couldn't fake it.
Okay, so maybe I asked the wrong question. So, what percentage do you think they could fake it?
That's God way up there if they really wanted to spend the money to fake it.
Okay, do you know of any reasons why they would?
Why they would?
Yeah, why would, let's say it's all fake, right? Hypothetically. Why would NASA stay being a program and launch rockets in the name of science? But the deception part is that they can't get to the moon or to outer space. They can let's just say they can only go to low Earth orbit. Where the ISS is. ISS, they can launch rockets and go land on it and come back and forth and do all that. They just can't go to the moon. Why would you think they would say they're going there or doing that? Is there any reason?
None that I can think of. I mean, to me, if they had to go as far as faking it, they'd just not go. I can't see no reason right now why they would. Now in the '60s, they sort of had a reason. You had more of a reason to say they might have faked it back then because of the Cold War and stuff and the
What kept them
so-called
from faking going to Mars
space
and just being
race.
done with it? Like, if they were gonna fake something we haven't done before.
You can't think of that one reason.
I don't know. Yeah, you can't think of one. That's strange to me. I mean, I don't know. I just don't. I don't know.
Not nowadays,
I guess I'm
because
different.
nowadays it's just like, what would they get out of it? I can't even really see what they're getting out of it going.
$80 million a day.
You realize it's not a group of like 4 old guys in a dark room that's just raking in $80 million a day. You realize that's not how it works at all, right?
Yeah, for sure. I know.
NASA don't get
They were.
80 million by it's a couple guys in a room somewhere that's raking all this money. And this money
How
gets
many do you
divided
think they
up
are?
amongst hundreds of different universities and places where they do like research and development and factories that actually make the parts and stuff that they need. Like this money gets divided up a lot.
I know. But
Yeah,
as
I mean,
Rakia said, if you pull the pin on that, Cole, if you pulled the pin on that, what would be the implosion effect of that $80 million a day being ripped out of the US economy?
Well,
It'd be significant, bro.
And
yeah, but here's the thing:
And
every country around the earth that ever starts a space industry sees an actual increase to their economy. So they may spend 80 million a day, but they get back more than they put in just by having a space agency. It pays dividends.
They print money.
Well, how does that work?
Because it
You
employs
spend
so
money
many
to make money?
yes, you always spend money to make money. Do you not know anything about business?
How many people
It
do you think they
employs
employ?
people?
It employs tens and tens of thousands of people if you add up everybody and all the factories, all the scientists, all the people in all of the education systems,
19,000
everybody, and they're
people.
all getting a little chunk out of this big chunk of money the government's giving.
90,000 people. That's all
And
they employ.
they all pay taxes in. All the businesses
Okay,
that are
okay.
involved paid huge amounts of taxes in. It's
Your bridges are
the way it
falling
is.
apart, bro. Your plumbing
Every
sections are falling apart. Your water infrastructure is very poor, and you're like, no, space makes money.
no,
So does that mean that like water treatment plants also make money as well in the same scheme?
no, it means that you
How
can
does
look
that
at the numbers. Every country around the world that puts a space agency in sees a boost to their economy from it. All of them.
19,000
Your
people. So
every country
your
that
premise would
fakes
be
a
that
space
any
agency.
industry
Yes,
would do that.
19,000 for NASA. That's not 19,000 for everybody that has something to do with that money that NASA gets.
You keep
Because
giving more and
it's
more reasons
loaded
of why
with contractors and subcontractors. Go ahead. I'm sorry, I didn't mean to talk over you.
which is another reason they would fake it to keep it going and keep all that economy, boosted.
Now you
You
can
just
say
gave
that.
the
That's
reason.
a good example. Yeah, that would be a good
You
example.
just said it. Yeah. So don't ever say you don't have a reason. They would lie to us to help the economy.
So
Yeah.
there you go. You come up with a good example of why they
Well,
would
no, I
lie.
didn't ever say I couldn't. You the one said you couldn't think of one.
I know
Like
I
it's
couldn't,
weird,
but
right?
I couldn't, but you come up with a good one. So there you go. I agree
But you
with you.
came
It's
up
a
with a
good
call.
example.
You pat yourself on the back, mate. You found it.
Do what?
Oh man.
Well, I mean, dude,
I didn't.
people. Go ahead.
Well, I just don't think people are that naive, right? Like I guess I give more credit to people just having more I'm not trying to insult, but common sense of that, you know, the possibility of being deceived by the person on the street or your employer or even your
But
mom and dad basically is there, right? Like,
but
much less someone who.
I feel like you've been deceived by flat Earth and by all the things that you've seen that makes you disagree with it. That's what I feel like you've been deceived by.
I would have to be deceiving myself. I mean, I agree
Yeah.
with you to a certain extent. Like, if I didn't do the measurements and do all the observations and stuff that I've done, flying drones and doing the gyroscope stuff and all that myself, and I just blindly believe somebody that I know could possibly be deceiving me, I get your point. But I'm not that guy.
Yeah, that's really cool to hear that you have done all that stuff. That's awesome.
Right. So I'm not deceiving myself. I mean, either the earth is flat or it does a really good job at deceiving me. Well, it
Or
doesn't deceive.
you may have fell for a lie that you don't realize has deceived you, and now you're still believing it, even though you don't
Okay.
realize it.
Okay, but that shows
Same way you're looking at me though. It's just in the
right.
opposite direction.
The only difference is you say you're 99 point, you probably say you're 100% sure on spherical Earth. And I say, no, I'm probably 80-20. I can see, and believe me, tomorrow, if someone shows me a way to make a horizontal over static water, measure down to that water and it's curving, I'm a glober. All that bullshit about measuring angles to the lights in the sky that are billions of miles away, and then explaining to me how the light gets to me in a year or two, and all this bullshit. Like, no, that doesn't do it for me. Sorry. I think that's how you were deceived. I think that's how I was deceived. I can see how they took perspective out of taking angle measurements to the North Star, and instead of getting 1 degree per 69 miles as you move away from the North Star, they say that's not the reason it appears to go down in your vision. The reason is you're on an Earth. Oh, by the way, the 69 times 360 is the radius or whatever it is of the Earth. It doesn't make sense to me, bro. I mean, I can see it both ways, but now that I've done all the measurements that I can, as accurate as I can, it doesn't curve until I'm shown different. I just don't trust and I definitely don't trust all the sky stuff because no one's going there.
It's fine. We just got two different ways of believing.
You said earlier these theodolites are pointed towards each other and showing that they go over each other's head, proving that we live on a curved surface. So you're acknowledging that those theodolites make a straight enough horizontal line to measure curved water.
What it shows is verticals are not the same at different points. Deviation.
Yeah, what it shows is that when you look to an optic long distance, especially low level over water like that, what you're talking about is the only one I know of is over a lake.
No.
At the shoreline, so low level.
Both of the ones I'm talking about were done high elevation from mountaintops.
Oh, so the mountaintop is lower than. I mean, I get it, right?
Quite a bit less refraction, less disturbance.
Yeah, quite a bit less. Based on what?
Based on the thickness and the temperature and the turbulence of the air.
Come on, man. And on other days, it's not. I mean, we've gone through
That's
this.
a fair argument. I'm not going to try to, I'm just saying that that's, to me, just more evidence that makes me feel like my side is correct. But it's fine if you don't believe it.
So discord the fact that the shorter the measurement, in especially in this case, to an optic, right, the more accurate it's going to be. I have posts that I took pictures of the other night when I was talking to John that was talking about theodolites and stuff being less accurate, because of turbulence and refraction and all this, like at 500 feet.
Look, man, I respect the way what you believe and everything else. I'm not saying that I'm correct. I'm just saying that's what I believe. It's what I think. You know what I mean? So it's not like I'm trying to say I'm right and you're wrong and you're dumb or anything like that. I'm just saying that's what I believe, and you believe what you believe. But I'm not trying to say you're wrong and I'm right. So you don't have to get like, so confused about it. That's not what I'm saying. I'm just saying
Yeah,
that that's, we just got different beliefs.
yeah.
Bless your heart, Cole.
Well, I'm getting ready to get off here and I don't want to leave a big argument. I gotta get into bed though. I gotta get some sleep. I gotta get up in the
Wait,
morning.
before you go, can I ask you? I thought you've said in the past that you think SpaceX has faked certain space things. So the question
Yeah,
is,
seems like it.
then why did they fake it? If you said you couldn't think of a reason why NASA would, what are the reasons that you think SpaceX faked space?
Because SpaceX is wanting to keep that money rolling in. I feel like Elon Musk knows that the Starship will never be a moon lander, or definitely never go to Mars. I feel like he knows he realized that not long after they began to develop the Starship, but they'd already sunk so much money into it they didn't want to change their designs. I think all he's out for is he's using the government's money. He's getting it through NASA to just build himself a large satellite launcher so he can launch his internet satellites. He can launch bigger ones and more at a time. It's all about him making money off of this big satellite thing, internet thing he's got going on. And I think that he realized it not long after they started building the thing. He realized that this is a horrible design to get to the moon, but instead of changing it, he just went along with it so that he can get money and to develop himself a large satellite launcher that he can use to make his own self money. And I think that he'll do whatever it takes to keep that going. So that's why I think that he would, fake things and do different things. He has a very big incentive to do so.
You know that's what the NASA did with the space shuttle, right? That was supposed to be a moneymaker, and it ended up being a huge fail.
Yeah, it's a money
Probably,
pit.
but they wanted to keep it going, right? Because they employed so many people, the economy. They
Misfits.
probably got pressure
Go ahead.
from the top. Wouldn't you think they would get pressure from those who stuck their necks out on the line? Hey, we're going to start this space thing, and give you all this budget, and then it failed. They just look like assholes, right? Like
Well, it didn't
that's how the
fail. It flew like 175 missions. It put the Hubble Space Telescope up. It serviced several satellites. It took people to the ISS for 30 years. It built the ISS. It they used it as a portable space station because that's basically what it was. It was its own little space station. It was big enough for people to sleep on and spend weeks at a time on and everything else, move around on. So it wasn't a failure. It was just astronomically more expensive than they thought it was going to be. So in that line of thinking, it was a failure. It wasn't. It didn't make space travel cheaper like they thought. It failed to do that, but it accomplished a lot of things.
They scrapped it.
Yeah, after 30 years of constant use.
Can I just ask real quick? So apparently SpaceX are the ones that are making the lunar lander for the Artemis 4 or whatever they claim they're going to land on the moon.
Yeah.
So then your view would be that a guy who built a company, Elon Musk, who has faked space, is who NASA is hiring to do it for real. They're hiring a guy who fakes space, in your view, to go do it for real.
He got it very, very strangely. The woman that was the head of NASA signed his $2 billion contract and awarded SpaceX the contract over top of Blue Origin. And literally, I'm not even lying about this. It was like the very next day she quit NASA and went to work for SpaceX as the head of SpaceX. So she literally awarded SpaceX the contract and give them $2 billion and then left the people that was picking between SpaceX and went and worked for him. So it was sort of give to Elon Musk not very fairly. It was handed over to him by someone who was like a troll on the inside that was working for SpaceX the whole time.
Shadiness. You're describing the shadiness at NASA that we're describing.
Yeah.
This lady awards a massive contract that comes out of the taxpayers' pockets and then leaves NASA and goes and works for SpaceX.
SpaceX. Yeah, I'm saying if they would have had somebody there running NASA who would have been all about NASA and not been just all about money, SpaceX would have never won that contract because they have a dumb design for a moon lander.
Don't you think, Cole, like if that was the case and there was some impropriety there and some shady deal, the government would, or NASA would have some sort of a clawback clause in the contract. It wouldn't just be, oh well, there's $2 billion. Oh damn, Julie really fucked us over.
It really happened. She really did that. She really picked SpaceX. She really awarded, and then she really quit and went and worked for them like the next day.
That's the story. That's the story. I'm just saying. They're not going to give $2 billion away. Go, oh, fuck, Julie really did us a wrong there. Oh well, move on. No foul, no harm, no foul. $2 billion. I think they might try and get some back. Or
I think
something.
I think a lot of them believed it. A lot of the higher ups at NASA really fell for the whole SpaceX thing. I think they really fell for it. But that's why, just like the guy Smarter Every Day, Destin done that big talk in front of all the heads at NASA, and he straight out told him, he said, look, he broke it down just how crappy of a moon lander SpaceX craft was. He talked about, all the things that he sees that they're doing wrong that is obvious. And he told him, he said, you guys really need to stop and take a look at what, you've allowed to go on.
So NASA got deceived?
I think they fell for a good con man.
Deceived.
Yeah, I think a lot of them were deceived.
What's so wrong about his moonlander?
Because it's shaped like a paper towel, like the inside of a paper towel roll, and that's the worst shape to land on an uneven, rocky surface that you don't have a very, very good map of the ground of. Yeah, they've mapped the moon, but down to the inch to where they know if they land something that's literally like a really tall grain silo. If one leg lands on a large boulder, the thing will turn over. If it lands on a slope, it's going to turn over. It's just a bad design.
And the people who designed it, you think they would have.
Sorry, go ahead on.
It's just quick. Cole, do you not think like the people designing a lunar lander would not be aware of the topography of the surface they were going to land on to not build such a rat shit design?
No, what I think is they started out building it and they had this whole idea they was going to land vertically, but just like a lot of Elon Musk things that he does, he don't realize just how hard things are going to be. Just like in 2018, he said we would have driving cars that would drive all the way across America on their own by 2020. He said that we would have robots walking around washing our dishes and stuff by 2022. He said by 2022, in 2018, he said by 2022 he's going to be landing starships on Mars. He makes all these claims, and I think that he pushed this whole idea of a vertical lander, a gigantic vertical landing rocket on the moon. But after they started building it, like I said a while ago, they realized it was a very bad design, and I think that he didn't back out. He continued because he's wanting to build himself a satellite launcher. He's using it for his own good. He ain't worried about going to the moon.
I ain't gonna lie. I think Elon kicks NASA's ass on design. So saying that his design, if Elon would have designed the launcher and they said that landed on the moon, and I saw the video, I probably would have convinced me more than that stupid bullshit. Apollo 11 lander.
Yeah. Sorry you think that way.
I think the whole lot of them are deceivers.
100%.
It's not a hard concept.
I just posted it, y'all.
A low profile.
It's more reasonable.
A low profile flat craft with wide legs is much, much more safe, especially if you're sending humans, which something has to be human rated, which means it's very difficult to get it human rated because they're so strict. If something very tall and thin is way more unstable and likely to turn over by
doesn't matter.
magnitudes more than something
It's like
global.
there's barely any gravity up there. So what would it matter?
It matters a lot. Things still turn over, dude. What are you talking about? You think things don't turn over because you're in 1/6 gravity?
The lunar lander can land. That spaceship where he's saying that definitely would be able to land.
Believe it.
Nicole, I'm struggling to understand how NASA, in this $2 billion whatever contract with SpaceX, number one, they would have had amount of due diligence up front. What are you going to do? How's it designed? How's it going to work? Okay, that all looks feasible on paper. Then they would have had progressive milestones to how's it going? Where are we up to? It'd be a progressive drawdown. It wouldn't just be here's $2 billion, go and have fun. Like
you would think so.
Yeah, well, I
But
would.
again,
I've been in business a long time. That's how it works.
yes. But again, that's why the Devin, the engineer that they invited, all the tops of NASA invited him to give a speech in front of all of them. That's why he broke it down just how bad of a design it was. And he said, those of you who have realized that this is not the way you need to be going, this is not something that you should keep going along with. Said you need to say something. You need to say, hey, all these doubts that we all have in our mind, but we're all holding back because we don't want to be the one to speak up and say this is a dumb design. We need to start speaking up and say, hey, this is not going to work. He broke it down very good. I mean, it's worth a watch if you've never watched it. Just what he said to the heads of NASA who invited him there to give that speech.
But surely there would have been
chat.
competing companies in the tender. I don't know who, Raytheon or Boeing or bloody Jeff Bezos or somebody.
Yeah, Blue
They would have
Origin
all been competing, and they wouldn't. The competitors would have said, "That's a shit design.
They
Don't do
did.
that." Or the
Blue Origin was
so
the people competing against the Blue Origin sued NASA because of it.
Sued NASA because Blue Origin can't even do anything at the moment. I don't know.
Blue Origin developed a lot of stuff. They even had
He developed a
a
flying
nice
penis.
moonlander developed already. It's called the Blue Moon, if I'm not mistaken.
Blue Origin versus SpaceX. There's no question talking about.
Here, I'll post this. This is the video I'm talking about. Right.
So Nicole, are you concerned, like trying to put myself in the shoes of your how you view this? Are you then concerned that NASA hired who you were saying is a deceiver and a greedy, money grubbing deceiver man, of Elon Musk with SpaceX to be the entire dependent factor of landing on the moon in Artemis 4 is what they're claiming. So are you concerned that they're hiring a deceiver?
Yeah, I think that it'll never happen. I think when the time comes that it'll never happen. They'll realize when the time comes they spend a load of money on a company who cannot do what it says it's going to do. And I just want to say whoever posted donk or whatever, this is why you shouldn't listen to memes. It says why not a moon helicopter? Elon Musk can do that on Mars. Elon Musk didn't put the helicopter on Mars. It was NASA, and they used the that company in California that builds a lot of their satellites and stuff. They built the helicopter. Elon Musk had absolutely zero to do with the lunar probe or the helicopter. But yeah, I think when the time comes, Jill, like by this point, as long as they've been working on it, they're still trying to launch up. They can't even hardly get into a good stable orbit with the Starship. They consider getting into a partially stable orbit, deorbiting once they get halfway around the planet or 3/4 away around the planet, opening up a little tiny cargo bay door, which shouldn't be an achievement at all. We've been doing that for the last 70 years. Um, Little things like that they're calling achievements. They still don't have no concept of a craft with a cockpit for the astronauts to ride in. They have no concept of a craft with engines that can relight and come back off the moon and lift back up into, they like there's all these things. They're still in diapers where at this moment they should be, running and jumping and stuff, but they're still crawling in diapers. They're so far behind, it's embarrassing at this point in time. They started working on the SLS, the orange rocket, after Elon. I think after Elon Musk started working on the Starship, or somewhere right around the same time. The SLS just went around the moon with 4 people. The Starship is barely making its way into orbit right now. Yeah, it can come down and land vertically, but what good does that do if you have no cockpit? You can't show that you can get into a complete orbit. You haven't proven you're able to dock and transfer fuel. You haven't proven that your engines can be relit multiple times in space. None of the things that have to be shown and have to be shown to be very safe and reliable haven't even been developed yet. They're incredibly far behind.
Used to think we're going to the moon. That's just hilarious.
But I gotta jump off here. I have to get up here. I gotta go to bed. I gotta get up in the morning. I've already stayed up way later than I should have.
See you later, Cole. You're a good sport.
Yeah, I always like to have a good little argument back and forth. I think it's good for the blood pressure.
Go and get some sleep, man.
Yeah, I'll catch you guys later.
See ya.
No hard feelings, Gio.
Oh, you looked it up, Cyrus?
What?
Did you look up the last thing we were talking about?
No, I've been busy, man. I will do. Sips. I heard what Trump said. People are rushing here to buy our oil or whatever.
Yeah,
That I
everything's
saw.
getting redirected over here, and then they blockade the blockade.
Yeah. That's
Sounds great for the gas prices. Sounds phenomenal. Shit, man. It's not good.
That'd be a global energy shift, man. If the U.S. all of a sudden gets more of that business.
I don't know, man. You think like countries like India, they're gonna come all the way over here? It's quite the distance. Or maybe China and Russia will team up to open up the blockade for themselves.
Yeah, well, that would have to go through us then. Now, and that would definitely start a definite.
I mean, let's say Japan. They were paying the toll in yuan, right? They're our allies. I mean, and we said we're just gonna blockade all ships, even if they pay the toll. So how the fuck does that work? Same with India. They were paying
Japan is
the
starting to diversify their shit. They're starting to go away from the Middle East and increasing their oil purchase in the U.S.
We'll see how that works out, man. I don't think it's good for my pocket.
Why do you think? I mean, it makes sense now if you think about it. Why he was so adamant about Panama Canal, Venezuela, and Cuba.
Oh yeah,
it makes
because
sense.
we're gonna light up the Middle East. I already knew that. Come on, man. Of course, we secured the oil for the It's for the military, though. It's not for you, the peasant.
Of course,
like it's for the machine. It's for the machine.
For the
peasant's
industrial
paying
machine.
$5 a gallon. Oh, and it's gonna go up to what? $10 a gallon now? I don't know, man. Not
I
looking
don't
good.
know.
We'll see. I don't know, man. Maybe we'll see what China does. What kind of moves China does. They might do something in their favor. Don't know. Did you hear about the word on the street where they were actually trying to rob the uranium? You know, and that's why the F-15 pilot went down. Yeah, because there was more than 100 special forces on the ground. 2 C-130s we lost. Do you know about that? They got stuck in the sand. That's the official report. So we torched them. But we lost 2 C-130s in that nobody was really talking about. And because of the amount of soldiers we had on the ground, it's about 50 kilometers from Isfahan, that facility, right, for refining uranium. Some people are speculating this was a failed uranium heist because how many troops we had on the ground, especially when you compare it to same thing happened in Vietnam, and lost a pilot and whatnot. And for a couple of weeks, and then when we recovered them, it was 2 men. That's what a quiet operation is, right? 2 guys go in quietly, exfil. Boom. But yeah, 100 guys is not fucking quiet. It's a lot. 100 special forces is a lot. It's like, what are you doing? That's what people were speculating. Word on the street, I don't know.
All right. So the Iranians are saying that there was a few US C-130s.
Oh, it's
Destroyed
not
along
the
with the
Iranians. We confirmed that shit. Yeah, they ain't. So what we said, they got stuck in the sand. We used the runway over there to recover the pilot. I forgot what was it? Like a farm runway or some shit, or an old air base. I forgot what it was. You can look that up. Where the C-130s got stuck in the sand. That's what they say. From the footage, people analyzed the wreckage and you know how they look like they were shielding each other. And in the wreckage, there was evidence for small arms fire, bullet holes. So I don't think the official narrative is adding up. But we said it got stuck in the sand, so we torched them. That's the official story from like CENTCOM.
I heard Tom Cruise went in and jacked a F-14 and got the pilot out safely that way.
Yeah, they sent Bruce Willis along with them too.
Yeah, they made a documentary called it, I don't know, Maverick or something. I don't know. It was like a
I'm sure they'll make a movie about this one, man, for sure.
Yeah.
And you know it's bullshit because if they were serious, they would have sent Jason Statham, not Tom Cruise. So you know it's not true.
There you go. There you go. Yeah, Lindsey Graham, your boy Lindsey Graham, Elbow. He said, yeah, Iran is going to have to either give up the uranium or we're going to have to take it from them. So you just can't have that, their own uranium.
Yeah. I mean, they're definitely adamant about that.
Yeah. There you go, Elbow. Dow futures dropped by 500 points. That's what's up. See what I'm saying? It's a negative effect from my pocket.
Temporary, man. That's usually the time to buy it more.
Bro, you crazy? What do you mean? Hell no. So not the way it's going. I'm on a craft where, I mean, if anything, yeah, I'm buy stock in like Lockheed or something. That's evil. I don't do that. But with the shortage of petroleum, I mean, any industry that relies on it, I'm not trying to put my money in there. It's gonna go down. Why would it go up?
I mean, it went down for 100, but it's in the 5-day period. It's been.
That's the futures. It's gonna open. It's gonna open tomorrow, right? This is just the futures dropped by 500. Tomorrow, really find out what's gonna happen. So I'll give you the headlines if you want. It's mainstream. CNBC. State media, you know, state sponsored media. It's like, yeah, another what, 25 years of this shit, like Iraq, but this is Iran. So what? Multiplied by 2 or 3. What, 75 years of this horse shit, paying $10 a gallon. Or what? Yeah, don't worry, it'll go up, man.
I don't think it's gonna last that long.
What do you mean? Why not?
I don't even think it's even
Iraq